Hi everyone, and welcome to the IBM Developer Twitch stream live from Think 2019. We are on the West Coast. We're in San Francisco. If you're looking at the weather, it's a little wet, but that is fine. We are dry here in the studio. So this is day 2. We had day 1 yesterday. We had a lot of people come on. I'm going to give you a little preview of what we're going into. As we talked about a lot yesterday, they announced Call for Code 2019 at some point during this conference. And so what that is it's just the same thing as Call for Code last year, which is a large distributed hackathon. And it's all part of an umbrella project called Code and Response, also out of IBM. And with Call for Code, what you can do is you can put a team together, and you can sort of work using technology, using the IBM Cloud, to work on some of the harder problems in, broadly speaking, natural disaster recovery, natural disaster prevention, human life, and stuff like that. Ruby Bushy X is asking about the drones. Okay, so I don't know if you got a drone or not. If you did get a drone, that's awesome. If you won, you should have a drone now. If you don't, DM the IBM developer account, and we will start an email thread to get you your drone. As for the live streams, most of the team has been pretty focused on this conference, which is 2019 Think in San Francisco. But John Wallachy, I think 2 weeks ago, did a stream specifically for like, what are we going to build next with the drones? And I'm sure Wallachy will come on at some point, on kind of our regular Friday streams to do more drone stuff. And if there's an active interest in more drones, that's not a problem at all for us to get more drone content. I personally sort of felt like we maybe hit the drones like we're too hard, but if there's an active interest, like we're happy to do it. No problem with that. Great question, R Bushy X. Thanks for joining the stream, by the way. So what we're gonna kick things off with to begin with is the Call for Code winners from 2018 from last year. So we're actually gonna bring Dan Crook and Kevin Allen, who are sort of the brains behind the project inside IBM, to talk about the 2019 experience. And then we're going to have the winners, which was Project OWL or Project OWL, which is not an overloaded term on Twitch or anything. No problems there. We're going to bring Project OWL on the stream, and we'll kind of talk to them about their solution, what they built, and how they felt about the hackathon. That'll be really cool. Then what we're going to do is we're going to have another guest from Red Hat. So we're going to have Saran and Dan, who are the brains behind both the Magical Living Room and the Command Line Heroes podcast. So if you're a podcast person, I'm not entirely sure what the overlap between podcast people and Twitch stream people is, but if you're a podcast person, the Command Line Heroes podcast has really taken a pretty strong place in software engineering podcasts. I mean, they look at open source broadly, they look at specific open source projects, they talk about users and devs. Saran is sort of the brains behind that, and it'll be really interesting to have her on to talk about that. Then we're going to kind of, that takes us till about 11:30 Pacific time, which is about 2 hours from now. And at that point, we're sort of going to head into kind of a pretty heavy blockchain component. So we're going to have Horia on to talk about Hyperledger 1.4 and like the basic ways you put out a kind of some network and chain code onto a blockchain. And then we're going to have Swetha Rapuka come on, and she's going to talk about, the title of the talk is Deploying Ethereum Smart Contracts to Hyperledger Fabric. And so what that means is you're actually going to bridge the Ethereum stuff and sort of what people have been doing there around smart contracts and chain code, but we're going to do it in a hosted way with Hyperledger Fabric. So it sort of bridges the cool with the enterprise, which is what we're all about these days. Then we're going to take a little bit of a different tack. We're going to bring Sai on. Sai's been on the show many times, and he's going to talk about Node.js and Loopback. Despite the fact that IBM has a huge investment in Node.js, and we have a lot of Node.js talent on the team, we actually haven't had a lot of Node.js on the stream this last couple days. It just kind of worked out on terms of who we got on. So it's going to be nice to have Sai come on and talk about Node.js and Loopback. And if you haven't seen sort of the standard Loopback demo before, it's pretty cool. It blows your mind. I mean, the line is build an API in 5 minutes, and it's not a lie. And for somebody who's always like trying to quickly prototype and get like a simple app with some simple requirements just kind of nailed, it's really awesome to have that ability just kind of written for me. Then we'll have Sai Sruthi come on, and she's going to talk about the Model Asset Exchange, which if you've been on our streams before, you probably have seen. But if you go to developer.ibm.com and you click around in the community section, we have a number of exchanges. So we have the Bot Asset Exchange and the Model Asset Exchange. And the Model Asset Exchange is essentially pre-trained machine learning models that you can pull down and use as sort of stem cell models to train your own much more specific models. I'm spacing on the actual term for what that is. But that's the common developer loop, is to not build your own model from complete scratch, which takes hours and huge training sets, but to take a general model that already knows things like cars and teach it how to identify the Toyota Supra, which, by the way, is back. So if you're not hype about that, I can't help you. Then what we're going to do is we're going to kind of move back into chatbot land. Sergio's coming back. We're going to do speech-to-text and text-to-speech using Node-RED. And that'll be integrated with Facebook Messenger, which will be cool as well. There's a small chance that that ends up being a little interactive for the team, right? Because for the chat, but no promises on that one. So then we're going to have Victor come back on as well. Victor, we love our team Brazil. We love it when they're getting on. And so Sergio and Victor were both on yesterday, but they'll be on again today. And Victor's going to take a completely different approach. Instead of machine learning, he's going to be looking at Docker and Kubernetes. And he's going to look at OpenFaaS, which I assume is Open Functions as a Service, which is another way to do essentially serverless on top of your Kubernetes, I think. Then we're going to have Ryan Anderson on. And Ryan Anderson is one of my favorite IBMers. He's one of the nicest guys at this company. And there's a lot of really nice people at this company. And Ryan does a lot of stuff with emotion and identity and how sort of character is, character and personality traits are sort of lifted up and inserted into a digital medium, which is sounds kind of spacey, but it's actually, Ryan's a really smart guy, and I think he's going to take us through sort of his ideas around how you embody cognition and you embody empathy and you embody character into a chatbot, into a VR experience, into something more enterprisey like customer service. So that'll be really interesting to talk about. At 3:30, we're going to have Brandon come on from GitLab, Brandon Jung from GitLab, and we're going to talk about GitLab on Kubernetes on the IBM Cloud. If you're not familiar with GitLab, GitLab is a completely open source. It's a couple things. So there's a GitLab.com is sort of your hosted implementation of GitLab run by the company. It's a giant code repository. They have pull requests, they have merge requests, they have all the things you sort of expect from a hosted open source development model. But they also have a lot more stuff, and including one of the exciting parts is GitLab Triggers, I think is what they call it, which is sort of a serverless model based on Knative, and that's been injected into GitLab. What we're going to talk about specifically at this session at 3:30 is actually taking GitLab's source code, which is open source, and deploying that on Kubernetes on the IBM Cloud so that you can run your own GitLab, deploy code from GitLab, and keep it all inside your Kubernetes cluster on the IBM Cloud. So that should be a really good session as well. At 4 o'clock, we're going to talk about probably the hottest topic in the Cloud Native Computing Foundation right now, which is Knative. Knative is a project out of, IBM, Google, and a couple other people, Red Hat as well, have been writing software that uses Kubernetes APIs. It deploys into Kubernetes, somewhat like Istio does. And then it exposes a bunch of custom resource definitions. And the idea here, there's a few things of it. The short definition is something that it provides a serverless functionality, so you can have the quote-unquote scale to zero out of applications that you deploy using Knative. But there's also a lot more work that's being done around modeling the entire application lifecycle as like a dev-first tool. So the way to sort of compare and contrast it is that your kubectl, like when we talked about with Sadev, your raw kubectl commands and vomiting YAML at the Kubernetes API server is cool, and it gives you a ton of specificity around the application and how it needs to run and where it's going to go and how many replicas, and with the health checks and stuff, you're defining what a failure mode is. But that is entirely way too low level for people who don't want to have their head in the infrastructure time all the time, which I am one of the people that wants to be involved in the infrastructure, but most people just want to get work done. And so what Knative is doing, it's somewhat similar to the Cloud Foundry model of we need to get to the point where the devs type 1 or 2 commands and it wraps up all the complexity and it says the code is now deployed. So we're going to talk about that. Specifically, Greg Haynes, he works on the open source team at IBM, and he works upstream with Knative. And we're going to be talking about how, remember there's a serverless component to Knative. And what we have specifically there is something called scale to zero, which is the value proposition for serverless is that if you're not actively using that route, that endpoint, that function, it goes away and we stop billing you. But how do you actually do that? You just scale to zero. There are some performance problems in the default way that Knative was written the first time that made it difficult. There was a lot of performance around the cold start problem. How many seconds do you wait before your route becomes hot before you can respond when you didn't already have the thing warm? And so Greg is going to take us through what he's done and what his vision for increasing that or decreasing that cold start time. But also on the way to doing that, I think we're going to be able to talk a lot about the internals of Knative and how, where the thigh bone is connected to the leg bone is connected to the knee bone. And I think we'll learn a lot about Knative in that session as well. And then at 4:30, depending on whether or not he's feeling anybody, we'll have Greg Gorman back on to talk about IoT. We had Greg on tail end of yesterday's stream with Ishu from Red Hat, and they talked about IoT. Greg Gorman did tell us he's not feeling super well, so we may go longer with Greg Haynes. We may just cut the stream short because that's the end of the day, or we may have a surprise guest, something waiting to be seen. I want to take you through a couple quick announcements that are really exciting that came out of Think. This one, this is where we're going to start. We're going to say IBM has announced a managed Istio on the IBM Cloud Kubernetes service. And so what this means essentially is that, and I don't know if there's any, what this means is that after you've created your installation, you press a button, you receive a Kubernetes as a service. Once you go into the manage section of the IBM Cloud Console, you can actually press a few buttons to just go ahead and install Istio directly into it. So you don't have to think about how Istio is installed. You don't have to think about tuning it or anything, your parameters. You're going to get all that stuff inherited by the professionals at IBM Cloud who know how to install it. And also, there is, I don't know if they speak to it exactly here, but the principle behind this managed Istio is that IBM is going to behind the scenes sort of upgrade and patch your Istio. So you're not constantly going in there and restarting everything. You're not going in there and figuring out whether we need to install the latest release of Istio, et cetera, et cetera. You're just doing whatever you need to do in order to use the service mesh to get the best results out of your application. Istio is one of the hotter pieces of technology out there right now in the cloud native land space. So it's really exciting that we have this in a managed way, which lets enterprises get their hands on it right away. In that same vein of, first provisioning a Kubernetes cluster and then adding some smarts to it, we've also, this is labeled as beta, but what's labeled as experimental is the managed Kubernetes on IBM Cloud situation. And so this also got announced today. You can slot in there and you can basically manage Knative add-on. So you can get in there and you can just turn on Knative in your application, start playing with the serverless components, start playing with build, start playing with pipeline. We have a lot of Knative content coming out of this specific Twitch channel, as well as the IBM developer blog. And then there's this great video from Sai, which we might even run on the stream during a break, which is just Sai taking you through what is Knative and what does it do in just a couple of minutes. And that's all very exciting stuff that's been announced. So again, we have a long list of content that's available for you. We're going to have today. We're hitting blockchain, we're hitting machine learning, we're hitting IoT, and we're hitting a lot of Kubernetes and cloud native stuff. So what I mean by that is it's going to be great. We're going to have a lot of stuff. Stay with us. There's a bunch of cool stuff to do. There's still a Coursera link below if you want 50% off a Coursera class. Throw some questions in the chat. We'll try to get them answered, and we're going to have a great time from San Francisco. So we're going to take a quick break, and we'll be back with our first guests. Thanks.
In 2018, Call for Code captured the world's imagination. From aiding earthquake-torn villages in Nepal to building resilient financial systems in China, coders stepped up to the challenge. The Call for Code solutions we saw last year addressed everything from wildfires in California to hurricanes in Puerto Rico, to creating a blockchain-driven applications in Europe to help track donations. More than 100,000 developers from 156 countries donated their time and talent to building technology to address natural disaster preparedness, response, and recovery. We learned that developers have the power to change the world through their code. We learned that no matter where you are in the world, chances are you or someone you love has been affected by a natural disaster. We learned that this is more than a coding challenge. This is a global movement for good. This is personal, an opportunity to make our society more resilient, a chance to show that while we can't stop natural disasters, we can mitigate their impact. This is a new year with new challenges. We need you, the developer. This year we're adding emphasis on healthcare and ways to keep society's most vulnerable safe and healthy in the event of a natural disaster. The winning team from last year, Project Owl, met through our Slack channel. They built a solution that connects victims and first responders in areas that lose power and access to the network. We're working right now to implement that solution in Puerto Rico and other areas where staying connected can really make a difference. Last year's runner-up, PD3R, saw a need in the villages of Nepal to assess earthquake-damaged homes through AI. They built a solution that can scale throughout the world and help victims of natural disasters return to their homes in days instead of months or years. What will you build when you answer the call? How will your code change the world? Commit to the cause, push for change, answer the call. Visit callforcode.org to register. Get started today.
All right, everybody, welcome back to the Twitch stream from IBM Think. I'm joined here by two of the smartest guys in the company. This is Kevin Allen and Dan Crook. You guys want to introduce yourselves?
Sure, Kevin, why don't you go
Sure,
first?
absolutely. My name is Kevin Allen. I'm the content lead for Call for Code, and I also lead a lot of our efforts on IBM Developer. I manage our acquisition editors there. So, yeah, excited to be here, Spencer. Thanks for having us.
coming on.
All right, I'm Daniel Crook, CTO of Call for Code, one of the global initiatives that we have for applying technology towards some of humankind's largest challenges.
Got it.
So I'm excited to talk about some of the things that are happening.
Yeah, so what I'd really like you guys to do is just take us through code and response, the announcements, and then finally call for code.
Okay, sure. So we announced on Tuesday at the keynote by the chairwoman, Code and Response, which is a new program by IBM that follows on the success of what we did with Call for Code last year. So Call for Code itself is a long-term program to match technology to humanitarian causes. And that's a contest format. It's basically for generating new ideas, developing new solutions, working with new technologies as they constantly come out, how there's new interactions between technology, hardware, software, and the relationships between people.
Right.
So all that stuff is
I've
changing.
been characterizing Call for Code as a distributed hackathon. Is that?
Yeah, it's definitely a global thing.
Yeah.
Where it happens around the world, but we also have satellite events happening in cities around the world. So we've had over 150 nations take part around the world last year, and so that's really the avenue for kind of building out the challenge of a particular year, a challenge scope, a prize structure, and then once applications go through that structure, they're going to go into code and response. So when we set out for Call for Code originally, we always had that idea, that vision that this wasn't just going to be a tech for good hackathon where you throw away the code afterwards. It had to have somewhere to go to make an impact. So that's where Code and Response comes in. It's supporting the winners of Call for Code last year, and it will support Call for Code this year, and it's also going to support things like the Clinton Global Initiative University, which is codeathons for university students.
Got it. And so there's a inside of the code and response umbrella, there's a component of deployment.
Correct. Yes. So what we're doing right now with Project Owl, who won Call for Code last year, is taking. So they won a cash prize. They won an introduction to a venture capital firm, and they also have open source community support through the Linux Foundation. Mm-hmm. So we're taking what they built and making that open source, getting the contribution guidelines in place with them, helping them license it, set up their trademarks, their logos, and whatnot. And also the most interesting part, and the most exciting part to I think a lot of IBMers, is that IBMers are volunteering through our 10-year-old corporate service corps plan or a program to support the deployment. So we have IoT experts, software engineering experts, user interface experts, community building experts. They're all coming around Project Owl, the winning solution right now, to help deploy it. And we're going to be doing that starting in Puerto Rico next month.
Awesome. That's fantastic to hear. I was just in Puerto Rico. Wonderful place.
Yeah, I think we were all there probably at the same time.
Yeah, I think we didn't actually meet because I was on vacation.
Yeah.
But that's fine. We sent 2 text messages. Like, I don't know.
That's right. We didn't want to bother you.
Yeah.
No, it was exciting. So yeah, we're heading back there, and we made a lot of great relationships with local NGOs, governments, companies, even the local Rent-A-Center to help make some really amazing connections down there to make sure that what is built is it's applicable to the local community, and ideally what we learn there we can transfer around the world, but the solution has to be driven by the local partnerships.
It has to be. Yeah.
Right.
You can't just airlift in as we're IBM and we have the plan.
Exactly.
Yeah, and one of the pieces of feedback that we received from the time that we were in Puerto Rico in August to the time that we came back was just that, there are so many organizations that come in and just say, here's what you got to do. And they just kind of say, here's some solutions, implement it or not, or, they try to kind of bully their way in. What we wanted to do was to say, we have some tools, what are your ideas? So we brought the hackathon to Puerto Rico, and our first question was, what was your experience, and how could technology have played a greater role in mitigating some of the suffering that happened on that island?
Right. I think that's great stuff. So Dan, why don't you take us through very briefly, there is a contest component in 2019.
Correct. Yeah.
And can you take us briefly through the format of the contest and what we're sort of asking some of our Twitch viewers to put teams together and compete?
Yep, exactly. So, so the starting point for learning about the challenge, you can go to developer.ibm.com/code and response, and that will get you joined into the 2019 challenge. So you'll get your cloud accounts, your special promo codes, as well as joining a community, and you'll learn about, once you join that community and kind of interacted with learning about it, it'll send you over to callforcode.org, which is where this particular competition, the information, the canonical location is for all of this. So if you go there, callforcode.org, accept the developer challenge, you'll learn about the scope of what we're doing this year. And we addressed natural disasters last year.
Right.
And we that was such an amazing issue, and with 2018, in 2019, it's just becoming more and more relevant, right? It's something that people really want to apply new models of development, hardware, software, human interactions to. So we are building on that again. What we're doing, though, that's different from last year's competition is that we have more of a focus on health and well-being. So
Okay.
explicitly asking folks to look at issues such as disease mitigation, access to clean water, and food
And mental health.
Mental health, of course, a very important one, especially after disaster. You know, it affects your livelihood, your interactions with your families, things like that. So you'll learn about the challenge scope there at callforcode.org, and you will see the prize structure.
Okay.
Again, it's multi-dimensional, right? So we want to encourage a huge variety of developers if they're motivated by a cash award, motivated by access to venture or mentorship, access to the Linux Foundation, large communities of open source developers, as well as the opportunity to work with the IBM volunteers who can help deploy the solution using their expertise, particularly with the IBM technologies that are in play. And of course, it's not just a winner take all, one winner, right? So we have 4 runners up as well, 4 runners up team that will also have access to the open source communities, support through Linux Foundation, as well as a cash prize. And all of these solutions that compete this year, even if they don't win these top 5 places, what we want to do is make sure that they have the support and they have the knowledge for how they can build a community around their solution. So again, it's not just build something, throw it away if you didn't win.
Right.
We want people to constantly be thinking about this, constantly be imagining how they can take their skills and apply those to large problems.
That's fantastic stuff. I mean, $25,000 is a ton of money. $200,000 is life-changing money. Even if you're a developer, you don't sniff at $200,000.
Yeah.
And there's a lot of follow-on opportunities there too. You know, meeting with venture capitalists,
Right.
being in close collaboration with the upper echelons of the Linux Foundation is the primo open source credibility.
Yep.
So there's a lot of really exciting stuff going on there.
Right,
Yeah.
and one of the interesting things that we saw from last year, Spencer, was that a lot of the top teams have started to talk to one another.
Oh,
so a lot of the
good.
participants have started to share ideas and are becoming involved in each other's projects. And so this becomes we're starting to really see it become its own living, breathing ecosystem and community.
That's awesome. So can we talk about specifically like timelines, how to form a team, et cetera? Like what is the, I think I have a couple questions. Timelines is the first
Sure.
one. Then I think I would really like to understand what is in the submissions manifest. Like what are we building here?
Yeah.
How far does it have to be from the idea to implementation? What are any requirements around specific coding technologies? Like does it have to be in JavaScript, that kind of stuff? Take me through it, Dan.
Sure, yeah. So the competition is longer than it was last year, or at least it's got a longer scope. So we kicked it off on Tuesday. So the number one thing that
Mine's
developers...
done. Mia and I,
There's
we
an
have
internal
already,
IBM competition.
we've
You guys are
already
eligible
finished
for
our
this stuff.
submission. We had it ready to go.
Nice. So again this year we're also going to have an external competition and an internal one for IBMers. So if anybody...
Nobody cares about that. Let's just talk about the external one.
All right, let's talk about the one. Okay, so we kicked it off on Tuesday, and we asked developers, join the community, kind of explore the technology that's there, and meet potential teammates, right?
Okay.
So anyway, that's kicked off, and later in March is when they can actually start submitting their solution. You'll get the full submission details about what needs to be included in your application. But right now, you're going to join the community, understand the challenge, start thinking about the technology.
So when we say join the
play.
community, we're talking about the IBM Coder community?
Yes,
Okay,
and that's
where
what
we're kind of running most of our work through?
Correct.
Got it. Awesome.
Yep. So
Is Slack on the table again this year or no?
it is an ancillary thing.
Okay.
It's there, but the primary community is going to be Coder.
Got it.
So we've got a lot of folks in there that came in from last year's competition, as well as some of the other competitions that we've done, the drone giveaway.
Right. Our Twitch family is very familiar with Coder because that's sort of how they got the drones.
Exactly. So that's
Work
a
with
huge
the drone
community
program.
now. So we want to make sure we take advantage of that, make sure that people are familiar with it, they're used to it. And what Coder also does is help them guide them through the life cycle of the challenge, which not only includes these milestones in the schedule, but also Kevin's team is aligned for the 24 weeks of the challenge, new content, new tech talks, new expert talks from SMEs, from IBM developers, from guest developers.
Got it.
So that's going to go through 24 weeks, and it's all going to be run through through Coder, so they know exactly where you are in the competition, from start to submission to review to FAQs, things like that.
All right. Got it. Okay. And so March 25th is the cutoff?
No, that's when they can start submitting applications, right?
Okay.
And they do that all the way through the end of July. So we've got several months there in the middle, and that's the 24-week period we were talking about, where there's
Got
new
it.
content being released. So submissions end then July 29th. Judging will go through August and into September. And again, we're going to have some eminent technologists, ideally folks like President Bill Clinton, who judged last year, as well as experts in the field, right? So folks from the UN, folks from American Red Cross, folks from the Linux Foundation, that all help judge the applications against the 4 criteria and get us a full view of the solution.
Got it.
Right? And then make sure that it's solving a real problem, that it's technically viable, that it's something that is not only local to a particular nation perhaps, but also something that can be transferred.
Right. So let's roll back to March 25th. So do people have to submit sort of this is my idea and get that accepted?
No, not at all. So there's no like proposal step.
What does
right?
opens for submissions mean?
Okay. So what you'll do is there will be a form. You specify your team name.
Got it.
You're up to 4 teammates.
Got
so
it.
teams of 5.
Okay.
You'll basically do a one-liner on what your application is, kind of its title.
Right.
Then you'll do maybe a Word document page, a word processing document, 1 page. This is the problem domain. This is how we solved it. Here's some details, kind of like a 1-page brief,
Yeah.
a little more metadata.
And
And
then
then
work at IBM one day, you say executive summary.
and then a link to your open source code repository. So GitHub, just provide a GitHub repo. And so last year, what's different this year versus last year is you submitted once and then it was that was it. You couldn't really iterate on it, right? What we're doing this year is letting folks get their idea in there, make sure it's entered in the competition. But if they want to evolve it, they want to add, maybe they're going to change their teammate names,
Sure.
they can continue to do that through to the deadline, right?
Okay.
So at least they'll get something included that can be judged, and it gives them a chance to kind of rethink it and iterate on it.
That's awesome. Okay, so this is an opportunity to sort of, that what this helps do is prevent the crush of logistical questions on July 29th.
Exactly,
Right.
because we got a lot of questions last year. It's like, all right, I've been working on this, but I have no idea exactly what the submission form is going to ask for. And I'm that type of person. Like whenever I fill out any form, like I do it in like a text editor first, because I don't want to lose my web browser session.
Oh man, you hit that back button and
Yeah.
it's just gone.
So I handle everything in text files. Just pull up in Sublime, save a text file, and I keep it there. And so we want people to know exactly what we're asking for. And what's also going to be nice is we can point them to some examples from last year.
Got it.
The type of winning solutions.
That is going to be huge, is the opportunity to look at what was done last year for just some general, being able to like put it in something of a box, because it's such a broad challenge.
Right. That's something that we didn't have last year. So running it the first time around, we were all kind of sitting around wondering at certain points, like, what are people going to build? Like, like, are people going to join? But by August, September, we were floored by some of the ideas that were coming out of these hackathons all over the country. So.
And
all over the world.
Exactly. We want to build on the local ones too, where of course we have a single global multi-month competition with that prize structure, but we love to see these little local events happening, like the hackathon in Puerto Rico, the hackathons at universities around the world, hackathons of specific companies who maybe don't want to or can't even accept the cash prize, right? A large enterprise may not be able to do that, or deal with some of the IP restrictions. We'll get to that in a bit. But just in general, they want to answer the call, right? They want to develop something amazing, whether it's within this prize structure at all, but they want to make a difference, right? So these satellite events are kind of nice ways for people to get involved, understand the scope, learn the technology, and then decide, all right, maybe they won the hackathon, the weekend hackathon, now build up on that idea and bring it through the global competition.
Right. Okay. So let me see if I got this straight. Like the manifest of a submission is going to be a title, a list of teammates.
Yep.
It's going to be a one sentencer.
Yep.
It's going to be a one-page executive summary, and it's going to be a link to an open source Git repository on like GitLab or GitHub or something.
Exactly. And if you go to the FAQ on callforcode.org,
Okay.
you'll get a preview of that information right now that you'll need to have when you get ready. So yeah, so teammate, team name and email.
Oh, and a 3-minute demo video. Okay.
Yes, I'm sorry. Yeah, that's a key thing. So basically your pitch, right?
Yeah.
That describes, the problem you're solving. Because the judges here, like I said, they come from a cross-section of experts, right? There are technical people. There are people that see the larger view, the strategic.
People with NGO experience, what
Exactly.
does and doesn't work on the field.
Exactly. So if you can demo that and really make your case to show like what your application does and give them that aha moment, that's all these things that we ask you to submit. Add a little bit more information that judges can work with.
Right.
So some will do a deep dive into the code.
Mm-hmm.
Others will focus more on your business or the one-page summary.
Yeah, like not a business plan, but if it was a startup pitch, it would be your business plan.
Exactly. Yeah.
So, for folks on the Twitch chat, these two know more about the competition than anyone else on the planet, so this is the perfect time to ask any questions. Is this a good idea? We're hyping on these logistics because we got a million logistics questions last time.
Yeah.
Yeah.
We're logistics folks, but also just general sense of like scope. And I think the big question you haven't answered yet, Dan, that I have is you said there are 4 big criteria.
Yes.
There are 4 judging criteria, and I think we want to get into that as quickly as possible.
Sure, yeah. So if you go back to that challenge page, accept the challenge, you scroll down past the scope and the prizes and the schedule, you will get to the rules. And so these will be in more detail when you submit. You'll accept a participation agreement.
Got it.
So that includes some details in the IP and whatnot. But yeah, so IBM's making all of its technology available to developers. We've got a bunch of cloud data, AI technology. So we want you to use one of those at least, right? And you can use that in combination with, like on a mobile device, Apple Core ML, paired with a Watson service in the cloud. You can use Google Maps, whatever's going to make your solution complete. And in some cases, when it's offline first, you got to have clearly something that's cached working on a local mobile device. But we have close to 200 cloud services. So we want folks to use at least one of those. Explore
And
that technology.
our Twitch viewership sees IBM services day in and day out.
Exactly,
So
and that's the whole point of these chats like we're having is we want people to know how to use those, know what's available to them, and understand how they can kind of pull them together.
Right.
So that's number one. Yeah, and I mentioned teams of up to 5 participants, at least 18 years old, and they can build their application. Of course, in this modern day world with development, you got to leverage open source or something out there, right? You're not going to build, an application out in the middle of, it's not an island, right?
Yeah.
You're relying on some open source technology. So whatever you use in your application, you can use libraries, you can use APIs, as long as everybody else can use those too. So you
Right.
can't bring like your proprietary code that you built in some private project a year ago unless you open sourced it and kind of made it available to everybody.
All right.
So that's key to that. And on the IP a bit, so everything we want, because we want people to be able to use this technology beyond just, the people that create it, everything has to be Apache 2 licensed in order to accept the prize. So if you don't win, the IP is all yours, but if you don't win, you don't have to keep it out there. We want you to. But in order to take a prize, it has to be Apache 2 licensed.
All right. Sounds good.
Yeah. And then the criteria, which
Yeah,
what
that's
you were
what I
asking
really
about.
wanted to get into,
Yeah,
is
sorry
the
to take you on
judging criteria.
that. Took you down that little road there. But yeah, so there's 4 areas, and we know that some applications will excel in some areas more than other.
Mm-hmm.
Obviously, you want to make sure your application kind of covers all these. But in the semifinalists last year, we saw, for example, that some that were incredibly innovative, but weren't quite as complete. And in the same way, we saw some really well documented, amazing solutions that were complete, but they really didn't have a compelling story. Like, why was this important? And you just complicated the situation, right? We don't want that to happen, right? You don't want to just throw technology at the problem, and it cause a bigger issue
Right.
than solving the problem.
So completeness and transferability.
Yep.
This is essentially, is the code done? You know, is it going to be 200 hours of coding just to get this thing ready to ship?
Exactly.
And of course, you know, no, as I say frequently, you know, no plan survives contact with the enemy. And it's true in software deployment as well, right?
Sure.
You know, if you thought it was ready to deploy, that means you were ready to try. Effectiveness and efficiency. So this is, I see what you're saying here. Don't make a solution for a small section of people. Make a solution for a large set of people.
And also, yeah, it's solving a real
balance
problem.
it.
Yeah. So,
Balance
and again, you know, this is why the tech talks and the nurture that we have from the experts, SMEs, like we want you to see the real problems that are out there. We want you
Right.
to solve those problems.
Right.
We don't want you to
And I think the most effective solutions that we saw coming out of the competition last year were solutions that worked in your neighborhood, but could also transfer around the world.
Some kind of
Right. And so
think globally, act locally.
right, a
Exactly,
great
yeah.
example is the work that the PD3R team did, which was one of the runners-up last year. They created an application that uses AI to look at photos of homes that are damaged by earthquakes to assess whether they're structurally sound enough to go into and live in, or if you need to bring an engineer out. And we discussed that same solution with officials on the ground in Puerto Rico, and they said, we need that tomorrow. Or like, we needed that yesterday. So, you know, it's that idea of taking something that is specific to your region, and then, you know, that's also going to have applications globally. So those were some of the most effective that we saw.
That's a really great example. I think that's really interesting. And of course, obviously that ties in with the drone drop that we did, because now something like 2,000 developers already have IBM accounts. They already have IBM Coder accounts, and they already have these drones and a fair bit of like stem cell code they can use to build solutions like you're talking about right away. So tell me a little bit about design and usability and that particular judging criteria.
Yeah. So that one's really important because you have to think about your end user of this application. You've got to empathize with what they're going through. Are they under stress as an incident commander? What's their experience like? Do they need another dashboard, or are you helping them be mobile and get like?
No one needs another dashboard. I mean, if it has the right information, it's good.
Yeah, but exactly. So that's what we're getting at, right? It's like, think about like you got someone under stress here. They're trying to get something done. Like, have you made it easy for them? Have you made it easy to deploy the solution to begin with for like a local government? And then of course the end user, right? So we did some crazy innovative solutions last year, but there were some Rube Goldbergs in there.
Yeah.
We literally had like, all right, you're in an earthquake and you now have to open up your mobile app and go to the App Store, download my app, and you can't really, that's not, it may be an amazing solution technology-wise, but you got to solve for that. You got to figure out how people can actually use the technology in the context where they are. So totally use IBM design thinking or some methodology where you can kind of really understand the problem you're solving.
And this is the thing, right, folks, is we're giving you a bunch of judging criteria that are actually all going to pull you in opposite directions. We want you to solve the biggest possible problems with the tightest UI possible, and it has to be completely done, but don't make it so small in scope that you can finish it easily, right? So is there a...
I think you covered it, right?
Yeah. Yep.
Good
That's
luck.
about it.
Sign me up.
So Dan, is there, what is the weighting on these?
So these are all equally weighted.
They're all equally weighted.
Exactly. So they'll be scored across there. And you know, we're not going to expect, we were giving them 5 points each, coming to like a total of 20 points last year. Behind the scenes, that's what it will be, is out of 20 points, how many of these did you basically assign a score of 5 to each. And, you know, in terms of being complete, we want, you know, you're not going to hit like a perfect score on these things, right?
No.
What we do want to see is an application that's relative to the other applications in the competition. So there's no real level of score that you can really aim for. It's all going to be how the cohort of your competitors kind of come together with this. So so you know, build whatever you have, and if you have something crazy innovative, submit it.
Yeah.
Submit it. It may, you know, it may blow, you know, one of these areas out of the water, and with a little bit of work that the judges can see, yeah, you just need a little bit of help here. You know, judges will look at that and say, listen, this versus, they won't just look at a raw score. There's a little bit of subjectiveness that's going to come from the cohort of judges.
Right.
So we want to make sure, you know, you're building whatever you can, consider all these things, make sure you address them, and maybe if you're not complete in one area, make sure that's clear in your demo video, make that clear in your brief. Just be like, this is what it is, this is our roadmap, where it will be 6 months from now. But yeah, this is going to be your North Star.
Awesome. Well, so just to go one back thing, we have to cut to a break real soon here, but what is the way to get started? Is
Okay.
it callforcode.org?
Yeah, you can go to callforcode.org or the developer site, and then just join that challenge community. Both sites will take you there.
Got it?
You'll get your cloud account. You'll get dropped into the coder community. There's some immediate challenges now. You can learn about last year's winner.
You can start building your teams,
And all
then
that stuff.
you can kind
Right.
of start
Exactly.
putting your packet together on March 25th.
And selfishly, I want to say there's a ton of content because that's kind of my domain. So what we tried to do was create a lot of content that helped contextualize for developers what the problems are that we're facing on the ground in these areas, especially as it relates this year to that healthcare component.
Yeah, and you can find all those. They're linked from .org or the .com site, grouped by technology, 6 technology areas, 6 disaster domains, and a new area on healthcare, which we'll be fleshing out. There's always going to be new content coming in here. So it's not just whatever's there now that you have to work with. And of course, you can explore all 300 code patterns that we have as well.
Awesome. All right, folks, we're going to take a quick break. We'll be back, I think, with
With Project
some-
Owl.
some selection of our lovely faces, and also Project Owl, who were the winners of 2018 Call for Code. After that, we'll have Saran and Dan from Red Hat on to talk about the Command Line Heroes podcast. Stay with us. This is Think from San Francisco 2019.
inspired by the whole hurricane situation in Puerto Rico. All communication was down. It was completely dark for not just 1 week, but weeks and into months.
So Project Owl is kind of a two-part solution. We have a software incident management system that first responders and civilians can use to manage a disaster, coordinate resources, learn about weather patterns, and get information data analytics through the cloud. The hardware component allows us to distribute Owl incident management software to the worst disasters where infrastructure and connectivity might be offline.
Once this network is deployed, this network of ducts are deployed in a cluster or cluster duct, the civilians are able to basically get on the devices to a really intuitive interface, contact the responders, and basically send a list of things that are really essential to them.
When you walk into Starbucks and you want to connect to the Wi-Fi, a little page comes up, so it's kind of the same idea.
This type of efficiency can dramatically impact how many people can be saved during a disaster.
Hi everyone, and welcome back to the stream. We're joined by Project Owl and Kevin Allen. Owl, do you want to introduce yourselves?
Hello everyone, my name is Magus Pereira. I'm the CTO and co-founder of Project Owl.
Hi everybody, I'm Charlie Evans. I am the Chief Software Architect and co-founder for Project Owl.
Okay, so I have to say at the beginning, have you heard of the Overwatch League when you named it Project Owl?
I wasn't aware of the Overwatch League, sorry.
That's fine.
I only know what the word Overwatch is, so.
That's great. The less time you spend watching Overwatch and the more time you spend writing software, the better for your general lives. So you won Call for Code 2018. Can you give us the briefest introduction to what the solution is and what it does and how you built it?
Yeah, so we have a hardware and software solution and an incident manager that basically connects responders to civilians. But one of the biggest problems during a natural disaster is communication, and that's one of the reasons we developed these IoT devices called ducts. And these ducts are basically deployed in an area that is suffering from loss of traditional infrastructures such as cellular network. And basically these ducts are deployed in a cluster or a cluster duct, and all the messages are relayed to our incident manager, the Owl.
Okay.
And it basically keeps the responders and civilians in touch.
Okay, and it does that over shortwave radio, over Zigbee?
It does it over a hybrid technology. We use Wi-Fi and LoRa technology. So Wi-Fi allows civilians to connect to these devices via the traditional mobile or laptop device, and it basically pulls a captive portal. So imagine you're trying to go to a Starbucks or an airport, and you just tap on the Wi-Fi, web pops up on your device. It's a similar process, and civilians basically fill the form and send all the requests to the ducts. And once the messages gets to our devices, it's bounced and relayed to a ducts through a transmission called LoRa, radio protocol called LoRa, which is long range and low powered technology.
Okay, and is it what frequency band does the LoRa work in?
It's in a license free band. I believe it's 915 and 868.
Yeah,
Okay.
that's in the US, and it's a little bit different, I think, on the European side, but they also have the same technology, just works on a different frequency.
And you don't need a license in order to transmit in that frequency? That's
No.
fantastic.
Yeah.
Usually you have regulations all over the place. Cool. All right, so it creates a captive portal, and that allows people to essentially get on the internet?
Part of the internet. So it basically allows them to get on a form that allows them to relay the most important information. So if they need first aid, if they need water, food, it lets them tell responders how many occupants are in the house, or if they're in immediate danger, obviously the address.
Awesome.
Yeah.
Awesome. So tell me about how did your team form and come together? And then, how was it working together? How was the process of entering and participating in the competition?
Yeah, so some of our members already knew each other. Brian and Charlie were family friends.
Yeah. I've known Brian for about 6 years now,
Yeah.
and he's the CEO.
Mhm.
And he contacted me and said, "Hey, we're going to do this cool thing. Do you want to be a part?" And I said, "Yes, I do."
Yeah. And Brian met Nick through hackathons, I believe, and Tarakur from like data science meetups. Brian and I actually met through the Call for Code Slack channel. I believe right around registration, within like 24 hours, we were both looking for teammates, and Brian pinged me. We started talking, exchanging ideas, and we both liked each other's take on our solution, and we. The rest is history.
Awesome that you came together and were able to put a team together up of just interested parties. Do you live in the same city?
No, so I'm the most displaced. I live in South Texas, and they live all in kind of the New York City area. They live all up in the Northeast.
Yeah.
So this week was the first time that we've all been in the same place together.
Yeah.
Wow, you weren't even in the same place for the finals?
No, so
No.
I couldn't come for the finals.
yeah. Too bad.
They were all here, but I could not make it.
You were there in spirit.
I was there in spirit, definitely.
That's fantastic. Well,
Yeah.
congratulations again on winning.
Thank you.
Is there something to look at if we click around on the website? Like, can we see the? You said that there's the Owl is a participant in the system. That's probably your incident commander or your coordinator. Do you have a mock-up of their dashboard, of their view?
We kind of do.
Just ask him for the demo in the middle of the interview, Spencer.
Yeah,
that'll do it.
I know we have some video on it.
We did just play the trailer, so it might have covered that.
Okay, yeah.
You could probably speak to it because people would have just seen it 20 seconds ago.
Yeah. So the idea with at least the software portion is that there's going to be several different kinds of modules. Probably the most important one is as Brian keeps saying, is as simple as dots on a map, right?
Yeah.
So, well, based on the data we receive from one of these devices, we'll be able to kind of categorize, what people need the most or who's the most in trouble, and we can color the dots differently on a map.
And does this device actually submit its GPS coordinates or something?
I think that's a plan
Yeah.
that we are going to have.
Right now, the civilians are basically hard coding their addresses.
Well, they probably know where they are.
Yeah, and it's being geocoded once it gets to the web. But the idea is to add additional sensors, whether it's a GPS, humidity sensors,
Standard weather data. Yeah.
Yeah. So we have these things planned called backpacks, which are basically packs of additional sensors, and they basically allow the ducks to work in all sorts of natural disasters, not just floods and hurricanes. So imagine it being used for earthquakes, wildfires,
Exactly.
etc.
What is your, it's all kind of theoretical and remains to be deployed, but what is the strategy for deploying the ducks out over a space of miles?
So we have a couple different strategies. One we keep mentioning is drone deployment. That's one of our initial strategies. But we also have 3 different tiers of ducks. We have the smallest ones are called the ducklings. Then we have a mama duck and a papa duck. So the mama and papa ducks will actually be tethered down or anchored to specific places ahead of time, and especially in areas that are susceptible to these conditions. One example being Puerto Rico. They experience hurricanes almost annually. I'm a native North Carolinian, so I was actually in North Carolina when I was working on this project during Hurricane Florence. So we are pretty prone to hurricanes as well. So, and we would basically work with a couple of municipalities to have a couple of bigger tier ducks, the mama or papa ducks, anchored and tethered in strategic areas.
Okay, and what is
Yeah.
the power solution on the smaller ducks? Is it a baby duck?
The ducklink?
Oh, the ducklink. Yeah. Okay.
Yeah, so the ducklings are basically going to be powered by a battery source, and since they are they use lower technology. They can last up to a couple of weeks, or at least we are aiming for 7 days with our prototype.
That makes sense. Yeah.
Yeah.
And I mean, okay. Yeah, I'm with you.
Yeah.
And you, what is the battery source? Is it 9 volt? It's a cadmium?
Right now it's a lithium battery,
Okay.
and we have a sleep mode that it basically once they're deployed in clusters, they basically shuffle. So if one's asleep, the closest one stays awake, and it goes back and forth.
Okay.
Yeah.
And does it also report battery status back to the control center?
We are definitely working on a dashboard that sends not only the battery life, but a bunch of different stuff that we want to
internal
populate.
telemetry and metrics and stuff. Yeah,
Yeah.
I'd be happy to
Specific,
work
yeah.
with you on that.
Yeah, that would be awesome.
So, but then, so what is your, like, how do you patch it? How do you patch the software? How do you get the upgrades? How do you put more battery in? Like, are
Mhm.
these field serviceable by your affected individuals? Because if you just dropped it out of a drone
Yeah.
and it's in my backyard, what can I do with it?
So we have plans to have something written on this that allows civilians to either put it in a Dropbox, but one of the things is with like one of the things we're trying to at the moment we're just flashing all the boards ahead of time, but we want to add over-the-air update capabilities on.
We just had a conversation, you know, because I was talking to Daniel Kirk and Kevin Allen about, you
Yeah.
know, one of the criteria is completeness, and over-the-air upgrade is like a super hard problem.
Yeah.
Like, if you're not Apple, like, you're probably gonna mess that up. But also, more power to you. It's not that hard. It's just software, man. It always works.
Do you guys want to talk a little bit about the plan for actually implementing in Puerto Rico and what you guys plan to do in March and actually testing this in the field, and a little bit about what you hope to gain out of that?
So the plan is we are working with the government and the mayor of Puerto Rico. We want to take 100 of these ducklinks to a school and just create a network where we can educate the population over there on how our ducks work, but also put our ducklings in very high stress situations. Get multiple requests from civilians on the ground. One of the things we want to do is test the range, test these ducklings in high, in environments that have with variables that we haven't considered. We have
You just want to get it out of the lab, and
Exactly.
take it out in a field
Yeah.
test. Yeah, I'm with you.
test them in rural areas, urban areas, areas that are with high humidity. Basically collect
Sure.
tested with different variables, different environments, and put them in a high stress situation. So we are prepped when we have a high risk situation in the near future.
So, so Spencer, one detail about this team that might interest you is Magus, during the course of the competition, became an IBMer.
Oh, welcome.
So 2 days.
Did you actually get the money then, or did they take it away
was it
from
a
you?
week after the competition that you started?
So it was a week after the competition. I started. I was kidding with you yesterday.
I was having a good time, man. I was thinking, there was. The funny thing about last night was that the Project Owl folks went hard on the Smash Brothers, but
And the foosball.
and the football, sure. But yeah, we were chatting a little bit, and you tried to tell me you'd been at IBM for 8 years. I don't believe you.
Don't believe anything Magus says.
So
But
yeah.
welcome to the team.
Yeah, thank you. But the funny thing with that was it was a total coincidence, and I remember like we were working on a submission till 5 minutes before the deadline on a Friday night, and I get a call 2 days later on a Monday from the recruiter, and I was like, wow, like it was that was
That's
amazing.
great.
Yeah, fantastic. Well, we're very excited. Look, it's been awesome having you here. In very brief, I want you to give just one sentence each to the camera that says, look, if you're going to do Call for Code 2019, this is my recommendation for success.
My recommendation for success is, try meeting people that are not kind of different from you, but you guys share the same. You think you would be compatible in the sense that you may potentially share a vision or a mission, and do it for the tech for good aspect of the project, and that's going to put you under pressure to think very creatively and use tech for the betterment of humanity.
Yeah, and I would kind of mirror that in that, you know, if you have an idea and you think it's going to help people, just go for it, you know, and you'll, you know, if you need a team, you'll find a team. I mean, that's kind of how we kind of got together. So that's what I would say.
All right. Well, thanks for coming on. We're gonna jump to a quick break. Then we're gonna have Saran and Dan from Red Hat. We're gonna talk about the Command Line Heroes podcast and the Magical Living Room. Thanks again for coming on.
Thank you so much,
Thank you.
Spencer.
Thanks, Spence.
Welcome to Season 2 of Command Line Heroes, an original podcast from Red Hat. I'm your host, Saran Yadbarik.
All right, welcome back to the IBM Developer Twitch stream. We're live from San Francisco on Think 2019. My guest is Saran. Do you want to introduce yourself?
Sure, my name is Saran. I am the founder CEO of Code Newbie. We produce content for all things for people who are learning to code and who are new to the coding world. And I'm also host of Command Line Heroes, which is a podcast from Red Hat, which is all about all things open source.
Awesome. Well, thanks for coming on. Have you ever been on Twitch before?
I don't think so.
You might have. I mean, you're just kind of famous,
No.
so like you probably just haven't at some point. But yeah, there's a Twitch. We're just on Twitch. This is got the chat. So if you have any
Cool.
questions for us, we can
Cool.
pretend to answer them.
I like pretending to answer things.
It's like, oh yeah, I don't know
my
anything
favorite.
about that. Let me pontificate. So tell me about either. Would you rather start with Code Newbie or with Command Line Heroes?
Either one is fine. You want to start with Code Newbie?
Yeah, let's
It's
start
like
with
the
that.
easy one?
Yeah.
Sure, sure. What would you like? What's your question?
Give me the spiel.
Sure. The spiel is, so there are lots of people who are trying to learn to code and really get into, conferences like this, work at companies like IBM, like Red Hat. And it's really hard to do that. It's hard to kind of break in. And even though there are tons of resources available online and in person, the hardest thing and the most important thing to find is your community, right? That's why we're all here at IBM Thing, because we want to be amongst our people and people who get us and what we're doing. And so when I learned to code about a while ago, I taught myself for a little bit, and then I enrolled into a boot camp.
Okay.
And for me, the biggest difference was that I wasn't by myself all day long. It wasn't just me in my apartment, just, wanting to throw the computer against the wall. It was me with other people trying to throw the computer against the wall. And so being around that community just made such a big difference in my own confidence, in my self-worth, and just me being able to believe that I could do it was huge. But doing that and getting that community cost $11,000 in like 6 months without a salary.
Yeah, that's you're taking the double hit of no income.
Yeah, and luckily I had people to support me and I was able to do that, but that's like quite a price tag for a community. And so I wanted to find a way to give people access to amazing supportive people without having to drop everything and put their life on pause in order to do a boot camp. And so we started with Twitter chats. Do you know about Twitter chats? You know something about Twitter chats?
I may have seen a couple. Why don't you give us the spiel?
Okay, that's a good start.
The spiel inside the spiel.
The spiel inside the spiel. The super spiel. So Twitter chats are all about, it's on Twitter. So you pick a time. For us, it's 6 p.m. Pacific time, 9 p.m. Eastern time. You pick a hashtag. For us, it's Code Newbie. And what we do is usually there's a moderator, someone like you actually, who hosts and asks the questions. And the idea is everyone gathers and shows up online at that specific time. And then you just go back and forth. You answer the questions. You meet other people. And it's a little chaotic, but an organized chaos of tweets and people sharing their ideas and perspectives.
I think I have seen this. This is when the moderator will have numbered questions, and then people will be like, my answer to A6 colon, and then they answer it that way.
You nailed it.
People retweet and stuff, and it is chaotic. And
Yeah.
finding the root is sometimes difficult,
Yeah.
but that wasn't the point anyways. The point was just to have conversations.
Exactly.
And,
It was just an excuse. It was just an excuse to get people in the same, room and get people talking. And so
well, and it's a super smart format.
Right.
Because you get away from some of the a lot of more traditional formats sort of prioritize one or two voices, very one to many.
Yep.
Which is not, it's a homogeneous environment where you don't have the longest conversations. Whereas, Twitter.
Yeah. For better or worse.
Yeah.
Yeah, exactly. And it's funny because some people use Twitter chats very differently. They use it to do an interview with one person, which I think is kind of silly, you know? Like, you have an opportunity to talk to so many people at once. Why just do an interview one-to-one when you can do a many-to-many relationship? So, yeah.
So we have a question from Art of
Okay.
DHT.
Let's do it.
And it sounds like the question is, I want to learn machine learning.
Oh,
What program
boy.
do I start in? Which we may not say is our thing, but does Code Newbie have a machine learning arm?
Not specifically machine learning. We have people who are interested in doing some type of data science-y related thing, and usually we recommend like Python for that because
Yep.
it's beginner friendly enough, but it has enough, you know, data and math libraries and things that you can do like machine learning with. So that's what we recommend generally. But I mean, to each their own. It also depends on where you're located and what job you're trying to get. That's the thing. Most people, when they're trying to learn to code, they go, "What should I learn? I want to learn the easiest thing, the fastest thing." And it's like, sure, you can learn the easiest and fastest, but if you can't get a job and, you know, your local job market is looking for, you know, Java and you decide not to learn it, it kind of doesn't, you know what I mean? Like, you have to match up.
You have to match it up.
Yeah.
And then it's a moving train.
Yeah.
You know, and this is, I think, particularly difficult. It's so exciting that you brought up the boot camps, because the boot camps are sort of patching a number of problems, and
Yeah.
one of them is access to higher education. But the other thing is that higher education is teaching, broadly speaking, your CS degree has something like 5 or 6 classes where you're actually hand-on code, and the code you're writing is bad.
Yeah.
And it's in languages that no one cares about, like C++. I mean, sorry. They are not the. Let me say that a little bit better. They're teaching in languages that are not well aligned with like what the industry is hiring for and trying to build the next thing in.
Yes, exactly. I think it was it Stanford CS program who recently switched their main programming language to JavaScript?
I didn't hear that.
I-
That
I'm
sounds
pretty,
awesome.
I'm pretty sure it was one of the top, you know, computer science programs. But it was great. It was such a big deal because I'm sure they have to rewrite a lot of their curriculum. But, you know, it really says, you know, we're going to try and be a little bit more modern in the classroom and prepare people and have them get real life job skills before they get to the job. So,
Well, and that's another
yeah.
thing you bring up, and I'm sure you cover it in Code Newbie and on the Command Line Heroes podcast, is there's a lot of business around that isn't just writing code.
Yes.
There's Git trees, there's the politics of merge requests, there's your build tooling
Yeah.
and all this nonsense.
It's like
that
an ecosystem.
It
Yeah.
is. And this is one of the things, you know, you talked about some of that early frustration that people feel. I know I've been there when I don't even have a code problem.
Yeah.
I just can't access the code or get it to build or
Yep.
something, and I feel so stupid.
Yeah.
And it's, you know, I'm in a company or something when I was an intern or something, it's like, you can't Stack Overflow that because
Yeah.
it's this company's bizarre build system, right? And if you don't have a community of people around you sort of supporting you and helping you, you know, on board with those kind of processes and letting you, making it okay. Someone will say something like, oh yeah, someone senior than you will say something like, oh yeah, this is a pain in the butt. And all of a sudden
Yeah.
you're emotional. You're just like, oh,
It's-
it's okay. I'm not stupid.
Yeah. It is stupid. Or we are stupid together. Either one.
We made some poor choices when
Yes.
we chose this build tool.
And now
Welcome.
yeah. Yes, exactly. There's so much around. I mean, configuration is the hardest part. We have a conference that we do called Codeland, and we have workshops that we do. And the trickiest part about the workshops is saying, okay, here are the things you need to download. We may not have great internet at the conference. Please do it beforehand. Of course, most people don't listen. So then we have to have like a help station, and like that's the hardest part. The hardest part isn't even the things that happen in the workshop. It's all pre-workshop setup stuff.
Absolutely.
That's just a lot to go through. And that's the part that I think is so easy to feel demoralized by, because when coding is hard, it's like, well, I'm learning a new thing. But when setting up to code is hard, it's like, if I can't even get it started, how on earth am I going to actually build anything with it? So it can really hurt. You know, it can hurt you very deeply if you're
It's
not
so,
used to it.
So demoralizing.
So demoralizing, yeah.
We encourage all of you to become software professionals.
Yes,
there
of
are good
course,
parts, we
yes.
promise.
Just a couple.
So with the Command Line Heroes podcast, how
Yeah.
did you get started with that, and where's the direction it's headed?
Sure. So with Code Newbies from the Twitter chats, we started doing podcasts. So I actually do 2 podcasts, the Code Newbie podcast, which is interviewing one-on-one developers. And then we have another show called Base CS, which is teaching computer science concepts. So for all the people out there who've been, you know, coding professionally for 10 years, but never got that CS degree, if you're feeling a little self-conscious, that's okay. We made a podcast just for you. So through my podcasting work, the folks at Red Hat, I guess, heard about what I was doing, what I was up to, and you know, I like to think I have a unique combination of being able to talk and code, you know, those two kind of are nice to go together. And so that's kind of what got their attention. And so from there, we started brainstorming about what the first season would be and what the second season would be, and we're now working on a third season. So yeah, it's been great. It's been a lot of fun.
Yeah, the Command Line Heroes podcast is pretty well renowned in my little corner of the internet. It's like everyone's like, oh, there's another one came out, go.
Yeah.
And everyone's buzzing. Oh, we got to make something like that.
Yeah.
So you're, you know, if imitation is the highest form of flattery, like, what is the format you use to record, produce, and publish?
Oh, that's a great question. So production is quite a bit of work. There are a lot of people involved. I feel like I'm very lucky to be the host because I kind of get to take credit for everything, but like I probably play the smallest role in the whole thing. We have an amazing production team that takes care of the sound and the jingles and the sound effects and does the sound design for everything. We have a person who actually like writes the script, and I'm involved in that writing process as well. I voice the script, of course. I voice the show. I do all the main interviews in the show, and then it goes through like Red Hat and the production team, and everyone just really gets to have some say in it. So it's, you know, it can get a little messy because there are lots of people that are involved, but we always end up in a very, very good place. But for me, you know, people might be interested to know, I record in my closet. So I have a walk-in closet at home surrounded by clothes. And then I have
soundproofing.
Yes, I don't remember who told me this, but someone mentioned it in some blog post I was reading, and I thought, no, that's so silly. That's not, I'm going to feel like an idiot. I do feel like an idiot, but it's totally worth it. So as long as I don't have my video on, we're good.
Yeah.
But yeah, that's where I record.
I mean, we have a remote office, of course, right? There's a clear, like, nobody's on video chat before like 10, 11 a.m. You know, none of these 7 a.m. video calls. We're not doing that.
Yeah, it's actually a little tricky because, you know, your voice is a little rough in the morning. So I have to be careful not to record too early because then it'll sound, like you can hear the sound difference, you know, with my morning voice like this and then my normal voice throughout the day. So yeah, it's interesting little things you think about when you have to produce a show.
Well, and the production value is coming out, and it's such high quality that, like, you know, every little thing. If you were shooting for a lower bar, you could act that way. But, you know, you're coming out at the top.
Yeah.
So the format of the thing is not really guest driven on Command Line Heroes.
That's fair to say. Yeah.
What would you say is the format that you try to present to the users?
That's a great question.
Listeners? We have linked to it in the chat, so people can follow it out.
That's a really good question. I would say it's topic, it's message focused. So we'll start with OS Wars, for example. We really wanted to tell the story of how did we get to where we are today and what does that look like. And so for that, sure, we had some interviews and that helped enhance the story and make it really come to life. The sound design and little sound clips we used helped really animate it and really make it really exciting. But really, we wanted to give developers an opportunity to almost learn about their roots, you know, for folks who've been really in the weeds coding and didn't, you know, kind of look up to figure out, wait, how did we get here today? That's really the message. So with each episode, we think about what is the message we're trying to deliver and what's the story, what's the takeaway, and then we build around that.
Awesome. That's great stuff. So you had a talk yesterday, I believe?
Yeah.
You want to give us the broad strokes of what that was?
Sure. It's called The Magical Living Room. It's about a living room that is magical. And it's called Building and Nurturing Developer Communities. And so for me, obviously, I'm a big community person. And that's the thing about podcasts, too, is when you hear podcasting, you think it's about just the audio files, but it's not. It's the community around it, right? Because if no one listens, then I'm just talking to myself all day. And that's fun, but, you know, it's not really the point. And so the community is a huge part of it. And with CodeNewbie, everything we do is around supporting and creating community for folks. So I realized that between Command Line Heroes and the stuff that I was doing for CodeNewbie, I learned a lot of stuff about community development. And I learned that there's a process built into it that I didn't really appreciate until I wrote the talk, really. And it was this idea of understanding your community, building for the community, learning and, you know, kind of taking feedback and criticism and being okay with when you're wrong, and then iterating based on that learning and that feedback. And so I basically start the talk with my mom and how my mom is the best community builder and organizer there is. She truly is. And how for her, it was about nurturing the Ethiopian community, because I'm Ethiopian, I'm an immigrant. And so for her, it was really about taking this relatively vulnerable community. You know, if you think about immigrant communities, they're traveling from so far away, they're in a brand new place, they're not always safe, they're not always, you know, welcome and wanted. And it was about her creating the space in her living room, filling us with good food and good music and good conversation, and helping this community feel like we can be who we want to be. We can live the lives that we came here to live.
You can have a home,
You can have a home, a true home. And so just watching her I realized that I was copying her a lot when I was doing Konumi, and even how we talk about Command Line Heroes. Like I'm taking this approach of like, okay, I'm the host. I'm bringing people to my living room. What am I feeding them?
Same checklist.
Same checklist.
Yeah.
Yeah, exactly. So I built a whole talk around how those lessons growing up really translated to the work I do with developers.
So, well, do you want to pick one or two broad strokes of the ways that you take those lessons from your mother and
Yeah.
apply them to developers and tell the Twitch stream?
Yeah, sure. That's a great one. So one of my favorite examples is that my mom is always solving these little problems. And my favorite example of this is Thanksgiving. Actually, this was maybe 3-4 years ago. So we don't do Thanksgiving in Ethiopian culture. That's an American thing, in
Yeah.
case you didn't know. And so, we celebrate it because we're in America. But we have our Ethiopian food dishes, and then we have our like Thanksgiving turkey and mashed potatoes and stuff. And one year, we forgot the gravy.
No.
I know. And I said, oh my God, we forgot. Like, what are we going to do? Are we going to go to the grocery store? Is it open yet? Are we going to have to go to the gas station? We're going to get gas station gravy, I got really, really
Open the
concerned with the
package.
packet. Yeah, how's that going to work? And so my mother said, don't worry. No problem. I'll figure this out. And in the middle of really the start of dinner, everyone's around her in the kitchen. She rolls up her sleeves and she grabs the flour and the spices and the turkey juice. Is that what you call?
Yeah,
Okay, great.
Yeah, the leavings, I think.
The leave. Is that really what it's called? The leavings?
I don't know
that
what it's
doesn't
called.
sound. I hope
It's all the
that's not
stuff
what
left
that
over
is.
in the bottom
Yes,
of the pan.
the bottom of the pan stuff. And she takes that and she whips together the most amazing gravy that you've ever had. And for me, this was such a big deal because we don't eat gravy. Like, Ethiopians do not eat gravy. We don't know what that is. It's not a part of our cuisine. Our sauces are made from onions and spices. So the fact that this Ethiopian immigrant woman just figured out how to make gravy, in the middle of Thanksgiving was just amazing to me. And let's be honest, like, if we didn't have gravy, it wouldn't have been ruined. We had lots of other dishes, but she took that little problem and she said, she could have said, it's not a big deal. She could have said, get over yourself. You're lucky we have turkey anyway. But she said, okay, I'm going to fix it. I'm going to figure it out, and I'm going to do it in, 10 minutes, and it's going to be delicious.
Yeah.
So what does that look like for community? How do you translate that, right? And it might be taking every single, bug fix seriously, right? It might be taking every single issue seriously. It might be just taking a moment to say, hey, here's our code of conduct, putting that up. There are all these little things that for us may not feel problematic. Maybe it's fixing a typo on a website, right? There are plenty of times when someone will email me and go, hey, like there's a typo on the website or there's a broken link or something, and I'm like, I gotta do this other thing that
I have a million things to do.
I have a million things to do. I'm a busy person, but those are the moments when you get to really show your commitment to community, because when you take those things seriously and you act on them, you build this consistent, little acts that build trust in the long run. So things like that.
Leadership and also ownership.
Yeah, exactly.
Right? I'm not gonna wait for this to be fixed by someone else. I'm not going to try to assign it to someone who doesn't want to do it. I'm just going to say, this needs to be done.
Yep.
Roll up your sleeves and just execute.
Just got to get it done.
Yeah.
Yep.
And I think that's really powerful because especially people on the community side of these open source projects have so much invisible labor.
Yes.
Right? It's
exactly. No one can
most
see.
developers are like, oh, we need to fix the core main loop and optimize it down to -3 seconds. Okay. Everybody wants to do that work. Typos on the website, no. T-shirts, no. Stickers, no.
Oh,
but then when we get there on the day of, it's like, why are there no T-shirts?
Exactly.
Who does this work?
Yeah, exactly. So much of it is in the dark. So much of it is, private emails, private DMs. And it's just these things that no one really knows about, no one appreciates. One of the things that we did for Codeland, the conference, is we created these booklets. Because the problem for our community is they sit in these technical talks and they're excited to be there, but then the talk goes over their heads, right? They hear a bunch of jargon, buzzwords they're not familiar with. And so we said we want to make sure no one gets lost in our conference. And so we created a cheat sheet for every single talk.
Oh, that's awesome.
It was great. It was a ton of work, though.
That is a ton of work.
I mean, I spent, I think, a week just figuring out what the right color of yellow was so that it showed up on the paper, but it wasn't like too brown, but it wasn't too, just like that took like a week of my time. No one's going to pay attention to the yellow. No one's going to look at that and go, it doesn't look like poop. That's wonderful. No one's going to do that, right? And so there's all this, the invisible labor that goes into something that feels as, even as tangible as a booklet. There's so, even just literally picking up and carrying hundreds of booklets to my car was like a whole thing. And then getting it in the suitcase to fly over to New York City was a whole thing that no one will know about.
No one will know.
Except now.
Except now. Twitch knows. No, and that's true. And I think every vibrant open source community I've participated in, which has been a couple, there are a few people, unfortunately disproportionately women, get assigned that work. And we should fix that, everybody. But there's a lot of just, it's moving booklets around, it's getting T-shirts.
Yeah.
It's as you said, the private DMs between like, oh, there's maybe a little personality conflict between these two major contributors,
Yeah,
and for
yeah,
some
yeah.
reason that's my problem to deal with.
Yeah,
It's
yeah,
like,
yeah.
No, I don't want to do it.
Yeah, exactly. Yeah.
Just making sure, and there's also, it's a good thing that there's a lot of corporate involvement in open source, but that is another thing that needs to be managed.
That's true. Yep.
Especially one of these kind of party projects where there's multiple stakeholders from different companies, and they have some budget for this, but they need some result out of it, and it becomes the community leadership job to sort of manage that relationship, get those wheels greased, and then make sure that the event or the release or whatever is a big win for everybody, so that they're going to stay invested and be around for the release after that.
Yeah, exactly. And for us too, like we run on sponsorships, so even us picking who we work with and who we take money from is a thing that has to be managed. We have to send the right message and make sure that's properly put out there, and we have to make sure we partner with good people, and that's a whole other thing that keeps me up at night sometimes
I'm
too.
sure.
Yeah.
So for the people in the chat, we have a lot of people in the chat who are we're not too sure what our demographic is, but there's a lot of people who are like relatively new to programming, and so Code Newbie is an obvious thing. What's the the way to get started?
Sure. The way to get started is probably the podcast and the Twitter chats are the best way. The podcast is great because we do technical topics, like really beginner friendly. We actually had one on compilers and interpreters that was like really freaking good. I thought I knew how they worked, but then I did the interview with the guy and I said, okay, now I really know how it works. So we try to do a combination of technical and then non-technical talks too. So just interviews of people who, there's one of my favorite people, Becca. I can't remember her last name or else I would say it. We had her as our season opener for the season, and her whole thing is she has 4 kids, pretty young kids, I think under the age of 12 or 13, and she was learning how to code as a form of therapy.
Oh, wow.
And she had PTSD, and she used coding as a way to distract her and really help her heal. And it was just a beautiful story of strength, and then like managing being, a mom and learning how, and it's just an amazing, just tears all around. And it was just an inspiring story. So we try to get, a combination of the emotional journey side of things, and then the more technical, okay, let's start coding side of things. So getting a start there is probably a good place to begin.
Right. I think that's really useful because there's a lot of conversations around mental health, and like way too many people focus just straight into the code and not, we talked about it a little bit earlier, but the business of being a programmer as a professional can be taxing.
Yeah, and there's so much pressure, I feel like, to, even with open source, as amazing as it is, there's so much pressure to always do open source, and every side project you do should be a coding project, And if you've been at work, coding for 8 hours a day, it's okay to take a break,
Yes, it is.
It's okay to play some ping pong or, watch some TV. So I think there's this, constant pressure that sometimes can go, in a negative direction of folks feeling like they have to be on their coding game 100% of the time. And if you want to, that's great.
Yeah.
But you don't have to.
And that ties into the, Mako Hill has some research out that says, basically the average number of maintainers for an open source project is exactly 1. And how we completely overload someone who has a popular library on GitHub with just senseless demands.
Yep.
And, I'll pick on IBM because I work here, you get your Fortune 50 company like IBM, like engineers there demanding somebody who is a volunteer, please fix this bug and release it immediately. And he's like, he or they is usually like, I have a job and I do not get compensated for this library. I will try, but it is taxing and it's emotional, and especially when the project gets really popular because it's just useful. That kind of emotional baggage, we don't do a good job of compensating that person or helping them with their emotional baggage when we have a very small project.
Absolutely. Yeah, the idea that the person is a volunteer gets lost. As soon as you put something out there and you publish it and people use it, you're basically your own company, apparently.
Yeah, and you're expected to have communicate with the community about releases, have a completely up-to-date README. This documentation has this bug, fix it right now.
Yeah, it's
integrate with my service now.
Yeah.
What?
Or else I won't use this free thing that I'm not paying you for.
I will be mad on the Twitter.
Yeah. That would be a great t-shirt, by the way. I'll be mad on the Twitter.
All right, everybody. Thanks for coming by. We're going to take a quick break. We'll be back with our next guest, who is we're going to go into the blockchain part of the afternoon. So we're going to have a lot of blockchain for the next hour or so. My guess is
I'm not going to help you.
It's Sorna?
No. Okay, I'm going to help you out. Ready?
Is it Saran?
Yes.
Okay, sorry.
Think about it this way. If you know Harry Potter, right?
Yes.
Okay, thank God. If Harry Potter's best friend were knighted.
Saran.
There you go.
That's really funny. All right, there's 2 podcasts. One is the Code Newbie podcast. One is the Command Line Heroes podcast. There's links in the chat. We'll be back in 5 minutes. Thank you so much for coming on the show.
Thank you so much. This is awesome.
Hi, everybody. Welcome back to the IBM Developer Stream. We're live from San Francisco, I think. My guest is Horia.
How's it going?
Good, man. Thanks. Welcome to the stream. You were on yesterday.
I was.
Yeah, and you're kind of our blockchain expert on Twitch these days.
I try to be.
Yeah, and we're kicking off Blockchain Afternoon because for the next couple hours it's blockchain content. We have a couple things. One is that Call for Code 2019 has been announced. There's links in the chat and below. So get your teams together. It officially kicks off March 25th, but you can start working right now. And then proposals for that are due sometime in July. So get there, opportunity to win $200,000, write some code that's going to do some good. We also have a Coursera link below for 50% off of a specific Coursera course. So you can use that, hop on and learn some cool stuff. So with that, let's dive into the blockchain.
Awesome. Yeah. So today the topic is developing blockchain networks with Hyperledger 1.4. So this release in Hyperledger came out, I would say a month or two ago. And it's got some really good improvements in terms of the actual programming model, and I'll kind of go through an example from 1.2, and then we'll compare that to 1.4.
Okay.
And it's going to be the same app. It's doing the exact same thing, but you'll see that the actual code it takes to implement and to run the app will be almost 50%. So this new Hyperledger release really cuts down on a lot of the code to run your network and to actually build and start building your app. So
it's sort of a developer-focused release.
Exactly.
Awesome.
So I think it's pretty exciting stuff. So yeah, let's go ahead and get into it.
Do you want to give everybody like 3 sentences on what Hyperledger Fabric, and the foundation are?
Yeah, that's a good point. So a lot of confusion happens when people think of Hyperledger. They think it's IBM product, which it's not. So Hyperledger is an open source project, and it's hosted by the Linux Foundation. And within Hyperledger, there's about 9 projects. So Hyperledger Fabric was the first one, and it's the first one that GA'd. But there's also about 5 others. So there's Hyperledger Sawtooth, and that's led by Intel. There's Hyperledger Fabric, which is the one that was created by IBM. And of course, it's still open source. There's Burrow, which focuses on Ethereum smart contracts. And then there's Indy, which is focusing on decentralized identity. So they're all really cool projects. You can actually use Hyperledger Indy in Fabric, which is pretty awesome if you want to plug and play in terms of identity. Yeah, that's kind of a little bit of background.
Yeah, and all these projects are Apache 2, maybe?
That's right.
They're all open source. They're all hosted by the Linux Foundation. There's a Garrett. You can just go nuts.
Yeah.
Cool.
So yeah, again, Hyperledger is private, and it's a permission blockchain, so it is a bit different in terms of Ethereum. Ethereum was introduced as a public network, and it's using proof of work as the consensus algorithm, which is completely different than Hyperledger. But this is really meant for the enterprise. It's meant for fast transaction output, and that's what Hyperledger really specializes in.
Okay.
So
the key here is provenance?
Yeah.
Okay.
Exactly. So, yeah, for now, let's go ahead and dive into some of the concepts. We don't have a huge chunk of time, so I want to kind of just dive into the code.
Yeah, let's do it.
So everything looks good on the screen so far. So right now we're on the Hyperledger Fabric Read the Docs. This is kind of your one-stop shop in terms of learning Hyperledger and learning about the APIs, the programming model, the architecture. This is kind of where you want to find all that info, and I think it's a really great site. So in here, we have our introduction, and what I really want to talk about today, we can kind of look in what's new in 1.4. But one of the major releases is that we have long-term service support. So that means I think for 1 year they're supporting Hyperledger, which before in the previous releases they actually never provided support or long-term support. So this is pretty big.
Yeah. So it's a 1 dot, right? And we're saying it's an LTS. So these APIs will be stable. We're not going to break your workflows, which is also we're ready for use.
Exactly.
We're ready for use in bigger, more ambitious projects, and we're ready for developers who are comfortable with less risk to jump on the project.
Exactly. So that was a big announcement. The other thing is kind of what I want to focus on today is this improved programming model. And that's kind of what I'll show you. And this improved programming model just leverages a new NPM module. Oh, I guess you don't need to use Node, but I'll be focusing on Node. But it uses a new API, and it really cuts down on a lot of the code to get started and to submit transactions on the network.
Awesome.
Today we'll work through a sample tutorial. So if you go to just tutorials on the Hyperledger Read to Docs, we can go into the commercial paper tutorial. And this is a bit more complicated. So it's actually, you can think of it as kind of issuing bonds or a stock or something like that.
Okay.
So essentially in this tutorial, we have a company called Magnetocorp, and we have a company called Digibank. And essentially, Magnetocorp is going to issue this bond for I don't know, it can be any amount of money. And what Digibank is going to do, it's going to buy that bond, and if it holds that bond for that maturity date, it's gonna make them some money. It's going to give them some interest.
Sure.
So that's kind of the scenario, and we'll work through this a little bit. So at this point, let's go ahead and show you, just before we dive into this one, I want to just show kind of the differences between 1.2 and 1.4.
Yeah, I think that's a great idea.
So I got here our 1.2 FabCar sample app, and kind of the main. So let me back up really quick. If you go to github.com/hyperledger/fabric samples, this is I think is the best way to learn developing with Hyperledger. So here they have a few different tutorials. One is the FabCar. I think that's a really good one. There's the first network, which is pretty good too. They have the basic network. So these are all different tutorials you can try to learn and to experiment with Hyperledger. So if we click on the FabCar tutorial and we go on enroll admin.
Okay.
Actually, let's just go look at Invoke. So if we go to Invoke, this is the file that's actually going to send transactions to the blockchain. And so here I'm just going to run through this real quick. You can see at the top we're creating a Fabric client. Let me zoom in a little bit to make sure everybody can see well.
Yeah.
So we got the Fabric client up top, and we're using this API here. And then you can see we're creating the channel, the peer, the orderer, and then we're adding that orderer to our channel. And then now we're doing the cryptography part. So we're creating a public private key pair, and we're doing that by creating this new crypto store, and that's kind of our wallet that holds our keys. And then after that, we're getting this context. So right now we're looking for we're looking into our wallet, and we're going to grab these keys, and then we're going to use those keys to actually invoke a transaction.
Got it.
So essentially in Hyperledger, every time you issue a transaction, you need to sign that transaction with your public and private, or with your private key.
Got it.
So that your identity is shown onto so the network knows who's making this transaction, and it can be traced back to that person.
Yep. And that's all X509 certificates, right?
Exactly.
Yeah.
And then this is kind of the meat of the request, where you actually tell them which chain code to invoke, which function, and which argument. And then the actual API is the send transaction proposal.
Okay.
So that's more or less it. Then you get the results, and then you get your status code if it's 200, if it's 400, 404, essentially.
And
so
that's basically whether or not it was successfully written to the blockchain or not?
Exactly.
Awesome.
Exactly. And that's more or less it. Yeah, so we call this send transaction, and then now we have these events that are generated, and that's kind of more or less it. So if you look at just this file, it's about 160.
Oh, and it's all in a giant JavaScript promise?
Yeah, exactly.
Just then rest of program.
Pretty much. Yeah, so this is the 1.2 FabCar.
Right.
So let's go ahead and check out 1.4. So here we'll go in the same file where we just switch the release. So if you click on the branch, you have all these different releases from Hyperledger 1.0, 1.1, 1.2. So now let's move to 1.4. So you'll see now it looks a bit different. So we're still using, wait, let's see if it's the same one. I think it might be the same. Okay, yeah. So we're actually using a different NPM module. This one was Fabric Client. Now we're using a Fabric Network.
Yeah.
And this is kind of the new improved programming model that we were talking about. So we're still essentially doing the same things. So we're still looking for our wallet, and here's our wallet path. We're still checking that this user exists. So we're looking for if user 1 has keys in their wallet. And then this is kind of where the code is, I think, is a lot better. Essentially what you do is you create this gateway, and this is looking for your Docker containers, especially your peer, your ordering service, and your certificate authority. Once it finds that network, it connects to the network, and it passes in your identity. It looks for your wallet, passes in the identity, and then it connects to the channel. So we pass in our channel name here. And then we, again, the same thing, we have to reference which chain code or which smart contract.
Right.
And our smart contract is called FabCar. And then the last thing we do is called a submit transaction. So kind of similarly.
Yeah, that's way less code.
Yeah, so similarly how we did it in here, where
Yeah,
we
we
did
had a
like
submit proposal.
Submit
Yeah.
proposal. It's kind of the same exact thing. Essentially now we can just do contract dot submit transaction. So, and then you're still kind of doing the same thing. This is the function argument. So we're calling the create car function, and then we pass in the arguments.
So where are we doing, on the other one, we had a whole component of like submitting a proposal and then checking the error codes and stuff. This sort of looks like it basically just fires the contract and executes the program and terminates the program.
Yeah, so I think it's actually doing that, more of that stuff under the hood.
Okay.
So you'll still get error messages and you'll still get error checking, but a lot of that is happening under the hood.
Yeah, but as a programmer, as like a user of this API, like how do I we're not assigning that to a var and we're not passing in a callback or something. So how do I, take action once I know that's been completed?
Oh yeah, so
or is that what the await's doing? Is the await making it not asynchronous?
Well, so one thing you could do, so usually what I do, so in terms of debugging and checking your contracts, you can set this submit transaction to a variable and then see what's inside or get that response back.
Right.
Another thing you can do is, and I can show this later, is you can actually get the logs from the Docker container. So in your chain code, while it's submitting this transaction, in your chain code, you can print stuff out, or you can return your response. So you can do that there too.
Okay.
So
yeah, and I would be surprised if I bet if we read the docs, I bet submit transaction also takes in a callback.
Yeah.
Because that's like a very obvious. Like I've been looking at it for 3 seconds.
Yeah. So I think we can go here, and then it returns it just returns the response from the transaction function.
Huh. Yeah, you're not passing a callback. Weird.
Yeah.
Well, I guess you could do it then.
Yeah. Well, the await is essentially the same thing.
Oh, okay. Sweet.
Yeah. So. So that's more or less it. So you can see it's a lot cleaner.
Very clean.
Yeah.
Very, very clean.
So now let's go ahead and go back and kind of, let's say we got 10 minutes here. So
it goes real fast.
Yeah. So
and just for everybody watching, Horia is absolutely our blockchain expert. So if you have questions about specifically Hyperledger or other generic blockchain questions, how to get rich, etc., please throw them in the chat. We'll be sure to get those answered.
Awesome. So we've shown you a little bit of just this is kind of just how you interact with the network. Let's go ahead and I want to show you a client app that actually is working on the network and submitting the transactions.
Right, yeah.
And
Sounds awesome.
So let me jump into the code editor. So I'm going to zoom in a little bit.
Just a little bit, yeah.
Okay. So here I've showed you the let's see. So we talked a little bit about this invoke function, and we kind of have this similar code here. And right now I'm running the commercial paper smart contract.
Okay.
And right now this is all using the IBM Blockchain Platform extension on VS Code. If you haven't downloaded that, I think it's a really good way to debug, deploy, test your contracts. It's really quick. It's a great tool.
Everybody highly recommends this extension.
Yeah, so what we have is you can see all of my smart contracts are packaged here, and we're going to reference this paper contract right now. And in our paper contract, if we go into our extension, it is kind of messy because I've been just like testing this a bunch. But essentially we have our issue transaction, we have our buy transaction, our redeem transaction, and then we have a query all. So right now I want to show you what's currently in the blockchain, and then we'll add some things to it. So right now I'll do node query. So this will show us exactly what's in the blockchain right now. So we have a few paper contracts, so we can see that the what's important here is this. Where is it?
Okay. Yeah.
This key, this 00006. So that's kind of the key for the paper contract. That's the paper number.
Okay. This.
And
yeah.
then,
all right.
and then the Magnetocorp is the company. The face value is how much this is worth. And so right now, let's go ahead and submit a new one.
All right.
Let's go ahead and run npm start. So this is a loopback app that has some models that is able to transact and work with the issue, the buy, and the redeem transactions of that smart contract. And I'll show you what that looks like now. So we're in loopback now, and we have our explorer, and then these are our controllers here. We have buy, issue, and redeem. And if you look, issue is going to create a new bond on the network or a new contract. And if we click on try it out, let me zoom in a little bit. We see our function arguments that this function takes. And all I did to create this app is I'm using loopback 4. So all I did was create, I did like loopback, oops, spelled that wrong. Loopback 4 example. So what I did is I created an example like to-do tutorial, and then I essentially created these 3 controllers with models, and then that's how we're
and you
interacting
go through the
with this.
and then also we're gonna have Cy Venom on in like an hour or something, who's gonna take us through loopback like first principles. So definitely stay with us.
Yeah. So okay, so we have our schema here. So I'm going to issue a new paper contract.
Got it.
So I have this little nifty thing that I can just copy and paste some of this JSON in. So do you have a random number for me for this paper number? What are you feeling?
7.
Okay, 7.
Is that, or do you need more digits?
No, that's
Okay.
good.
All
So
right.
we'll submit this paper contract. So issuer, we'll just say Spencer.
Okay.
And then I'll leave the rest here. Do you want to give it a bigger value? Or do you
Yeah,
want to
I
keep
mean,
it?
we're pretty important, so let's do 200,000.
Okay.
Yeah.
Awesome. So let's issue this.
Make sure there's some skin in the game.
That's right.
This is a unitless value, right?
Yeah, exactly.
200,000
Could be anything. Anything's.
pencils.
So we got a response body back. So we see that this has been written onto the blockchain. And now we can, so essentially we have our paper number, we have our issuer, we have the date and time, and then the maturity date and time.
Right.
So now if we just, I'm going to close this app for a second, and then I'll do node query.
Node query, yeah.
We should be able to see our new paper contract with Spencer in there, the paper number being 7, and then I kept that, where is it? The face value being 200,000.
Yes.
So that's all in there.
So when do I get my money? I get my money in November?
Next year.
Oh, God,
Next
that's
year.
so long.
Yeah, so essentially what we did, we just, let me show you actually that model too. What we did is we worked with this UI, and we submitted the transaction. So our loop, there it is. So we have our controllers, this kind of what's linking the UI to the smart contract backend. So in our issue controller, well, yeah, thank you. I was like, why are there red lines everywhere? I was like, this is working. So let me go down here a little bit.
Everything is fine. Pay no attention to the error messages.
So essentially, we have our models, which are right here. We have our issue model. So our model contains all of the properties of our object. So we have the issuer, the paper number, issue date and time, maturity date, face value.
Right.
And what we do is we use this model, and then we pass that into the controller. So where's the controller? Here it is. And then really what's happening is we have this request body, and then we're using this request body, and we're passing in all of these parameters and we're calling our blockchain client. So our blockchain client is really the last layer before we actually get to the smart contract.
Okay.
So
I mean, this is go ahead.
yeah, so it's really the last layer. So we have the UI, which is kind of the controller, then we have the blockchain client, and then we have the actual smart contract.
Got it.
So that's kind of the layers in this app.
Yep.
And of course, if you wanted to use something else like Express and like React,
Just write it
you're
yourself.
100%,
Yeah,
100% welcome to do that, and it would be still a very similar flow.
Yeah.
I've just used Loopback because it's like a nice way to create APIs.
Yeah, it's like pretty slick, actually, honestly.
Yeah.
Nice.
So let's go to our blockchain client. So in here, I have my connect to the network. This is to actually get the channel and to get the contract. And you see that we're referencing the paper contract, and this has to be deployed. If it's not, you won't be able to interact with the network. And then we have where's our issue? There it is. So we have our issue transaction, and we're taking in those arguments, and we're just calling submit transaction. And submit transaction is our Hyperledger API, which we were looking at earlier. It's that same one that's being used right here.
And so this is rewritten for 1.4 and not using the old stuff from like send proposal or whatever, send transaction proposal.
Yeah.
Right.
Yeah. And then, we're calling submit transaction, and that is just going to invoke our contract, which is right here.
So now we're actually looking at the contract that's been deployed onto the blockchain.
Exactly.
Okay.
So essentially, we're looking for a contract name issue. So if we look up here, where is it? Oh yeah, issue. So that's and then it takes in our issuer, paper number, issue date, maturity date, etc. So that's kind of the link. We got the controllers, we got the blockchain client, which is finally going to talk to our paper contract, which is deployed.
Yeah, and this is the thing where like there's going to be code in here that's like yes or no.
Exactly.
And then we could write something that would identify whether or not I actually had 200,000 pencils in my account or something. I mean, that's not written, but this is where we can do some basic logic and conditionals to see if this is like a legitimate thing. Like we could write some rules that say that you can't make a bond that actually reaches maturity date past February of 2020. Like say you can only get a maturity date of 1 year away.
Exactly.
And that's where we could have something that would reject the thing that we just submitted.
Exactly.
Okay.
So yeah, you can see it's only 5 lines of code for this contract. So there's no error checking. This is literally just the bare bones. I think this was meant to be like least amount of code with some functionality.
Yeah.
So it's just to get you started. But of course, you can make this as comprehensive as possible.
Yeah, this is exactly where you write whatever your business logic is, right?
Exactly.
Yeah.
Yeah.
If your rules are Spencer can only do 1 transaction a year, this is where you put that limit.
Exactly.
Cool.
So one thing I want to end with, I have this commercial paper loopback code on GitHub. So where's my profile? And then I'll go to the repository.
I did not know that button was over there.
Really?
Yeah. Well, they changed the UI a lot on this website.
Yeah. So here's my commercial paper loopback app. So if you want to just go ahead and clone it, run it, everything, it should be working. You just got to deploy the commercial paper contract. And one last thing, I told some YouTubers that I would update my blockchain bean project.
Okay.
So So this has been a project that's been under construction for a while. This is going to come out, and it's going to use exactly this loopback app that I showed, and the documentation will be there. So yeah, looking forward to creating that for everyone. And if you have any other requests that you want to see, any sort of apps, anything, just let me know. Send me something on Twitter, and I'm happy to do that. So
awesome. So what we're going to do is we're going to take a quick break. Horia is going to take over the hosting for the next couple of hours. We're going to have blockchain from Swetha. We're going to have Sai come on and talk about Loopback, which is you just saw it in brief there, but Sai will go into depth. It's for building APIs in JavaScript. And then we'll have Sai Struthi, who will come on and talk about machine learning and the model asset exchange. So stay with us. There's a Coursera sign-up link below. And, take over. Thanks for coming on. And
thanks, Spencer.
Have a good afternoon.
I will. Hey everybody, we're here with IBM Developer at Think, and I'm here with Swetha today, and we're going to talk about deploying Ethereum smart contracts to Hyperledger Fabric. So why don't you tell us a little bit about yourself, and then
Cool. So I'm mainly an open source contributor. Basically, I go to different open source projects and kind of make some developments, contributions there, and try to sometimes, if there are features that we really like, try to get those implemented into the community that we're looking at. Currently, I work for Hyperledger Fabric, and basically what I've been doing for the last year or so is been bringing in a lot of the Ethereum developer ecosystem into Fabric, and so that way we give Fabric users a new way to develop their smart contracts and maybe even give a possibility of them migrating their stuff over if they're used to the Ethereum style of development. And I can actually get started with that. So I think right before, if you're tuning in now, maybe you'll miss a little bit of the Hyperledger Fabric 101 kind of information. So I'm going to skip over that, though, because that was just presented. But what I want to talk about is a little bit about Ethereum, because when you come in from a Fabric world, a lot of these concepts don't quite make sense in Fabric. So the first one is accounts. So basically, in Ethereum, everyone has an account, but your identity is kind of hidden on it because all you have to associate an account is an address. Now, this address comes from a public key that the user would have generated. And usually there's two different kinds. There's something called an EOA, which is an externally owned account, and then there's contract accounts. So let's start with EOAs. That's basically a user account. And what it has is that the address, and the main or the big thing that it holds or maintains is your balance, your Ether balance. Now, Fabric doesn't have a native token at the moment, and as part of all of this EVM ecosystem being brought in, we are not introducing a token or Ether as part of it. So in terms of what Fabric deals with, we don't really need EOAs. We already know how to manage identities and users, so we're going to continue with that system. What we are going to do, though, is because the EVM works on that concept of addresses, we're going to make sure that you have an equivalent address in Fabric. And we're going to do the exact same thing Ethereum does, and we're going to generate an address from your public key. So there's always one key. There's always one address. It's not going to change as long as you don't change your keys. With that, that's kind of how we deal with user accounts, and we kind of generate that address on the fly when needed, but not really stored anywhere. Now, contract accounts, these are a lot more important in my opinion, because they actually store the smart contract code that we're using when we deploy anything or when we want to interact with the ledger or anything. You're going to use that contract code. Now, the contract accounts, how it works is, again, it also has an address, and then it has the compiled runtime bytecode of the smart contract that you initially deployed. Now, this is really important, and so we're going to keep this, and we're going to bring that concept over to Hyperledger Fabric, which means we will be storing contract accounts and the contract code on the ledger. Now, this is different from how Hyperledger Fabric deals with chain codes, because chain codes, the code and everything is actually stored on the peer file system, which is basically the nodes in Hyperledger Fabric. Because of this change, there is a difference in how you would deploy and how you would get everyone to have the same version of the contract code. With that, that kind of covers accounts and how we are dealing with them in our new solution. The next thing is gas. Now, if you're familiar with Ethereum or the Ethereum virtual machine, which is what EVM stands for, basically how it works is that it has different opcodes, and each opcode has a gas price. Basically, you need to pay per opcode that you use. And it's been put in place because when you run a transaction on Ethereum, you're running it on tons and tons of machines, and you're using up a lot of resources. So it's really to incentivize the developer to make smart transactions, so that way you know your costs, you have to pay more to have a longer transaction. Now, Hyperledger Fabric use cases are more business oriented, and usually if a transaction is doing something, there's a real need or a cause behind it. So because of that, we're not going to have that system of pay per opcode. But gas is integral in how the Ethereum virtual machine works. It's also, for example, if you have an infinite loop, when you run out of gas, the infinite loop will no longer keep running. And this is kind of like a nice little benefit there in case there's some coding error or something that occurs.
So you're saying basically like if there's an infinite loop, then like all the computers would be using all the resources, but a way to stop that is just to have this gas limit. Is that right?
Exactly, yeah.
Okay.
Because we can use this limit, and we're going to use it kind of for some of the protective nature, and also because that's how the EVM works, what we're going to do is we're going to give a hard-coded high limit. So basically any normal or arbitrary transaction should finish to completion, but if you have some kind of buggy code or anything, that gas limit will help you kind of make sure you're not having code that's just running infinitely. So we're going to keep that. This is a design point that we've decided that we're going to start with this, hard-code it, but we do see in the future if we get feedback or we think users would like it to be more configurable, we're very open to kind of changing how we use gas in our EVM implementation. The next thing is reading current transaction rights. Now, in Ethereum, the way things work when you run a transaction is when you are manipulating values within your transaction, you should be able to read the values that you just wrote, even if it hasn't technically made it into the ledger yet. Now, this is different from how Fabric operates. Their philosophy is that you wouldn't be able to read it because it's not in the ledger. And to give some more concrete example, let's take the value of A. A, let's say it starts off at 5. So when you start your transaction, you can say A equals 5. And then you modify it, so now A equals 7. But then when you read it again in the same transaction, it's still going to say A equals 5. Now that doesn't quite work with how Ethereum or the EVM is expecting the state to be shown. So because of that, we've implemented a cache, just kind of a wrapper for the EVM and when it talks to the ledger. This does not affect anything else in Fabric. It is only going to touch the EVM kind of smart contracts, but this is something that's different from how Hyperledger Fabric works, and it's worth knowing if you're familiar with the Fabric ecosystem. The next thing there is ABI. That stands for Application Binary Interface. You're probably never going to see those words. It's always going to be API. But basically, it's a schema. So when you create a Solidity smart contract, you're going to have a schema of it, and it basically shows you all of the different transactions that are possible, what are the inputs that are expected, what are the outputs. If you're more used to the Ethereum side, it'll also tell you is one of them is going to cost you something, is something going to be just more of a query, so that all that information is encoded in that ABI. Now, we don't really have to do too much in our solution to the ABI, but it's a great tool, and it's going to help us use some of the Ethereum tooling that we're going to get out of doing this work. And it's important to know about that. The next thing is the Ethereum JSON RPC API. Now this API is basically an API that Ethereum has produced and published and said, if you want to talk to an Ethereum network or an Ethereum node, you can use this API. Now what that means is all the clients are using that API to interact with their Ethereum network. What it also means, though, is if we implement that API, we can use those Ethereum tools to interact with the Fabric network.
So is this the only way to really, is this the only way to work on a Ethereum network? Is by implementing this JSON RPC API?
Well, you wouldn't implement it if you want to work on the network. If you want to like submit transactions or something, you would use something that has implemented the network. So basically the nodes that are in the network typically have this implemented, and then you can connect a wallet, you can connect an IDE or whatever tools that you have to that node, and those wallet and everything, it has the expectation that the node implements this API. So as a user, you really don't have to worry about it or know about it, but it's important when you're trying to build up the ecosystem. So since we're going a little more into the technical and seeing how this is implemented, that's kind of how we have gotten so much out of a little bit of work. And the last thing is message calls. So in Ethereum, basically every transaction is basically a message call, and you're submitting or you're sending transactions. So a user is sending a transaction to a contract. That's what invoking a transaction is actually like. And if a contract wants to invoke another transaction, again, it's sending a message from this contract to the other. And I have a few examples of what that means. So basically the three fields that we're going to be paying attention to is the to, the from, and the input. Now the to is who this message should be sent to, and that typically is going to be another contract. The from is who is initiating this. Usually it's going to be your user account address, and then the input is what is the actual message.
And the to is always an address, is that right?
Yes, the to is always an address, and the from is always an address.
Okay.
The input could be various things depending on what the transaction is trying to do. Let's look at two main things that people are going to have to use. And one is contract invocation. So you're going to send it to a contract address. The from is going to be your user account address. And then the input is going to be the function hash, which to generate a function hash, it's actually very simple. What you do is you do a Keccak sum. So Keccak is a SHA-3 supported algorithm. So Keccak, you do a Keccak sum of the function signature. So for example, and I'll give you an example when we do a demo, so that way you can kind of understand what those mean. And then after the function hash, you have encoded parameters. Now, EVM and Solidity, they have some rules. I'm not going to go too deeply into it. There's so many tools out there that you never have to figure that piece out by yourself.
So essentially with that function hash, you're just referencing a function you want to call.
Yes. And basically now the EVM knows, okay, this is the function from this contract that needs to be run. So the next thing, and this is kind of one slightly different from the contract invocation, is how do you create a contract? And that's just as important. Because you don't have an address yet, because you're trying to deploy it, you deploy it to the 0 address. Basically, it's 160 bits of zeros. And again, the from is still the same. It's your user account. And then the input this time would be the compiled bytecode. So now might be a good time to talk about how is this bytecode kind of generated. The expectation is you're going to still use some of the Ethereum compilers to do it. We're going to use the standard bytecode. We don't have to have any new kind of compilation or a compiler necessary for the Fabric EVM. It's all exactly the same, which is kind of nice. But it also means as part of the EVM that's going to be in Fabric, we don't give you a tool to compile your contracts. We expect you to do this on your own.
Okay.
And with that, let me start talking about how we've designed this inside of Fabric. We have two main pieces. So there's the EVM chain code, which is, for short, we call it the EVM-CC, and we have Fab3. Fab3 is basically a proxy that sits outside of the network, and it implements a subset of the Web3, the Ethereum JSON RPC API. And this is basically the tool that's going to allow us or open the door to all the Ethereum tools to interact with the Fabric network. And I can quickly go into a little more detail. So we'll start with the EVM chain code. Basically, it's a user chain code. So that means any Fabric users, if you're familiar with chain code development there, you can just take this and install and instantiate, and you follow the normal Fabric process. What this also means, though, is you're installing a chain code that is going to be running other smart contracts. And that's slightly different. And because you're going through a chain code, a lot of the other steps that is usually in the Fabric lifecycle won't quite apply here. The actual EVM code is coming from another project called Hyperledger Burrow. They have their own EVM implementation. They use the EVM as their sole runtime, smart contract runtime. So basically, this is what they use in their system, and we thought we should be able to bring that over into Fabric. And it was really nice. We could just wrap it around in a Go shim, which is great. And
so are you just copying and pasting this code from Burrow?
Basically.
Is that allowed?
Not quite copy and paste,
okay.
But that's the fun part of open source. Okay. Because we're all under this Hyperledger umbrella, this is something that we worked with the Burrow team.
Okay.
We talked to them, they walked us through their code, they showed us what are the things we needed to do to get this to work with Fabric. So it was great, and it's also kind of shows you how great collaboration can happen and the things that we can get out of it. And a lot of it is also due to the Hyperledger community, in the sense that that's kind of the atmosphere and the culture that we have over there.
That's great.
Yeah. And then the last thing you really need to know about the chain code is what are the inputs. So we only have one function in there. It's an invoke function, and it takes in to and input. That's it. And if you want to, just to kind of go recap, the to and the input are what we saw in the message calls, the to and the input. We don't need the from, because when you submit a transaction, you're sending us your public key, and we're able to figure out what your address is from that. So with that, let's move on to Fab3. So Fab3, as I mentioned before, it's going to be sitting outside of the network. It's just basically a proxy. It's not its own node or anything, but it is a way for people to interact with the Fabric network. It's going to use the Fabric SDK Go as the actual client layer that is talking to the peer. And it implements a subset of the Ethereum JSON RPC API. We have not completed the whole thing, and it's practicality-wise, we probably won't, because there are a lot of functions and API calls there that just don't apply to Fabric, and we don't find it necessary to have. And with that, I just kind of want to give an idea of how this flow would work. So basically, a user request would come through. It would be, because of the API, that's what it should follow. From there, the Fabric Go SDK is going to invoke the EVM CC into the peer, which brings in and sends in the arguments into the EVM container. From there, we have a tool called the State Manager. This is basically an interface layer that allows the EVM, which knows how to speak in Burrow, is going to be able to talk now into the ledger, the Fabric ledger. And basically, the first step is you grab the contract code from the ledger, and then after that, we generate reads and writes. And if you're familiar with the Fabric workflow, that everything else stays exactly the same. Now, because the whole idea here is to bring an Ethereum developer ecosystem in, let's kind of take a look at what Ethereum usually does. As a user, you're going to have to start up a node, something like Geth. Geth could be considered a full node if you run it in a full mode, and you can mine in there whatever you want to do. You can also use it as a light client. Basically, it's just there as an access point for you to submit transactions into the network. But it really doesn't matter what you do, you have to run this. From there, you're going to connect it to the Ethereum network of your choice, whether that's mainnet, testnet. There might be another one that you want to connect to, but this is kind of your tool. And then you use other tools such as Web3.js, which is a node library, so you can create applications. You can use IDEs like Remix, and that's kind of another layer, and it has a nicer user interface or user experience. So when you're connecting directly to Ethereum, you're not dealing with bytecode. And the difference between Ethereum and now Fabric really is that all you're going to do is, instead of Geth, you're going to run Fab3, and instead of connecting to an Ethereum network, you're going to be running to a Fabric network. So the workflow really is the same. And that's kind of a nice thing to say, because now when you migrate, you're not really having to learn a bunch of new steps. You're just following. You might have to learn how to run Fab3, but everything else is kind of taken care of for you.
That's really nice.
Yeah. So I kind of want to show a demo.
Yeah.
So that way we can kind of see how this stuff works.
So we got a few more minutes left. So yeah, let's jump in the demo.
So the first thing I wanted to show you guys is we already have a network. Usually this takes a little bit of time. And if you're used to or you've seen the Hyperledger Fabric networks, there is a Fabric peer. We have 4 here. We have 2 organizations, so 2 peers per org. And we have 1 ordering service we have 1 ordering node. It's running in solo mode, which is great for development purposes. And I've already kind of played around to speed up some of the container creation, but we have 4 EVM containers. So each one you can see which node it's actually associated to, because it has the peer that it's connected to. That's all really we need to see there. The next cool thing is, let's go into installing. So Fab3 basically is our tool that we've created. It's a proxy. It takes in a few things that we need. One is the config. This config is the same standard SDK config that we use everywhere, which is great. So you can just use that here. You specify the org, the user, and the channel. And then this last option, the CCID, technically, since it's a user chain code, you could use any other chain code name if you'd like. But we're going to use EVMCC because that's a standard and that's also our default option. Oh, whoops. Not in the right repo. Okay, let's try that again. And you can see we have Fab3 running on port 5000. Now, if we want to deal directly with the EVM chain code, it's a little messy because you have to deal with bytecode. So I'm going to start off using some tools just to get us started. If you're familiar with Ethereum development, you've probably seen Remix, just a great IDE. But let's just go through the contract and see what we have here. This is called Simple Storage. All it does is it's like a key value store, except it's 1 int. That's all we're allowed to store. The great thing about it is you can do things like check out the details here. It has the compiled bytecode for you, so you can just use that directly. You have that ABI. Basically, as I said, it has the schema and everything you have in it. And it also has like this Web3 is a Node.js library that gives you the code on how you can deploy and do everything from there. So that's a cool tool. But what's even nicer is if you go to the Run tab, you can click on Web3 Provider. And I already have my Fab3 running, so I can just put in the port that it's running on. And the second I do it, you can see that the Web3 provider here has a different network, and it says Fabric EVM, which is cool. This account is your user account address, which is nice. And that's really all we need to do. And with one click, I can deploy. We can see that it's running. We have some information. These are just basically logs about the transaction. And with that, let's do a simple test. I'm going to set it to 10. I can use this. I'm waiting. I see that the transaction has finished. I can do a get, and I get back the value, which is pretty neat.
So you can do everything in the IDE.
Everything you can do in the IDE. Now, just to kind of prove that we are using Fabric in the backend, and this is not happening in the browser, we can go into one of the containers in the network that have been pre-populated with all the credentials that we want to do. And all we're going to do, because the query is a little bit less, it's easier to read basically, which is why I want to show this as an example. So I'm going to say the name, which is the CCID. It's the same thing. We're going to have to say the channel, which is my channel. Again, these are the same arguments we passed into Fab3. And then the last thing we need to do is the args that we want to pass in. Now, if you remember earlier when I was talking about what this function is, we only do invoke, and we take in 2 arguments, which is the to and the input. So the to here is going to be the contract address. Now, since we deployed it here, the contract address is actually going to be this thing right here. So I'm just going to copy it right from Remix. Because we're interacting directly with the chain code, we have to just remove some of the hex delimiters and stuff like that.
Okay.
And then here, we need is the function hash. So if we go back over here, we go to the details tab, we go down, and they have function hashes. And before I was saying what it was, you see here, this is what the signature looks like, get and set. And if you do a catch sum of that, you would get the value on the end. Basically, you're using the first 8 bytes of that.
Okay.
So with that, I'm just going to do a simple get. And these values are hex encoded, so just so it's readable for us, I'm going to do that. And we can see we get A back, and A is 10. And it's the same thing. And we can do this, back and forth. So I do that, wait for the transaction to end, and then we can run this again. And we can see that the value has been updated.
That's great. That's pretty quick, too.
Very quick. Granted, this is a local machine, so everything's running on here, and you don't have that many transactions that are coming into this network. So, of course, a real production system probably will not have as quick of a latency as this.
Yeah.
But there are, differences, and this is part of, if these are the kind of features that you want out of Fabric, you don't have to you don't have to lose something like the Solidity language or Viper if those are contract language or those are the programming languages that you're comfortable writing things in.
That's awesome.
Yeah.
This is a great demo.
Thank you.
So with that, I think we're gonna wrap it up. So Swetha, thanks so much for that that great demo on the EVM. And for anybody that wants more info, you can go ahead and go to the Hyperledger Fabric, or the GitHub, right?
Mm-hmm. Here, I can.
So we can put that in the chat for everyone. So if you want to follow along with the project, you can go to Hyperledger/Fabric Chaincode EVM. And, we got blogs, we got demo apps. So, yeah, thanks so much for Swetha for coming in. And we'll have Cy Venom talking about text messages with serverless functions coming in next.
We think we have everything or anything under control, but we don't. The dam breaks eventually. The rivers rise. We have to do something very differently right now.
Just within the last couple of years, we have seen fires in California that are just unprecedented, and they're becoming harder and harder to put out. It's a catch-up game. It's always a catch-up game.
If we're hearing voices that we haven't heard before from communities affected by disasters, we should be listening.
There are influencers, there are people that can really be the voice, but the people that really do the work can be anybody. It could be you.
It's not that you're writing code, but you're trying to solve a problem. Bringing something to life that hasn't existed before. There are much deeper patterns in these natural systems than I think a lot of people realize.
It feels like a lot of pressure, but this is supposed to save people.
I've collected the data and given meaning to it. It benefits me as much as it benefits you.
The coder is someone who's actually coding the fabric of the next century. Through human engagement, human contact. This is where we have to make some of those very hard decisions. How quickly do we act? Why are we acting? And how grandly are we willing to act?
Yeah, my family.
Hey everyone, we're live here from Think 2019, and we're on IBM Developer here with Sai, and Sai's going to talk to us a little bit about sending text messages with serverless.
That's right.
A little bit switch up in the schedule. We had originally planned for loopback, but I think this is going to be a great topic, and I'm excited to see what you got for us.
Yeah, definitely. So just to kind of quickly introduce myself, I'm a developer advocate with IBM. Not only do I work with serverless technology, but lately I've been focusing with things like Docker, Kubernetes, hybrid cloud, containers, that kind of thing. So, serverless plays a big role in hybrid cloud environments. And honestly, I'm really excited to kind of show off some of the cool things that we have on IBM Cloud with functions.
Awesome. Let's get right into it.
All right, let's do it. So I don't have any slides or anything like that. I just want to show off cool code. So we're going to start with what we got here. I've already logged into my account. So on my screen, you should see kind of the dashboard for IBM Cloud Functions. Essentially, a serverless, if you're not familiar with it, it's a way to run actions in response to triggers. A big thing with serverless is that it supports a concept called scale to zero. Essentially what that means is if you're not using that service, whatever that code is that you're running, then you're not paying for it. It scales all the way down to zero. And then, granted, you get something like infinite scalability, right? Because taking advantage of all the cloud resources we have, if we have a lot of load coming in, we can kind of scale up.
Does that mean I don't even have to worry about that? Like, about the traffic coming in because it'll automatically scale that for me?
That's right. That's what's cool about serverless is, you can imagine a company might get a lot of people hitting the application on something like Black Friday, or if they're a clothing company and they get a lot more kind of traffic around the spring season, they would have to get systems and applications scaled out ahead of time in response to that load. With serverless, you get that kind of response to load immediately. Even with things like auto-scaling policies with traditional application deployments, the problem is the application first has to hit a high latency. Users have to get bad experience to first then get better experience, because it takes a while to scale out traditional applications. But with the serverless functions, with the way they're architected, kind of respond to that load right away.
That's pretty great. I mean, that's
pretty
really neat. You don't have to worry about scaling beforehand, and of course, a lot of times you don't even know when the next huge traffic on your site is going to be. So,
right.
If you're not prepared for that, then what are you going to do? But it seems like serverless at least has a pretty good answer to that.
Yeah. So today I want to show a simple serverless function that we're going to create straight from scratch. But instead of just doing something like a hello world, I wanted to hook it into a third-party service. Hooray! Have you heard of Twilio by chance?
Oh, of course.
Yeah. So what do you think Twilio is? What have you used Twilio for in the past?
So I know it's a good way to send text messages. I think they do audio and voice calls as well.
Yeah.
But I know if you need some sort of either a two-factor authentication or something like that, you can use their APIs to be able to send messages.
Right, exactly. And so Twilio essentially is a communications API. So anywhere from sending things like SMS, video, you can even, there was a really cool demo I saw the other day. There was a short code number, and you could text this number a name of a song, and it would actually give you a call back and play the song for you on the phone.
Wow.
So I thought that was pretty neat. It was kind of like a reverse Shazam, right? So
That's
Shazam,
really
you
cool.
would hear a song, it tells you what the name of it is. If you have the name of the song, but you want to hear how it goes, just text it, and it'll call you with that with that song playing.
That's
and
pretty cool.
you'd think these days I would just open up Spotify and hit the song. Well, imagine you had like only 4G or 3G. You don't have like an internet connection. You could just, as long as you have text and calling, you could hear a song that you wanted to hear, which is pretty neat.
That is neat.
So yeah, with communications APIs, there's a lot of options that become available. But today I want to show an integration with Twilio and IBM Cloud Functions. So one thing, you are kind of going to see my private API keys today, but it's a trial account, so if someone does want to take it, then go on.
You guys should definitely take it. I invite you to take all of his keys.
At the end of the day, I am probably going to just reset all of these tokens. So
he'll forget. So you should still.
Yeah. But what I've got here is two different dashboards. I've got my Twilio dashboard. I've created a project in Twilio. What I've done is I've got the account ID as well as a token, an auth token. And the one thing I'll say about Twilio, which is great, is their documentation is awesome. So for example, if I hit this button, say go to programmable SMS and hit learn and build, I can start playing with their dashboard right off the bat, sending text messages. I even have a phone number that they've given me, this one right here. So, and the one that it has in here is my personal number. But yeah, it'll be able to kind of send me text messages, which is pretty neat. But let's go ahead and get started here. So the first thing I want to do is start creating a cloud function. So I'll hit start creating. And
so where are we right now?
Oh, good question. So we're in the IBM Cloud dashboard. So this is
Okay.
IBM Cloud Functions, which is our flavor of serverless.
Okay.
Basically, I think comparable to something like Amazon Lambda. There's other serverless platforms out there as well. This is kind of IBM's version of the serverless kind of the take on serverless.
And is this free? Like, how would you get a cloud account? How would you get started?
Yeah, so creating an IBM Cloud account is free, and it's actually it's crazy the amount of free actions we provide. I'm forgetting the actual amount that we give for free. Honestly, I could probably find it really quickly, but it's something that I've never even come close to hitting. Just to kind of get started with functions, we give you thousands of API calls for free per month. So it's kind of a great way to get started with serverless.
So if someone wanted to replicate this app, would they be able to do this for free?
Yeah, definitely. So
Awesome.
go to IBM Cloud, make an account, and honestly, you could follow along and really just use the same sample code. Follow along the Twilio documentation. It's pretty straightforward. It's cool stuff.
That's great.
Yeah, so let's go ahead and get started. So first thing we'll do is hit create an action. So first I just want to make sure I'm in the right region, org space. Okay, everything looks good. I'm going to call this action Twitch text me. And we're running on node 10. Actually, I want to use node 8. I've only tested it with node 8, but really it should work either way. I'm going to hit create. So just like that, what we have is a serverless action. And believe it or not, this is in production. So
Wow.
with that click of
already?
a button, yeah, exactly.
Okay.
With just that one button, we have a serverless function running in production, and we can change it, we can invoke it, we can play with it right off the bat. So for example, if I were to hit invoke right now, within 250 milliseconds, it comes back and it says, all right, we ran this this serverless action. This one's really simple. All it's doing is messaging back hello world. But it kind of shows you with serverless, you don't have to think about deploying an application to production. You don't have to think about having that running on the cloud somewhere, worrying about the memory. You just write the code. It's truly a developer-focused kind of environment where you write the code and everything else is managed for you. At the end of the day, though, you do, as a developer, have to make certain considerations when you're writing serverless actions. It's not the same as traditional apps, but yeah, outside of that, it's really easy to get started.
And another cool thing that I've seen from serverless is like web actions, where you have that URL and you can hit that URL and then basically get this same result back. So that's another cool feature as well.
Exactly, and that's what we're going to get into, because creating a serverless action is cool, setting up a trigger is cool, but what's that next step, right? So there's concerns that you always have to tackle when working with APIs and production in general. So we're making a function that basically lets people text me. I don't want that to be, like totally accessible. If someone were to hit that 1,000 times, I'd get 1,000 text messages, like overrun my Twilio account. That's not okay. So, with any sort of APIs in production, you got to think about security. Things like rate limiting. So we're going to get to that in a second.
Oh,
here.
nice.
Yeah. And we'll see how easy it is to set up that kind of security on APIs when you're working with this platform. But regardless, I have some sample code that I've already kind of written. It's very simple. We'll walk through it in a second here, but I'm going to go ahead and paste it into my actions UI. So what I've done is kind of pasted it into my serverless action, hit save, and again, it's in production.
Let's go ahead and zoom in on that a little bit, just get that a little bigger, just for the viewers at home.
And actually, let's just go ahead and look at it in VS Code.
That works too.
Makes things a little easier. And close this over here.
Perfect.
It's a little bigger.
Nice.
All right,
looks
so
good.
let's talk about what we've got here. So with serverless, what you want is a function. It's called functions because at the end of the day, it's invoking a function. At the very beginning here, we have a function definition. It's a main. It's called main. That's the first function that a serverless kind of platform, our serverless platform hits. And you can pass in some params, but for our sake, we're actually having a default that's being used. We're using the promise library. Promise is just a very simple way to kind of say that this function is going to return something. Let's do asynchronous kind of function calls. It's much nicer than callbacks. When you have a ton of callbacks, it ends up this thing. It's called callback hell that you want to avoid. So these days, I stick with promises no matter what kind of functions I'm working with. So kind of working through the variables here. So 2, this is the text message, like the number that we're going to be sending it to. The body is going to be whatever parameters I pass in, or if I don't pass in any parameters, it's just going to say hello from serverless.
Okay.
We've got a few options here. Basically, these are something that I pulled directly from the Twilio docs. Copy, paste. It's the URL for the API that Twilio provides. The method that we're using to actually send that text message. My user password, user token, as well as password token. And then there's one more field here. We're talking about the number that it's coming from. So this is my Twilio number.
Okay.
And I can quickly kind of shift in context here, going to my Twilio dashboard. We can see that I've got one phone number set up. And if I go to phone numbers, we'll actually see that that's the phone number that Twilio is using to actually send text messages. So this one, it's one that's from Alabama. Regardless, you can make some custom phone numbers in here. I just had it create one for me by default.
Okay.
But once I get a text message, it's going to come from this one right here.
Okay.
So just like that, that's all it takes. Oh, actually, one last thing at the bottom here. Once we call that function, it'll basically do a log statement saying it's done, and then it'll even return a status saying that it's texted it. This is just so that as someone that's calling a serverless function, I just want to verify that it really did run and that Twilio didn't respond with an error. I can use this.
Perfect.
So let's test it out. So we'll go into the functions dashboard again. So this is an IBM Cloud where I've already pasted that code. And I'll pull my phone out and we'll turn it off as silent and load up my text messages. And actually, I could probably pull it up in here too. Yep, let's do it. I think that is my brother and sister trying to figure out breakfast plans for tomorrow. But whatever, we'll hit invoke. And there you go. If you heard that, I got a text message, and we'll check this right here. Load into a private screen. Say we got a text message from Twilio just like that, saying hello from serverless.
That's pretty quick too.
Yeah, it's pretty cool. You can see that the total time that took is 726 milliseconds. So that's everywhere from kind of spinning up that serverless action, which is usually under 100 milliseconds. A bulk of that time is actually going to be the API call to Twilio.
And then getting that response back.
Yeah, exactly. So it's actually waiting until Twilio comes back and says, oh, that text message is on its way. And then the serverless function says, okay, we did it. As opposed to the serverless function coming back instantly saying, okay, I sent it off. It'll actually go and it'll wait for Twilio to say, okay, we processed it. It's on the way. It's coming. And I'm getting other notifications now. But
so now everyone on the internet's going to text you, is that right?
They could, if they had access to this button in my dashboard, they could start texting me. But this is not useful in the context. We need to actually expose this. We need to make this something that is secured, authenticated, and then anyone can send me a text message as long as I give them permission to do so, right?
Okay.
So let's set that up. So the first thing I want to do is, so now that we've got this, very quickly, we can look at some other capabilities in the platform. For example, how long do I want to time out a serverless action if it gets hung? 60 seconds. What runtime am I using? Am I setting up any custom parameters? There's actually a public endpoint that people can use to hit this API directly. I can enable it as a web action, as you mentioned before, so that applications could call this, or I could pull up a browser and hit it directly in a browser as well. And there's a couple other things like setting up triggers and logs. But I want to show you that cool thing where I get to expose this serverless action. Maybe set up some rate limiting so people can't just spam me with text messages.
Yeah.
And then we'll go from there. So there's a tab here. So I went back to the actions view where I can see all the actions I have. Here we see Twitch text me. This is the one we just created. We'll go to the APIs tab. And what we have here is an option to create a managed API. And so very simply, so under the covers, actually, this is using a technology called API Connect.
Okay.
API Connect is our API management platform. Essentially, it lets you do exactly what we're about to do, but for any API, not just serverless, right?
Oh, wow.
So outside of the context of just IBM Cloud Functions, you can take advantage of this API management capabilities.
That's great.
But let's go ahead. So there's not even that much to kind of set up here. It makes it so easy for me to manage this API moving forward. So very simply, let's start with a name for this API. We'll call it Twitch Text Me API. The base path, no, I don't want something so long. Let's just do /API. And then the main thing we want is the operation. The path for this operation, let's just make it text me. We'll use get. We could make it a post so that people could pass in a custom text message to send. But for now, let's just stick with the default.
Okay.
We'll choose the action that is connected to Twitch text me. You can also see all the other Slack actions, or not Slack actions, but the serverless actions I have in here. Some of the serverless actions I've done in the past is to do things like sending Slack messages, not just text messages. So, the options are kind of endless, but this one we're using Twilio and texting. We'll hit create. There we go. And first thing I want to do, I want to set up authentication because I don't want just anybody to be able to hit this API. I'll stick with the defaults here. API key is fine. API key and secret seems a little overkill right now. Here's the big thing I want. I want an API call limit. So I want a maximum of, let's say, 4 calls a minute. I know that sounds kind of like a lot, 4 texts a minute. So in the future, I might change that. But for now, for the sake of testing, we'll set it to 4 per minute. So basically what that's saying is I don't want anyone to be able to hit this API more than 4 times in a minute. There's a couple other options here, so things like using OAuth to authenticate users, and then at the bottom we also have the option to enable cores. Essentially, it allows browser-based applications, so web applications, to run those APIs on the front end. That's something that you may or may not want to enable just because it has the kind of option to be abused, but in this case, we're not worried about it. We're going to go ahead and expose that serverless function.
Nice.
Okay, base path is not unique. Great. Okay, so we have an error. So I have another API managed that uses that /API. So it's saying, let's make this unique. So let's say text me API. Hopefully I haven't used that one before. Hit save and expose. And in a second here, so essentially what this is doing, so the way API management works, so you can imagine if you're the user over here, you've got your serverless function in the cloud over here. what in the past, before we set up API management, those communications happen directly between the user and the serverless function.
Mhm.
What we're doing here is we're essentially setting up a gateway right in between. It's called an API gateway, and we're saying, okay, only certain people are allowed to go through that, and then we can even change like how big that kind of that hole through the gateway is, right? So rate limiting, like how many times you get to hit that backend endpoint.
So is this kind of like a bouncer at a bar, checking for IDs and like, oh, it's already full. Sorry guys, you can't come in. Like
exactly. So that's what we set up with this API gateway, and with the click of that button, we have a managed REST endpoint that is in front of a serverless action, and I can start hitting that gateway to send me a text. So let's go ahead and test that. First thing I want to do is I want to tell that bouncer that certain people are able to get into this action.
Okay.
So I'll hit create API key, and we'll give it a name, and let's put Aurea, because I want this API key to be for you, so that you can text me.
It's my private party, or
that's right. That's right.
So only my friends can get in.
Exactly, and you get to choose who gets to text me, right? So it's a really important power. Don't abuse that. Yeah, great power, great responsibility, right? So we've got that API key created. One thing you'll see here off the bat, it says I've got something called an API portal link. Okay, that's neat. Let's check out what that is. So we click that, and what it's going to open up right now, it's a dev portal. And this might look familiar to you. Are you familiar with kind of like Swagger, or more recently like Open API specification?
I'm familiar with Loopback.
Right. Okay. So yeah, Loopback is one kind of user of Open API specification in Swagger. Right. So this is a representation of a API. So this is essentially the documentation that powers, or rather, that shows you that backend API and how to use it. What's really cool about this is really powerful is that not only can you see the API endpoints that we have, so get text me. So essentially the API was text me, and it's a get. So it shortened it to get text me. And what we have here is a curl that we could do to actually run this. So let's just go to try it, and we'll hit call operation, and I should get a text message here in a second. So scrolling down, it says 200, okay, and it says texted hello from serverless. So one thing I have noticed, the first time I run this, it usually hangs, and it says, okay, rate limit exceeded, too many requests. Interesting. I don't remember calling it 4 times. Here we go. Okay. I think the very first time for the rate limit to get in, I've kind of seen this bug happen. But here we go. We'll hit call operation. And, oh, I forgot to turn off silent. But here we go. We're getting those text messages for every single time I've hit call operation. And
so could you essentially do the same thing by just calling that curl command in your terminal?
Yeah, let's try that. So let's see. We'll go to examples, and we'll copy that curl. Open up a terminal. Run that exact same command, and it says, oh, rate limit exceeded. So I really did hit it 4 times this time. So let's wait about a minute.
Okay.
And then we'll hit it one more time, and I should get a new text message. So here we see we got 4 text messages, and we set a limit to say you can only send me 4 text messages every minute. Maybe I should set it a little higher.
We'll wait a little bit. We got time. Nice.
Okay. All right. There you go. So now I ran it again. It says texted hello from serverless. Got my notification, and you saw it kind of pop up here on the right side.
Yep.
So in a matter of minutes, we set up a serverless action, integrated it with Twilio, set up an API gateway, set up a rate limit for that API gateway, and even gave you a personal API key for being able to text me. If I wanted to share this capability with you, I wouldn't have to sit there and have a long conversation with you. You have to do a get to this API endpoint and put in this API key, blah, blah, blah. All I would have to do is send them this link right here, this dev portal link.
So this is publicly available?
Yeah, anyone can actually hit this dev portal link.
Awesome.
So, if I wanted to send this to anyone out there to be able to text me whenever they wanted, I just send them this URL. In the URL embedded is the token to actually be able to be authenticated on these requests.
Okay.
And then, you saw how easy it was. Just copy paste that curl into your terminal, or, take it a step further, take that code and run it in your application as well, right? So I'd say it's a pretty cool way to get started with serverless, but then take it a step further and make sure that when you're in production, you're taking the precautions necessary to make sure that action is protected, rate limited, authentication is in front of it, that kind of thing.
That's awesome that you can all do that right from IBM Cloud, and everything's kind of right there ready for you.
Yeah.
Seems like it's a pretty pretty neat tool to have all those integrated. API Connect, serverless. You can use other third-party services like Twilio. That's pretty neat.
Right, and you can imagine everything I did today was pretty much in a browser. I could have done this on a Chromebook. I could have done this on a mobile phone. It's really powerful because at the end of the day, with the tools that we have available in the public dashboard alone, you can create production-ready, API endpoints. It's pretty neat.
That's great.
Yeah.
Awesome. So thanks so much, Sai. Do you have anything else for the listeners? Do you want them to check out? Do you have your code on GitHub or anything like that?
So actually, this code is so straightforward. I didn't see a reason to put it on GitHub.
Okay,
but let me show you how easy it is to kind of work with Twilio's documentation. Because at the end of the day, what I did was straight up take documentation sample code directly from the Twilio kind of documentation. So
nice.
essentially, they have a step-by-step process to set up a phone number, sending an SMS. Here's that sample code.
Okay.
There's actually multiple formats you can use. This is a PHP version. If you hit that sample code button, it'll show you different programming languages you can use. We use
nice.
Node.js today.
Yep.
One quick plug I want to make, I really like Node.js when I'm working with serverless functions.
Okay.
Mostly because it's a super lightweight runtime, and it's great for, it's great for asynchronous and I/O and that kind of thing when it's in a traditional serverless kind of, or non-serverless or like a traditional application kind of format. But in the serverless context, it's also great because Node.js spins up so quickly. Just kind of going back, let's take a look at the dashboard for that serverless action that we just created, just to show you how performant these serverless actions are. So going to the Twitch text me that we just used, and see. So we'll go to Kibana to actually see the logs. Well, here, let me just do this real quick.
So we're just checking like the performance of how long it took to actually fire and get that response back.
Yeah, exactly. See, there's a different overall monitoring view we can look at as well. And that might be better than checking out the logs.
Okay.
So here we go. So this is the actual monitoring dashboard. And we can see that, the very first time we ran this function, it took 715 milliseconds.
Is that kind of like the warm-up or?
Exactly. So the very first time you might notice that there's a little bit of a longer startup time. Once that cache has been kind of created, there's all sorts of cool efficiencies and like things that we do to make it run faster. And the last 3 invocations you can see are taking only 251 milliseconds.
That's pretty similar to like the Hello World. That's pretty cool. And that's using that API, that external API that takes some time too.
Right, exactly. And this dashboard is great for kind of being able to see the latest invocations. So I just made another one, and you saw it took 259 milliseconds. And you can see everything from when we called those functions to how long they took. And with that Kibana dashboard, which has logged me in now, we can see even more detail as to those invocation logs and that kind of thing. If I really wanted to dive into one of these, we could even see that console log statement that we had from when we actually ran that function. So here we see that message, texted hello from serverless. So, really powerful production level tools offered from the start, totally free. You can get started and start creating production ready functions on IBM Cloud. When you do want to start moving to production, moving to scale, the cost is, it's something so minimal. It's fractions of a penny, and I think we do it by gigabyte hour per invocation. So it's really cheap to get started with serverless for sure. And honestly, I just think it's a fun platform just to like run actions and check out code without having to spin up an application and push it to production every time you want to play with something cool.
Yeah, that's awesome. It's so quick and it's so powerful.
Yeah. So last thing I want to say, if you want to check out some of these capabilities, maybe just create a free trial account on Twilio, a free trial account on IBM Cloud, and you can do pretty much the same sample that we did today just by following along in the documentation, taking some of the sample code that Twilio provides, copy pasting it into your Cloud Functions tool, and you can have a function right off the bat to start sending you text messages, however you may want to use that. It's pretty neat stuff.
Awesome.
Yeah.
Well, thanks so much, Sai. That was awesome. Great to have you on air. And we're going to wrap up now, and we'll have the Model Asset Exchange by Sashruti coming up. So stick around, and thanks for watching.
All right. Thank you.
Hey everyone, we're back from Think 2019, and we're here with the IBM developer Twitch. We're going to be streaming for the rest of the day, and today we have Saishruti, and
Hi.
she's going to talk to us about the Model Asset Exchange. So please give us a little bit of background on yourself, and yeah.
Yeah. Hello everyone. So I'm Saishruti Swaminathan. I'm a developer advocate in IBM Kodai team, which is Center for Open Source Data and AI Technologies. So a bit about myself is I started my career as an instrumentation engineer, and then I transformed to software engineer. I worked for 2 years as a software engineer, and then that's when I encountered data science. So I took a data science specialization for 2 years, and then I ended up being data scientist come developer advocate in IBM.
Awesome.
So yeah, that's pretty much about me, and it's a transition from mission to machine learning.
Oh, I
Yeah.
see. That's awesome.
Yeah. Thank you.
Cool. So yeah, why don't you tell us a little bit about the Model Asset Exchange, and maybe just kind of give us a background on the project and why it's important, and yeah, take it from there.
So the topic for the day is Model Asset Exchange. Basically, I'm going to tell you all how to use AI, just like how you use your telephone, like effortlessly. You don't have to know much about the architecture and get into it. Rather use AI directly to your applications effortlessly. So that's the basic idea of this. So
That's
let's
awesome.
start. So the agenda for the day is it has become a ritual. So whenever you go, you have to start with the definition of data science, and then data science
Yeah.
process pipeline, and what are the challenges in model development.
Mhm.
And from there, I'm going to introduce you all to IBM Model Asset Exchange.
Okay.
And then we are going to see a quick demo, and that's pretty much sums up what you're going to do now.
Perfect.
So yeah, what is like data science? So what's the goal here? Here we are going to solve a business problem. You're going to take a business problem and try to find a solution for that. So how we are going to do basically? We are going to take this business problem and try to convert into a data science question.
Okay.
And we are going to use your mathematics skill, programming skills, all scientific methods, algorithms to find solution for your questions.
Okay.
And finally, we are going to communicate the result to our stakeholders and try to interpret, and then it goes like a loop.
Mhm.
So I'm just decoding the definition of data science,
Yeah.
not rather than take some book definitions and then say. So this is pretty much about like what we do in our data science job.
Yeah.
Okay, I'll ask you a question. For example, we have, say for example, you have your business problem defined,
Yeah.
and you have converted into a data science question,
Mhm.
and you are like an expert in math, algorithm, and everything, and you have your data as well.
Mhm.
Do you think if you take your data and directly give it to your model, you'll get an output?
If the model is deployed.
Yeah, I mean, it will be like garbage in and garbage out. Say, for example,
Mhm.
you are taking real world data as it is
Mhm.
and trying to give it to your model.
Oh, I see. Like without cleaning the data at all.
Yeah.
Or I see.
Yeah, so it will be like, it will be a faulty model basically. You won't get, proper results. And at the end, once you complete everything, you have to again start from zero level.
I see.
So what do you need to do for that? So there is a process. It's called data science process pipeline.
Mhm.
And that is what we are going to see now. So it starts from data extraction,
Mhm.
goes to data cleaning,
Mhm.
then data exploration or visualization, and then model development, and finally interpretation of a result, and it goes like a loop. So
Mhm.
this is like a data process pipeline, and it has to be taken. Usually the first 3 levels are not celebrated. So whenever you
Uh-huh.
say someone as a data scientist,
Uh-huh.
the thing that pops into your mind is, okay, they automatically predict things, they use cool algorithms, but
Yeah.
that's not the reality.
Mhm.
80% of the time data scientists they spend in data cleaning and exploration, just 20% in model development.
So essentially, when you first asked me that question, like, oh, would you just throw the data into the
Yeah.
model? You're taking the data, like the data cleaning, the data extraction part
Yeah.
out,
Yeah.
which is like most of the work, 80% of the work,
Exactly.
right? So
Yeah.
you're saying you absolutely need this. This
Yeah.
is key for a good model.
Exactly. So these are not like much celebrated
Mhm.
part of data science. So it's
Mhm.
model development, deep learning, machine learning.
Yeah.
But for today, we are going to focus on model development for sure.
Okay.
So okay, one more question for you. Hope you.
Yeah,
you
let's
can-
see how I do. I didn't do so hot on the first
Okay.
one, but
Can you spot what are the objects in this image?
I see a kid and a
Mhm.
teddy bear.
how do you know it's a kid and a teddy bear?
From how, so I just see the shape,
Mhm.
I see the head, and I see, I don't know, I mean, from
That's
from
a
the
great
so-
answer.
yeah, so
Yeah.
from my previous experiences when I've seen kids before, that they look like that, and then
Mhm.
the teddy bear is fuzzy. I see that there's, yeah, it just looks fuzzy, kind of like a toy. So I'm like, oh, that looks kind of like a teddy bear.
Exactly. So that's what I'm coming to say now. That's a great answer to start with.
Mhm.
This is like human intelligence.
Yeah.
So from your childhood, your neural network has been trained.
Mhm.
Okay, if something like this appears, it means it's a kid.
Yeah.
So if something like this, it's a teddy. So this is human intelligence.
Mhm.
Now we are going to take this human intelligence and try to give it to machines.
Mhm.
That's called artificial intelligence.
Yeah.
So fortunately or unfortunately, it's you who has to construct the architecture.
Mhm.
For us, it's already there. All the neural network is set up. You don't have to go, okay, this architecture, can I put it in my brain? No, it's not the case.
Uh-huh.
You're all built in.
Yeah.
But here we have to take, we have to select which architecture is better for this one, and then try to take in and construct it.
Mhm.
So this is like artificial intelligence.
So
what are the,
so when you
sorry?
talk about architecture, are you talking about the model or?
Yeah,
Okay.
model. So
Gotcha.
it's a neural network model. So we
Yeah.
have to select the neural network that
Mhm.
can fit well with the missions,
Mhm.
and then we are going to create the artificial intelligence for them. So what are the challenges you will go through? First, you need to know what are the models available for the specific problem.
Mhm.
So it's an object detection problem. So what are the models available? So that's your first challenge.
Mhm.
Second one, okay, I have like 10 to 20 models here. So which one is the best? Which one I should choose? So that's your second challenge. And the third one is, okay, you got a model, you got a code and everything is ready. You need to solve installation issue. You have to clean the code because not all the code will run in one go, right? So
Mhm.
you have to do all the setup issues, clean the code and run it. So this is not impossible to do, but it's super time consuming. It takes like so much of your time, to build this kind of a model, and that's when model asset exchange will come into picture. So this is where it's going to help you.
Mhm.
So just a quick demo. Say for example, if I want to construct an object detection models,
Mhm.
you can see the number of results, right?
A lot.
So
That's a lot of results.
yeah, I mean every single day something new pops up.
Yeah.
Some model pops up. So you need to know which is the state of the art model, right?
Yeah.
So that's our goal. Model asset exchange is one place for all state of the art deep learning models.
Okay.
And the models are categorized into wide varieties of domains. By domain, I mean, we have vision related models, computer
Mhm.
vision, image
Yeah.
related, audio,
Mhm.
video related, and natural language processing, time series. So we have like different varieties of model, and they're
Mhm.
categorized into different domains as well.
So it's not just visual detection. It's not just object detection. It can be audio, video. It can
Yeah.
be all types of.
Yeah, it can be
models.
anything. We have wide varieties of models that can that you can use in different domains and applications.
Perfect.
So and the one interesting part is if you take a model from
Mhm.
model asset exchange, you can be very sure that it's a well tested code and IP.
Mhm.
You don't have to worry about the license terms or whether the code will run or if there is any bug in the code.
So is this all open source?
Yeah, it's all open source.
Okay, perfect. So we can see all the code behind
Yeah.
every single model if
Yeah,
we wanted to.
Exactly, and
That's
you can even read the paper behind the architecture. And all.
Oh, that's perfect.
Yeah, so we have both trainable and trained version of the model.
Mhm.
So this is what I thought. Okay, why do we need this?
Mhm.
Why do we need this kind of model zoo for us?
Yeah.
Because we want to make AI easy to consume. That's our primary goal. But I will show you like why it is easy to consume in few minutes.
Yeah.
But still, this is the goal of creating this open source project. It's called Model Asset Exchange. And now I can show you. This is our site.
Mhm.
If you see.
So right now we're on developer.ibm.com,
Mhm.
and then we just went into exchanges, right?
Yeah.
Perfect.
So you have models for this. These are all like image related models, and if you go to feature, you have like audio model. You have security related models.
And if we click on view the model, is that just going to take us to the GitHub or how?
Yeah, that's a good question.
So all I can see is the PowerPoint.
Good.
Way better.
So we're on the develop. So let's back up just real
Okay.
quick. So right now we're on the developer.ibm.com site, and we went into exchanges, and this is how we got to the model asset exchange.
Yeah. So, say for example, if you want to build an object detection model,
Uh-huh.
you can get into this.
So is this the one that we're going to be using today?
Yeah.
Oh, perfect. Okay. And is this one that you've worked on, or is this someone else that contributed this one?
This is someone else from my team who
Okay.
contributed this one.
Okay. And this one is trained, or it's trainable?
It's right now we have pre-trained version, and trainable is coming soon. Yeah.
Ah, okay.
So this is like overview of the model. You can see like which domain and which application,
Mm-hmm.
which industry you can use, and what's the framework, and with which data we have trained the model.
Oh, perfect.
And we have references for the same.
So when you say trainable, does that mean you can try to alter the model, and then who are you able to then deploy, like put that into the model exchange as a trained model, or how does that work? Trainable
So,
versus trained.
Trainable is when you can use your own data.
I
So for
see.
example, these objects, we have, say for example, this model has been trained on 30 different objects. So
Okay.
what if I want to train an object which can detect my face?
Oh, I
can
see.
detect, okay, this is Sai Shruti, like how can you do it? So for that you need trainable models.
I see.
Yeah.
Okay.
So, okay, let's get back to our presentation now. So I'm going to tell you all the flow, like what do we do, what behind the scenes thing,
Yeah.
how do we create such models. So we basically find all the state-of-art deep learning models in every domain, and then we pick up the best ones. Of course, it's state-of-the-art, and then we validate their license terms so that there is no IP issues, and then we perform, model health check and code check, how well it is running, whether it's giving the same accuracy, or whether what are the things they have promised on their paper, whether it's been replicated, it's proper. And then we wrap the model in a Docker container, and then using the framework which we have developed, which is specific to Model Asset Exchange, and we give a REST API, provide REST API to it. That's when the consumability part, consumption comes into picture. They don't have to do anything. We provide REST API for accessing the model, and then we have 3 to 4 set of reviews going on before releasing the model. And once we release, we make sure we have models in the current version. It should not be an older version. So we do version control for the model. So this is like a behind the scene of how we create each and every single model in Model Asset Exchange.
That's pretty nice. So it seems like there's a lot of work to be
Yeah.
done before it's officially posted into the
Yeah.
Model Asset Exchange.
Exactly. So that's the aim of this, since the open source, we want to let people know
What's
is happening
happening.
behind.
Yeah.
Okay. So whenever I go for the workshops and other, people generally ask me, okay, I'm this kind of, there are 3 varieties of users that I have seen for now. So I'm user 1. Say for example, I have no idea about deep learning. I just want to know how this model works. That's it. That's my aim. So if you want to just try the model, you can just use the REST API.
Okay.
And then try to see how the model is working. And if you want, you can even read the paper if you want further information on that. Okay, there's this user 2 type. Now I have good experience in deep learning. I want to use my own data and then train the system. So that's when you get into trainable models we have, and you can start training your model and tweak the architectures here and there, and see how it goes. And the third set of user is, you are an expert now.
Okay.
Now I have object detection, it can detect between cat and a dog, but I want to use the same for detecting cancer.
The same model.
Same model, but for detecting cancer. This is called transfer learning.
Okay.
I'm going to transfer whatever I have learned here to this application. So we have transfer learning models coming up.
Oh wow.
So they can use that transfer learning and try to use in different applications. So these are the things which people can do when they get into Model Asset Exchange.
So when I think of AI, I think of it as kind of being really good at a really narrow task. For example, differentiating between a dog and a cat. When you're saying that you're going to have something that's transferable to other domains, is that making the AI just more broad? Like it's able to detect more things, or how is that actually working?
Yeah, so say for example, instead of just instead of being narrow, instead of using the same thing, now we are trying to extend the applications that where we can use this model. If we're trying using people, I can use it in a place where we can detect people for surveillance purpose maybe.
Yeah.
If I train with cars, it can go and detect number of cars, and it can be used for parking system.
I see.
So
Okay.
you're
That
trying
makes
to put it
sense.
in like different applications, but the underlying model is same. You're going to tweak here and there and trying to adjust it.
Okay, perfect.
The good point is now my presentation is over.
Okay.
So,
So we're ready for the demo?
yeah.
Oh, nice.
So we are going to do the same object detection here.
Okay.
So if you get into the GitHub thing.
So this is where all the models are?
Yes. Not all specific to object detection.
Oh, this is, okay, I see. It's object detection.
Yeah.
I see.
So each and every, We can't see the browser. Oh, sorry. So each and every, if you click on the model, it will take you to the respective GitHub.
Oh, okay, so each model has a different GitHub associated.
Yeah.
Okay, that makes sense.
Yeah. So here.
Perfect.
Okay. So you have the same like introduction about the model, metadata, references, license terms, and this one. There are 3 types of deploying this model. One is directly running the Docker container. So okay, I'm just this will pull the pre-built models and it will run.
So this is taking the model that's already deployed and we're just running it on our local computer?
Yeah, so it will just pull a pre-built image from Docker Hub and it will run locally. So
perfect.
Okay, so the model is running in localhost port 5000. If you go here, this is the server. And you have to get into the predict part.
So let's make this a little bigger. So this is the REST API you were talking about. Okay, so if someone has no idea about AI, they can just go ahead and take this REST API and they can use like a curl command and then invoke the AI. Okay.
Yeah. Perfect.
Perfect.
So you have to click into this try it out and choose an image. So I have this.
So what is this threshold number?
Yeah, so this based on threshold, say for example, if I'm seeing the teddy, I'm just 50% confident that it is teddy.
Yeah.
Then it will eliminate. So it needs like at least 70% to tell this is a teddy, this is the person.
Okay. So you can shift that based on how accurate you want these results to be.
Exactly. Yeah, I'll show that as well. So I'm just executing it. You can see the result here.
Okay, so we got a
this
teddy bear.
Yeah.
And probability 98.9.
Yeah.
So it's very confident that it's a teddy bear.
Exactly. And it also gives you the bounding box. I can show it in app so that it will make better sense. So we also have app version of this model.
Okay.
See, for example.
So all the app is doing is it just puts a UI in front of that REST API?
Yeah. So this is the architecture. So you have the UI and it will go and hit your API, and that will in turn call your model and give the prediction, and you will get it in your app.
Okay.
So that's like a flow chart. Again.
Oh, okay, so that's the bounding box.
Yeah, so this is the bounding box that you are getting here, 0.27. And this is the threshold. You can increase, and if I decrease, you can even see the bench here.
Oh, okay.
So since I've given threshold as 0.7, it wasn't giving me the bench.
I see,
output there.
because it's not very confident that there's a bench. I see.
So you can play around with this threshold to see, what object that are being detected.
So have you tried a lot of the other different models on the exchange?
Yeah.
What's your personal favorite? What's like do you think? What's a great one to kind of get started with and try out?
For getting started, I would
Mhm.
say object detection, and
Okay.
the next one is image segmenter model.
Okay.
And I would say right now, like age estimator, pose estimation,
Mm.
and all the models are like pretty popular.
Okay.
Yeah. So, if you want to try this, go ahead. We have facial age estimator here.
Yeah, let's try this one.
I think I need my picture. Let me restart my Docker first. Okay, so
So are you just killing the Docker container and then you're gonna just restart a new one?
Yeah.
Okay, and it's gonna pull a different image.
yeah, exactly. So I'm getting into the create up thing. So this time I'm going to show how to build from scratch, like clone
Okay.
the repository and build.
So what's the benefit of building this from scratch?
Like you will actually clone, and if you want to make any tweak in the code, you
Oh,
can
I
actually
see.
go-
So you can kind of
Yeah.
you can change the code a little
Yeah.
bit and kind of tweak the model to be
Yeah.
okay. So this is a little bit more advanced, right?
Yeah. For those who want to play around with the model.
Yeah.
Just clone the repository now. I'm getting into the folder. I'm building the model. So it's downloading all the assets.
Mm-hmm. And then how many for example, this one is this the age estimator or no, age estimator?
Yeah.
How many images is this one trained on? Are you able to find that out?
Yes, so if you go here, you will have information about the training data.
Okay.
So if you get in here,
Oh,
500,
500,000. Okay, wow.
So what are the images, like what information that does it contain? You will see everything in the
Mhm.
respective site. So yeah, it's building the model now.
So if you had any advice for new developers getting started, what would you tell them in terms of building with AI and creating applications? What advice would you give them?
First, I would tell them like go and see how the model works,
Mhm.
and when they get sense of what is happening with the model,
Mhm.
then see the research paper and understand the architecture,
Mhm.
and after that they can poke into the code and then see they can start tweaking code here and there and see how the model changes.
Yeah.
So I would prefer starting getting to know how the model actually works rather
Mhm.
than directly getting into code and then trying to figure out what is happening.
And how would we see how the model works here? Would you just dive into the GitHub or just kind of read the?
Yeah, I mean, I'll actually build this model and then
Mhm.
use the APIs to check how it works.
Oh, okay. So
Yeah.
that's like the first step, you think?
Yeah.
Yeah.
So that's why we have the deployable model. People who have no idea about what is happening, they can
Mhm.
take this and deploy their own, deploy locally and see how it works.
Yeah.
It's taking some time. Okay, so meanwhile.
And then the last step is just to actually run the Docker container. Is
Yeah.
that right?
So you have to build and run.
Mhm.
We also have steps like it will take you to the API.
Mhm.
How to actually run? You have to use the model and predict endpoint to load your test image,
Mhm.
and then get the prediction from API. So you also can use the curl command here.
Mhm.
Just use directly. Yeah. We also have app versions of a few of the models to
Mhm.
let people know how they can consume the model,
Mhm.
rather than.
So that's kind of what you showed earlier, right?
Yeah.
Where you have the app and you just click and then import the file. Is there another app that there is running already?
Yeah, there is image segmenter app as well, I guess. A facial age estimator app is also there. if I'm not wrong. Okay, we have app for this as well. Age estimator. They can deploy in Kubernetes, how to run locally, how to.
Nice. Let's see if it's done now.
Yeah, I think it's
Perfect.
done.
So anybody that's watching at home, they could go ahead and
Mhm.
click on that GitHub and try these
Yeah.
facial estimators as well.
Yeah. So now we are going to build. Okay, sorry. I think we have built the model. Now we are going to run the model.
So now we're setting up the server, or
Yeah.
we're about to run the server. Is that right?
Yeah. So it will run in localhost port 5000. If I'm not wrong. Let's see if it is up.
So now we're predicting the age of whatever picture you import, right?
Yeah. I'm gonna try with my own picture. Hope it predicts properly. Let's see. So
Have you tried this before?
yeah.
Okay. Yeah, let's see what it says. So the
Okay.
prediction is
25.
25.
That's pretty accurate. So.
Pretty accurate.
Yeah.
Nice.
So you have the bounding box here.
Does it give you the estimation, like
No, it doesn't give you the probability.
Okay.
Rather give you, age directly. Oh.
Awesome. So I think we're kind of out of time now.
Mhm.
Do you have any last word, any last links that you think they should check, the viewers should check out at home?
Sure. I can, send the model asset exchange link and
Perfect.
what are the, models that we have used here. I can send all the links so people can try it out, and so it's completely open. So
Perfect.
they can feel free to try it.
Awesome. Well, thanks everybody for joining. Sashruti, thank you for having for joining us on IBM Developer. For everybody else that's watching, we're going to take a quick break, and then we'll have a talk about metadata repositories from Mandy. So please stick around, and thanks for watching.
Thank you.
Hello out there. I am Amara Graham, back with more exciting content here at Think. I am joined by Mandy.
Hi.
Mandy, go ahead, introduce yourself and tell us a little bit about what you'll be talking about today.
Thank you. So my name's Mandy Chessel. I am an IBM Distinguished Engineer, which means that I'm a technical person. I build innovative systems for IBM. And at the moment I'm working on my favorite project I've ever worked on, which is called ODPI Algeria. And it's creating technology that allows us to exchange and manage metadata. And I'll go into a little bit more detail about what metadata is and how the technology works.
Awesome. And it's your favorite project, so
It's
that's
my
super
favorite.
cool.
It's so good.
It's so exciting. All right, so let's get into it.
Okay. All right. So metadata is a word people hear and they never really quite know what it means. So it's really simply data about data. But if you think, when you take a photograph on your phone, the photograph, when you look at it later, they say, well, that photograph was taken yesterday. And you were actually at IBM Think when you took that photograph.
So you get a timestamp, you get a
Yeah,
location.
That's exactly right. And that's metadata. And what's super about sort of digital photographs today is that metadata is embedded. It's always there, and you can use lots of different programs to put smiley faces on people, take out the red eye, or if you're into data science, you could actually take photographs all from the same location at different times of the year over many years and really see how that location's changing. So you can do important data science on it because the metadata's there. Prior to digital photographs, we all had to write on the back. You know, this was Auntie Flo's 50th birthday party, and this was Joe, and whatever. And we were all terrible at it. There were some people who were very good at it, but most of us have got boxes of photographs where we can't quite remember who the people are,
Or what day,
or what
or
it was
what
taken.
year,
That's exactly right. So people aren't very good at keeping metadata, and so we really need computers to do this all for us automatically. And that's really what our project's about. But we've got a few steps to go before we get to the point where it's as good as the digital photographs. So, so if I tell you a little bit about what systems really look like. So I'm going to show you a picture.
Oh, that looks like a mess.
It's a mess. And it's actually a testament to how successful we've been in IT over the last 40 to 50 years, in that companies have gone from buying one computer and putting a few things on it, like payroll or admin, to actually running their entire business and everything about their business. And the result is they've built many, many different systems. And you see this picture here is an example from a real company, and it's just a small percentage of the number of systems they have. Every one of those has data inside it. And it's all been designed assuming that that system was the only system in the world, and then the other ones have all been bolted on over time. So when we take data out of these for data science, so typically, you know, we need to pull all the data from the different systems and sort of find out what's going on in the organization. The data scientist is just left going, well, I can read some of the words. I say, I know what New York is, but I don't know what these funny numbers are. And you know, so they're left guessing really about what this data really means. But there'll be somebody who actually knows what that information is somewhere else in the company. And data scientists spend a huge amount of time trying to find out what the data that they're supposed to work on, well, even finding the data in the first place, but then trying to decipher what these numbers mean, because a lot of data is just numbers really. So we need to make that a lot easier. Back to the digital photograph. Yeah. The other thing is that data's not always, you know, public.
Right.
So this is actually payroll data. And
very sensitive.
Very sensitive, because it's got how much everyone in the company's paid into it. So here we've got
they're very sensitive.
And so Callie, of course, is actually in the payroll file. So she knows how much she's paid, so she can work out how much everybody else is paid. And it's actually in there. There's a bonus as well as the pay. As people's salaries. So, you know, you're not going to give somebody in a company a file with everybody's
everything.
Everybody's and their home address and everything. So we have to do things we call masking when data scientists work on the data. And again, this needs to be an automated process.
Right.
Yeah, so the core of this, and now, unfortunately, unlike digital photographs, data from normal systems, from business systems, is not doesn't have any metadata with it. So it's just the numbers and the text that you get. So there are products, lots of products, called metadata repositories. And this is where we store the information. So when we pull the data out of a system, it's a bit like a poor tortoise who's lost a shell. Because the system before used to protect the data, and you couldn't access the data without using the system itself. But when we pull it out for data science, it's somewhat vulnerable. So what we try and do is capture everything about what the data meant, what it was captured, what it, how it should be used, how sensitive it is.
Right.
And that goes into the metadata repository.
Okay, and that gets you that context too, because sometimes you get a location, you're like, well, what is this? Is it the
That's
location
right.
in time? Is this relative to something else? You don't quite know. Then you don't know how relevant is that information to
Or
solve a
even
data science problem.
Exactly. Is it accurate? Is it whatever? So that's really the role of the metadata repository. And inside it, let's try and show you a little bit about how metadata looks. So there's very simple stuff. So say this came from a database. We have what's called the schema, which shows the fields within it. And that gives you a clue, actually, as to what the data means. You start to say, oh, I know what salary means. And that gives you some of it. We can also put tags on it, label it with business terms, and so people actually start to really begin to understand it. And then we can get really sophisticated and say, this is everything about an employee. So we can start to say these things all belong together. And so, well, actually, this is about an employee, so it's probably a little bit sensitive. And we can even label our labels. And so here, we're labeling
which ones are
sensitive.
sensitive. Okay,
Sensitive,
yeah.
right? So inside the metadata repository, we now know, because somebody's done all this work, where the sensitive data is located in.
So then you can say that's the one that we need to mask.
That's right. Yeah.
Okay.
So if we can get this metadata into the tool that does that actually provides the data to the data scientist, then we can mask the right field
without anyone seeing what's
Exactly.
actually in that field.
Exactly. Yes. And for different situations, you may allow people to see it or not. So the HR director probably can see that information, but not the data scientist. So this is how we do that mapping. And the good thing about metadata is you can do an awful lot with it. The bad thing is everybody agrees. And so most companies buy lots of different tools, and every single one of them has got a metadata repository in them. They're all different. There's no standardization. And so you end up doing all that work with every tool you buy. So it's expensive to buy a new tool, not because the tool is expensive. Even if it's free, there's a lot of work to actually maintain the metadata. And they normally all start empty. So now we get to, what does Egeria do? So a lot of discussion about, how we need, what needs to change. And so what we're actually doing is we're not saying we need one big metadata repository in the sky that everybody uses. We're saying that you're still going to have different tools with different repositories, but we need to make them talk to one another. And we need a common language that they can talk, because not everybody's going to use the same language in their repositories, and there's an awful lot of really good tools out there that already have repositories. So we created, in open source, we've created an open standard that allows these repositories to talk. We've created the software that actually does the exchange, so all the protocols about introducing one another to each, and exchanging the types that each tool supports. And this is Egeria. So this is the technology we're working on. It's got 2 levels. One level of interfaces, we call this the repository services, and this can basically talk about any type of metadata. We can actually have metadata about buildings or computers or data or whatever, and the repository services, this one's at the bottom, will work with any type of metadata. And then we have very special services for different types of tools, and these are called the access services. So when we look at the protocol, so if you're happy looking at JSON, I don't know how well that's going to come out, but so this is what flows between the servers when we run. So you have at the top is the type information about what is this type of metadata that we're talking about.
Okay, so kind of like header information.
Yeah, this says,
okay.
so this is about a database column, this is about a glossary term, we've seen those two things. Then there's some control information, and this prevents us from corrupting the metadata in different repositories. So this says whether a repository is allowed to update that data, or it has to wait for the updates to come through from another system. So each system owns and is allowed to update. Only one system, is allowed to update at any one time. And then you've actually got the metadata itself, which is the property section. So this describes one thing, one column in a database.
Quite a lot.
It's quite a lot. And so the access services are much simpler. And they're specialized for a particular type of tool. So this is for a system that's basically appointing people to a particular job in an organization. And this is actually 3 objects, but much more consolidated. So I think it's these 3 objects. So it's a person, a job, and the link between them is described in that small piece of JSON. And actually you can see there are 3 horrible numbers, and these are the identifiers of that metadata.
Okay.
So so again, this is what Egeria does, is it manages that very complex discussion which will support any type of metadata, and then also these simplified APIs for different types of tools. And going on to a little bit more detail, and you can see, you start to see how clever this technology is. So here we have 3 different tools, and you don't want all tools to share everything with everybody worldwide. So we have this idea of a cohort, which is a group of tools that need to share. They need to work together. So that's the cohort. And what happens is they sort of come in one at a time. So the first one comes in, and they have a topic, a Kafka topic, that they add a registration record. And that just basically says, hello, I'm a metadata repository, and this is where my address is on the network.
Okay.
Then the next one comes in and does exactly the same, and the other one picks it up, and then they actually exchange, and they are agreeing and making sure that they're not going to corrupt each other's metadata because they support the same types. So that basically makes it safe, but it also means that they now have exchanged their URLs, their network address in that process. And so once that's finished, they now can call one another. And if you notice, there's pink metadata appearing in the screens of server 2, and there's blue metadata appearing in the screens of server 1. So they've had that little exchange, and from there, Egeria is now allowing them to act as if each server has all of the metadata from both servers. So it's what we call it's like a virtual metadata repository now that they both talk to.
I'm already seeing how this would be really nice for the data scientists who are doing, data cleaning and missing certain things, where they would have previously had to go out and do that investigation on their own, tried to match things, run into issues where there's sensitive data or there's just issues with how the data is constructed. How do you get everything working?
Exactly. So remember, imagine there's 2 teams of data scientists, one using server 1 tools in server 1 and the other using server 2, and one of them has a question and they attach it to one of the items, and another data scientist goes, oh, I know the answer, and they attach an answer, and that goes back. And so it's as if they're all using the same tools, even though they're using very different tools. And that could be the data scientists using server 1 and the HR team or the experts in the data using server 2, and they're able to collaborate through that process, despite the fact they're using very different tools.
Right.
Now, there are nuances to this. So if, for example, we have some metadata in server 2 that everybody needs, it doesn't change very often, we can actually replicate it through. So server 1's got it, and it'll be a lot faster to access that metadata. Or if server 2 is only available in the week, server 1 needs to have a copy of its own. And this is, again, automatic. It's controlled by rules inside the server, so they can choose what they share and choose what they store as well, depending on their users.
And I'm assuming too that the data that's coming from the other server would have a label or some sort of identification that says that, yes, we think this is fairly static data. It doesn't get updated very often, but in the event that we need to update it, we need to retrieve it from this other system.
Yes, yes. And in fact, if server 1 tried to update some blue metadata, it would work. But what would happen is that update would go to server 2. Server 2 would update it, and then the new copy would come back. So the user of server 1 wouldn't know that server 2 had that it had to go to server 2 to update it. But it means that we keep the integrity of the metadata at all times, because there's only one server that's allowed to update it.
Okay. Because I was imagining a conflict of some kind,
exactly,
and I was like,
yeah.
oh, I'm thinking kind of like race conditions, things like that. But no, that's
it's simple in that respect, but it actually works in practice as well, because each tool typically has a community of users that are creating the stuff they need, and they're building on the work of other teams. So the fact that their local server is the one where they can update the things that they've created, it actually works from a sort of people sense as well as from a technology sense. So, more detail.
Yeah, let's
have
go.
a look. Let's have a look. So each tool supports different types of metadata. And sometimes you actually want to create relationships between things, because that's where it becomes the most interesting, is when you start to link things together that different tools don't realize. So it helps people collaborate. So here we want to connect a database column, information about a database column, with a glossary term, which is the meaning of the thing. And they're in different servers, so how do we do that? There's one approach, which is that we replicate using the replication.
Okay.
So then we can create a relationship between it, and we call that copy, that read-only copy, a reference copy. And so that sort of works as long as server 1 supports glossary terms. But if it doesn't support glossary terms, we can't do that trick. But what we can do is bring a third server into the metadata, into that cohort. We talked about the cohort. So you can have sort of general servers that are able to sort of do all the things that the tools that you're using can't do. So they fill in all the gaps.
And have a
and
reference to each.
That's exactly right.
Yeah.
And then we can store the relationship
Okay.
there. And the end users don't know that it's not all local to their system. As long as their tool can actually display it, they can see these new relationships. And we have a slightly an additional thing there. So to make the job easier for server 3, you actually don't have to store the whole thing. You can just store a stub, and we call that an entity proxy. And it's basically the identifier of each end and what type of thing it is. And that allows us to form relationships again across the environment. So this is very important, because sort of you have tools that are really good for very specific jobs.
Right.
But we can also then create connections across, between these tools from different teams.
And as you keep mentioning, the end user, so the data scientist, just needs the data.
Yeah.
They just need some reference. They don't need access to it directly.
Yeah.
So
they just need to be able to see it.
Right.
Yes.
They just need to be able to see it. So this works out really well. That you don't
Mhm.
have to move anything. You just store it as a reference. You're able to see it and
That's right.
get your work done.
Yeah. So here's a practical example we've been working on. It's using some different tools from deliberately from different organizations, because we want to make sure that this isn't just an IBM thing. We're trying to get, it's supposed to be an open ecosystem. We want as many different vendors to work in this ecosystem so that their tools become productive the moment a company buys them. So here we've got one of IBM's tools, the Information Governance Catalog. And this is where they're defining all their rules, their policies around how data should be managed. We've got Apache Atlas, which is an open source project that provides a metadata repository in the Hadoop environment. So this is where a lot of the data from the data scientist perspective will be located. And then we have an Ageria server that's filling in all the gaps. So when I talked about the gaps. And it's also supporting these high level interfaces, these access services that I talked about. With our, this was actually, we called it our MVP, but it's actually quite a complex scenario, as you can see. But we proved that with, we can make changes to the policies in IGC, in Information Governance Catalog, and then it will flow, those changes will flow through to the Ageria server. They're available in the Apache Atlas server for the users of that. And the Ageria server can then configure Apache Ranger, which is a security service. and Guyan, which is a virtualization service. So this allows the data scientist, so that's Callie at the top there, to query data, and she queries Guyan, and then Guyan will fetch the data from the right place. But what we've configured with Egeria is that all of the column names are actually changed to be glossary terms, so they're nice and familiar terms rather than obscure names. And then when the query occurs, Apache Ranger can then find all the sensitive data from that metadata. If you remember that first picture.
Yes, and mask it.
And mask it as we need. And so every time we change the tags on the metadata, the Ranger will change what gets masked in the data.
Okay.
And again, this is 3 very different types of technology all working together through Egeria.
Yeah, so it's much more complex than it looks, and I would say a traditional MVP, but it's
No,
it's a very
but
hard
we needed
problem.
yes, and we needed it to make sure that we built these frameworks so they were usable by lots of different types of technology. So it actually was necessary to do a good job in terms of of how we built Egeria. So I've got lots more details, so we seem to be
we keep going lower. Yeah, we have time.
Okay, so if you were somebody who actually owned a product, and you think, well, actually, I'd be quite interested in connecting into this. What's required to create these little lines underneath to connect it to Egeria? Now, everything in Egeria is built on a connector framework, so basically it makes it very easy to plug in different technologies into this environment. So when we think of how Information Governance Catalog plugs in, we have 2 connectors. One of them is a wrapper around the Information Governance Catalog's API.
Okay.
And the other is watching for events. So every time one of the tools that work with Information Governance Catalog adds metadata in, it produces an event, we capture it, turn it into an open metadata event, and send it out over the cohort. So we always have these 2 connectors, but you can put them in a separate server, and we call this the repository proxy because it's a proxy to the repository. And that's what we do with the Information Governance Catalog, or for Apache Atlas, because it was an open source server, we just put it into the server itself. And so it's exactly the same process. We build the same connectors, but it runs all as one single server.
Okay.
And there are different patterns in terms of how you can use more or less of the Egeria libraries in your technology to bring it into the open metadata framework. So it's quite, it's a very flexible environment. It's designed to minimize the work that a vendor needs to do to bring their tool into the ecosystem, which of course is important because the more tools that are part of this, the better. Better, yeah. So moving on. There were lots of tools. We've got tools that produce reports, tools that store data, tools that provide access to data or move data around. You've got our analytics tools, and you've got the governance platform, which is where all the policies are set. And they each need a different API because they focus on different types of things. And so, again, you can start to see how big Egeria is, because these white boxes here are all the different specialized APIs that we've built for Egeria, for the different types of tools or end user. So this is, again, to make it as simple as possible to allow people to connect into the ecosystem. And that box in the middle, that's all the different types of metadata that we support in the open types out of the box. So governance and data and glossaries, all the things that we've talked about, and the collaboration, of course, allows people to put comments and likes and things on the metadata as they're using it. So it's a very big ecosystem. It's a very exciting project, and actually could make everybody working with data's life an awful lot easier as we go forward. So you can see why I'm so excited about it.
I can see why this is your favorite project, because I'm seeing all the people that it's helping.
Yes,
and
exactly.
I'm going back to my days in IT where we had some challenges because we were building tools that we were not allowed to see real live data. And so we were making fake stub data that didn't always look like what we were going to get in the real productionalized data. And that was a challenge just as me as the software developer box, where I'm like, it would have been great if I would have had access to everything with only the sensitive things masked.
That's right.
Just so that we could have built the right tool.
And you could have clever masking, which didn't just blat everything out, but gave you representative values.
Yes.
That weren't the real ones.
That would have been fantastic, because
Yeah.
I know being on call where someone says, "Oh, so and so typed a special character in that we weren't anticipating, and it broke everything farther down the line," and I'm like, "Well, I didn't know what characters we were using and what we were accepting because I couldn't see real data."
Yeah. So, as I say, a big project, important for developers, DevOps,
Right.
And through to the data scientists and the people who have to manage their whole ecosystem. And so, to make this work, as I say, it can't be an IBM project. It has to be open source. And we've been very fortunate to firstly have worked with IBM, ING Bank, Hortonworks, who gave us a lot of advice on open source development, and SAS as well. So we've got different perspectives from the consumer to different tool vendors and open source experts. And we're part of the ODPI, which is a non-profit organisation that's part of the Linux Foundation. So we've got deep experts in managing communities helping us with this project. And we've divided the work into two major groups. Project Ageria is the code, and there's two parts to it. There's the Ageria code, and then there's a compliance or conformance suite, I should really call this, that allows people to test technology and whether it's compliant with the open source, with the open standards. And anyone can run it, and anyone can improve that compliance suite, because it's all, again, that's part of the open source project. And then we're also building best practices around how you do governance, how you manage data, how you identify sensitive data and work with it. And that's being built by practitioners who are helping us build out these best practices. So, as with all open source projects, we never have enough people.
Of course, this is where we say, pull requests, come on!
Yes, please, yes, please. So this software is on GitHub. You can see the GitHub address at the bottom of the page. And we are definitely looking for help of any sort. You don't need to be a programmer. However, developers are very, very welcome. As a company, you could join the ODPI and just help fund the work. If you're a practitioner, if you've got advice, or actually, if you're new to data governance and you really need help, your questions are incredibly valuable to us, because we have people with a wide range of knowledge about governance, and often those questions remind us that we need to document how you do certain things. So everyone is welcome, and the bigger we build this community, the more impact that we can have on the industry.
Absolutely.
So
I've been looking at the chat. We don't have any questions. So we can go ahead and wrap up.
Okay.
Mandy,
so thank you.
Thanks so much for coming on and talking about your favorite project. This has actually got me really excited about it too.
Thank you.
Is there anything else that you wanted to share other than this help wanted?
The help wanted. Just say please come.
Come on. Awesome.
Yes.
Well, we will be right back with our next guest. Thanks.
Thank you.
And we're back. My name's Amara Graham, and I am here with Sergio. What are you going to talk about today? Can't even speak English. What are you going to talk to you about today, and would you like to introduce yourself?
Okay, thank you. Are you talking about integration with Watson, STT, or TTS, or speak-to-text, text-to-speech, to use voice on Facebook Messenger chatbot?
Super cool.
Using Node-RED as a orchestrator and controller.
Awesome.
And I'm Sergio Gama. I'm a developer advocate from Brazil, so I can realize it with my accent, terrible accent. Okay.
Yeah, we can go ahead and dive right in.
Okay. In fact, I have no PowerPoint, so only my presentation to introduce myself in this PowerPoint. The next one, and I have some services and prerequisites that I will use in this lab, in this live stream, in this live demo. So I will use the Watson Assistant, Watson Speak-to-Text, Watson Text-to-Speech, Node-RED as orchestrator or controller, one page on Facebook, and a Chatfuel as a webhook. Okay.
So there's a lot of pieces.
Yeah. So a lot of pieces. I have a big challenge to do all of these things in 30 minutes. But I have some tricks to try to get there. Okay. So let's. Yeah. I like this baby. Okay. Live demo and pray for this demos. Live demo. Okay.
I continue to be impressed with the Brazilian advocates because you guys do live demos. You're like, let's go.
Let's go. Yeah, because as I will show, it's more easy to understand when I take a look inside this workflow and the demo I will do now.
Okay.
Okay, let's go. All right, because 30 minutes is so here is IBM Cloud. Okay, we need to have registration here and go to catalog and start a service such as Watson Assistant. Okay, and text-to-speech is speak-to-text here. Okay, and also Start Kit. It's this one, Node-RED. Okay, so I already have these services created. So just to show that's the point. That's the way I can start this service. Okay, so I have another services already created here. By the way, it's here. So this is Watson Assistant. I think I have to zoom something here. Much better. Okay, I create a new assistant. Okay, this assistant I will show. The name is demo. Okay, it's a demo. So this is pretty new in Watson Assistant. So now I have assistant, and under assistant I have some skills, or one skill so far. So create dialog skill. Create a skill from the scratch with a blanket, or I can import. So another tip is to use, let's see, here it's bot asset exchange. Okay, so this IBM developer.ibm.com. I'm using this one. Okay, let's hurry. Restaurant concierge. Okay, so get this bot. This is a JSON file. So let's copy this one.
Looks very scary when you can see it all in there, but the import will make it look easier.
Exactly. Yeah. Okay, I'm using Sublime just to save the file. Okay, save. Download, yeah, demo, think, JSON, save. All right. So in this first step, I'm using asset of a bot already done, and download this JSON, and now I will upload to my skill here. So import OpenJSON, okay, here, everything, import. All right, so I have this complete chatbot with intention, entities, dialogue, everything. So, okay, the idea is not to talking about this. How we can create intention, entities, everything.
We just want to
so
use
it's
it.
okay. Yeah, it's pretty easy. So now I have to start a Node-RED. Okay, Node-RED starter kit here. It's based on Node.js platform, but I already have one as well. So, but it starts from the screen. Okay, let me try to. I think
Refresh.
it's small. Yeah, maybe.
All problems that you wouldn't have at home.
yeah. But I think it is very small for the people. I don't know. The people, it's okay to see this my screen, or it's too small. I don't know. Okay. So I have one chatbot to Watson Assistant completely. Now I have already have this Node-RED. So I start to build just to show how we can do this. So I'm using HTTP just to create an endpoint here. This endpoint, the name is chat. Okay. I'm creating an API, REST API here. I think I will take no more than 2 minutes to create a REST API.
Oh, that's fast.
Yeah, very fast. Here, change, and here I will use request query message.
And you know what to put because you've done this before, right?
Yeah, a lot of things. I've done a lot of times, maybe 100 times. Hack query message, okay? It's a parameter or value that's coming from Facebook, okay? This endpoint will be used in my Facebook to call the services. So now I put here Watson Assistant V2 is the new one.
Okay.
Okay. Here. Okay. So the Facebook call this API, send a message. This message, I get this message, send to our chatbot. Okay. So I need to get this view API details because I need this one.
So
Here.
it knows what assistant ID.
Assistant ID is different. Okay. Okay. API key. API key.
Need that too.
Okay, for everyone, see my API key, but
deleted later.
Yeah, very soon. Here, API key. All right. Multiple. No, it's not necessary. Okay. Here now I need to a function. Function JavaScript. Okay, just to get the what I need here. Let me copy here because I
That's
don't
a
remember.
lot, yeah.
Yeah. Here. Yeah. Okay.
And again, for anyone watching this stream, this can be a little bit complicated. So with Sergio walking through this, you can kind of pause the video, check back, and do the
Yeah.
steps along with him.
Yeah. Sorry. Okay.
Needs
here.
a P, huh? Yep, there.
Payload. Okay. These are JSON. Text. Okay. Payload. It's okay.
Looks good.
It's
Or do you
okay.
need
I think
something
so. I think so. Let's. No, something wrong. Okay, I know. Here. Okay, now it's okay. And return message. Okay, at this point, I'm creating an endpoint to be called by Facebook. Facebook send a message. This message is a text message. I send it to Watson Assistant. Watson Assistant process, natural language process, and give me back a response for this question, okay, or this sentence. And I'm get this information from this JSON that's come from Watson Assistant. And now my endpoint is done.
Just make sure it gets back to Facebook, right?
It's okay. It's let's try this one, this part. Okay. Yeah. Let's open a new tab. Click here. Let me. Okay. Map. Chat. Message. Hi.
Okay.
Great. It's okay. 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 I know. No, it's okay. It's okay.
You were expecting
It's
to
working.
get something
Yeah.
back?
Yeah. Yeah. It's okay. So here I have the functionality to send, to give or to receive a message from Facebook, to send it to Watson Assistant, and to have the response to back to Facebook. Okay. So now I will create a page on Facebook. Page. Let me put her. Create a page here. Okay. So restaurant. Gama. Restaurant. Okay. Zip code. Some zip code. I don't know. Anyone? I don't know. It's a address in São Paulo. Here. Okay, just any.
Some
I don't know
information
what's
for right
the
now, yeah.
I don't know. 5,000. I know there is no this number at this street.
Okay,
so
good.
skip. Okay, one page.
Okay.
Okay, I have one page, no connection with Watson so far. So add a button here. This button contact you.
Okay.
Okay, send a message. All right, next for message. Finish.
And
so
so
the
this
part
is-
of the page is okay now.
Yes, and this is a little bit different than when I built a chatbot for Facebook. So the Facebook integration does change from time to time, right? And the
Yeah.
steps are different.
Yeah.
So this is the way to do it today. Very different than when I did it maybe a year
My
ago.
problem is not different because I'm using another techniques to do this. The first is a page. There is no contact or connection integration with any chatbot. In fact, we have to go to developer.facebook.com, create application. Right?
Yes.
And create webhook. But I will don't do this.
Okay.
Okay. So I have a Facebook page. Facebook. I have a very simple API. Okay. And now I use Chatfuel. It's a services. It's a open, free services just to connect to Facebook because there is a Facebook connection already done here. So let me create a blank, okay? Blank project. Oh my God. Cadê? Here? Yeah. Okay, here. Let me remove this one. Blank blot.
Oh, wants to make sure you really want to delete it.
Yeah, delete. Here, connect. So connect to Facebook. Okay. My pages on Facebook. I will connect, in this case, Restaurant Gama. So now I don't need the webhook in this case.
Okay.
Okay, just for this. Now I go here. Okay, here. All right.
It's thinking.
I'm thinking. Normally it's very fast. I don't know what's happening here. Let me
really hard.
refresh and pray. It's two.
Oh no, it's doing so well.
My God. Okay. All right. Okay then. No. Yeah.
Thinking. Oh no. So is
interesting. It's not IBM.
Yeah, no.
No. It's this part is not IBM.
I was going to ask: is Chatfuel a free service? Can you go and create an account and play with it? For free?
Yeah, for free. Yeah, it's just and you don't need to create a specific user, so you can log in with Facebook inside the Chatfuel. It's a very good approach because we have connection automatically to Facebook page. So, okay, let's refresh and let me see. Interesting. Let me. Everything's okay here. Okay, this response. Okay, that is everything okay. But let's see here. Blank bunch. This one. Okay. Let me show another page I already done before I come because this
Just
is a
in
plan
case.
B.
Yes,
Yeah,
plan B.
Plan B. Okay. So I create the page, put some images.
Okay.
The name of Think Restaurant. Okay. It's the same.
Send message button.
Nothing
Yes.
here. Here. Yeah. Let's go back here. I have other projects inside Chatfuel. Okay, Chatfuel. Here, Think Restaurant. Here, the influencer. I include. How can I do this? I put here plus any kind of objects, so can integrate with YouTube, a lot of things, but I don't care. I don't
want
need
Facebook
this.
right now.
I just want this guy just to bring me to the Facebook. Only this, just to as a channel. Okay, so I put a user input. User input is where I get information from Facebook. Create a variable name message. Okay. After that, I create a typing, just to pretend this typing. Okay, so I have a typing, and the last one is a JSON API here, plus JSON API. JSON API, I can configure a endpoint, so that's the endpoint I put here.
Okay.
Okay, but as my new project is not working, let me see again.
Maybe?
No.
No.
Okay. But in this case, when it's okay, you put these three objects. The messaging, typing is not necessary, just to pretend that there is someone
It's a good
typing.
user experience.
Yeah. And the second one, the last one, is a JSON API. Only this. This guy is not working, so back to here, here, these three here. Okay, so JSON. I have already another one. It's okay here. So here I have the same situation. Endpoint, send message. This message come to here, and here I split in two directions because could be a voice or messaging.
Ah, okay.
Okay, when I have a voice, come to here, MP3 to Wave, because from Facebook we have MP3 format.
Okay.
And WhatsApp doesn't understand
No.
MP3. So I using FFmpeg node here to convert, just this, to convert to Wave, send it to speech to text. Speak to text bring me or give me a text. I send it to Watson. Watson process NLP, bring back response. I get this response here, and if the response, if I start here with audio, I send again to text to speech to voice to convert Wave to MP3 because Facebook understand MP3,
Right.
and send back to the end of the endpoint.
Get it back to Facebook, right?
Okay, that's the process. I will try to. This is a part, only the part. Okay, so this is complete.
So you can
Okay.
do just text, or you can do speech,
Or
and then if it comes back in the same format. So
exactly, I show you. Okay, so here I will remove this. I don't need this. Okay, and here I have this page is already working. Oh, sorry. Text button. So, hi. Hi.
Okay.
Okay. Thanks God. It's working. Something wrong here. Why? Okay. I know. Okay. Let's go back here. I will remove assistants. I will remove demo. Delete.
Oh, since we're not using that one anyway.
Yeah. I have
It
another
wants
one.
you to type.
Okay.
I don't know where it wants you to. Up
Yeah,
there.
okay.
Too big.
Reading. Delete. Yeah. Let's try again. Deploy. Let me see. Code 404 is not good. Okay. Once again. I want a table. Well,
Oh,
only
just
repeating. Let's see. Node ready. Think the same. Why? Let me see.
Do you
Restaurant.
have the right credentials for
Yeah,
this one?
maybe. Maybe.
You have to delete this one too
Assistant,
now.
yeah. That's it, just to confirm here. Okay. 1 second. And the assistant IG. I think is the same.
Oh, you missed the J.
Yeah. Okay. Oh my gosh. Yeah.
Oh no, that's
I don't know.
assistant ID.
Oh no. Okay. This is APK.
There.
Here. Yeah?
Yeah.
Yeah. Deploy. 404. My God. Something wrong. Let me try again. But hi. Let's see. Run. Let me. Where is my? Because I can use it here in my cell phone. So the same. Yeah, I
Still
have
echoing.
some problem here. So one good feature is that
Add a debug.
debug. Let's see what's happening. Here. Okay. Let's see. Message not found session ID. Not found session ID. Okay, let me sessions. Maybe. Just try. Okay.
Oh, happier.
Yeah. Okay.
Oh, there.
Okay.
So what did you do?
Guys, I'm using the same chatbot on Message Facebook, but using it in my cell phone. So let me show here. Okay, hi there. I want a table. No, but it's working.
See.
Yeah. Okay, reservation for how many people? Yeah, 4 people. Okay, reservation what day? Friday. Okay, but what's the idea here is using the same message here, and we can see here. All right. Hi. If I send audio, the audio come back.
Hi there. How can I help?
Okay. So, book a table. Let's see my accent.
Reservation for how many people?
It understood you.
Okay, yeah. So here's some message from here. Book a table. Let me.
Oh, that was just the
try
debug.
again. Yeah. So what's the idea? So it's okay so far. I'm connecting speech to text here. I don't know if there is some, if there are some questions or something like that.
I don't see any questions, but is this bottom? Is this Portuguese?
Yeah, no, it said yeah. Opa, boa tarde. Yes. I don't know who is this guy. Okay, boa tarde is a good afternoon.
Oh, okay.
From Brazil. Okay, guys. Please send a message in English because I have people around the world. Maybe, I hope so. Okay, what's the idea? Using Node-RED as a controller or orchestrator to receive this message from Facebook. Here, what's the trick? Here, when I receive this message, Facebook send for us message text or HTTP URL when we send image, when we have audio. Here I have, no, this is over here. I test if this URL is coming from Facebook, it's audio, okay? So I can send this audio to speech to text, and after convert, send it to Watson Assistant, and treat this response and process the response. I send again to text to speech to convert wave to MP3, and I save the information in the session inside Node-RED, because for Facebook I need to send a URL, so a link of the audio. So I put the audio here. That's why I have another endpoint here.
Ah, okay.
So I send this endpoint to Facebook. Hey, Facebook, this is my audio to response. And Facebook send to here. So Facebook get this audio, store in his servers, and so this is working. Guys, I have this code shared for everyone. Okay, it's Node-RED.org. If you flow, you can find Sergio Gama, and here the first is my code. My code is here. Let me back to here. That's the code, okay? So here we have the link to my code that is in GitHub. So this flow is in GitHub, okay? So feel free to copy this code and start your solution with this code. Sorry, I try to hurry because there is no time. I simulated this in the hotel. There is no, it's impossible
Of
to create
course.
everything because I have a lot of steps to
Right.
do.
And there's a lot of technology working together to make it happen.
But it's working.
It
and,
is. And it's
very
very cool.
fast.
I definitely learned something.
Yeah, oh, right.
Is
Thank you.
there, show people how to get in contact with you. How can they
Oh yeah.
reach you?
Okay, I have a lot of.
You're all over the
social,
internet.
Yeah, anything, any place. Okay, so YouTube, I have some videos including explain how to connect Facebook, Node-RED, STT, how to use also Watson Assistant with functions, integration, knowledge, WKS, a lot of things about Watson and the other things. other stuffs.
Awesome.
Yeah.
Well, thank you for coming on. Guess we can go ahead and wrap up.
Okay, thank you. Thanks so much.
Awesome. Thank you. And we'll be right back.
Yeah. Bye-bye.
Hi, we are back again. I'm Amara Graham, and I am joined by Victor again, 2 days in a row.
Yeah.
Go ahead, I guess, and introduce yourself again, because there might be people watching this time that weren't watching yesterday.
Okay. Okay. So, hello guys. My name is Victor Chinia. I'm developer advocate at IBM Brazil, and today I'm going to talk about how to create serverless application using Docker, Kubernetes with Apache OpenWhisk and OpenFaaS.
All the hot topics.
Oh yeah, hot topics. So if we take a look back and start analyzing at how we design new applications, we can see a significant change in our mindset and the way that we need to focus on when we are developing, delivering new solutions. So if we start with the most common, with the traditional architecture using bare metals and virtual machine, you can see that we need to focus both with the code and the environment, with the configuration of the processor, the memory, and the OS, and so on. So you're not 100% focused on the code, which is the value that you're delivering to your client, to your customer. And that's we're not going to say that is a problem. We need to focus on both.
Right.
But if we in the next, we can see the containers, the microservice architecture, which is recent for many companies. I can say that in Brazil we are implementing a lot of new solutions, new applications, new products using microservice architecture. So here it is a little different. So we break the entire application into several separate components, and here we need to set and to configure the whole applications in each container. So that's a little different. We are not 100% in code, but we are not like 50% in configuring the environments, and so on.
Right.
So, and the last one is the serverless, the functions that is right here. Here, we stop worrying about the environment itself, because we have pre-configured environments. So, I don't need to provision a new server. I don't need to configure with the tools that need to run that solution. Here, I just need to I have that function that can be written in any code, in any programming language, Node.js, Python, Go, and I just deploy the code and setting and configure it to become like can be a trigger, can be a API, can be anything. Okay, and yeah, so with this serverless architecture, the billing models become different. So right now you'll be charged by the number of calls, API calls, or actions, and so on. So here I can tell you guys that you'll be charged in a different way. You'll be like you get a great economy if you compare with the previous model, which you'll be charged by runtime. So I need to have like a gigabyte per hour, and right now with the serverless, we are how many times have your API called during that month? So it's totally different right now. And what about tools? So first, I think it's good to say to you guys that if you new on serverless, I think the best way to start learning about it, access the serverless.com is the best place to learn what is serverless architecture, and how to start implementing. From there, you can access the IBM developer and access some code patterns that you can learn some use case. You don't need to. I think we need to avoid some scenarios that I'm creating a new solution. We are using serverless, but why you're using serverless in that case? So we need to stop. We need to avoid that. It is the same thing that when we talk about microservices with Kubernetes, Docker, and so on. So we need to avoid it. Okay, and well, we have several tools. Okay, so as you can see here, you see the Apache OpenWhisk. We have IBM Cloud Functions. So if you guys don't know, we use Apache OpenWhisk running on top of IBM Cloud. So Apache OpenWhisk, and IBM Cloud Functions, it's kind of the same, but it's not. And we have the OpenFast, which is an open source project created by Alex Ellis. So I'll talk more later, okay? I'll show you guys how to create create a first serverless application. But one thing that you need to know is that, as an example, Apache OpenWhisk and IBM Cloud Functions work with major of programming languages, such as if you're a Node.js developer, Go, Python, PHP, Swift, Java, you can create serverless using those languages, okay? But there are some cases that it does not support, like if you're using C or C++, Apache OpenWhisk and IBM Cloud Function does not support with the runtime itself, but you can use a Docker, okay, to build your solution, your serverless application. And I'll show you guys how to create your first C application using Docker, IBM Cloud Function. And there are some scenarios that, okay, actually, I don't need to create like a function based on program language. I need to create a tool, a function using tools such as ImageMagick. So I just need to, resize the image because it's too big, too huge to store in cloud object storage, for example. And how can I do it? Okay, I don't see that Apache OpenWhisk support it. Okay, but you can use it using OpenFast. So I'm gonna show you guys how to create a function using Docker. In that case, using Docker Swarm instead of Kubernetes. It's kind of the same. You just need to configure, like change the gateway and so on. But it's simple, okay? But I'm going to show you guys how to create the ImageMagick function using ImageMagick, okay?
Okay.
Okay. Let's code. I don't want to talk more about it. Let's just code. It's the best way to learn how to use it, okay? As you can see, guys, you can access the QR code or access ibm.biz/Docker and Kubernetes to access the repository. And here you have two folders, the CLang and ImageMagick. I already downloaded in my machine, so you can see, you guys, that I already have both folders. I'm gonna access let me go back here to show you guys that we actually have simple, like the first application you're gonna create, Hello World, the classic one,
yes.
in C. And you need to see that to create a serverless C application, you need to use a Docker file. So you can see here we use a simple Docker file. So it will get the action.c, the C file. It will compile and generate a file called exec, okay? And then we're gonna upload to IBM Cloud Functions. There are a few steps to do this, so let's just show you guys. If you don't know how to do this, if you check out later, you can see the steps here on the GitHub repository, so don't worry about it. I'm gonna show you quite fast. We have like 20 minutes to do this, okay? So, okay, let's go. Let me show you guys. I'm gonna open the terminal here, okay? As you can see, we have the code here. So, first we need to, I don't know if you guys have already created an account on Docker Hub, so you need to push your Docker file, your Docker image to Docker Hub. So I'm gonna push a new called think CLang, okay? Oh, that does not, okay. So let me build it first, okay?
You have to build before you push.
Think CLang, okay? It's quite fast. And then let me see if I can find here. Oh, I have a lot. Let me see if I can find, yeah, image the same thing. But you can see here, we have think clang. Okay, so we can now push to the Docker file. Oh, I need to log in. Yeah. Okay, no problem. So make sure you have already logged into Docker Hub.
Do you have
Then
to do the push again? Yeah.
Yeah, need to push again.
That looks more successful.
Yeah. Okay, it would take a while. Yeah, it's not so fast, but I'll open here the Docker Hub for you guys to see that I already deploy a new clang. It's the same thing. Okay, I just changed the name. So, okay, let me see if it. Okay, we have the think clang here, and then you just need to deploy. Oh, sorry, IBM Cloud Function. We are using the IBM Cloud CLI. So if you don't know, that's how we're gonna deploy. So we're gonna use IBM Cloud CLI, FN for function. So we are deploying an action, and then we're gonna function action create, and then the name of the function, the name of the action, I'm gonna call C, and then Docker, we need to create this flag. Okay, we need to create a reference from our Docker Hub or image on Docker Hub to the IBM Cloud, and then think clang. Okay.
Action
Okay.
created.
Yeah. Let's just check here. Just need to action list.
Make sure it's there.
Yeah.
Oh,
And we can
there.
see that the think C is already deployed. Okay, in a private black box. Yeah, because we didn't inform you which language we are using, so they consider that it's a black box. Okay, and then we just need to test here a little bit. Action invoke the name think C. Okay, and let's see your thinking. Okay.
Oh, there.
Yeah. Hello world. We can change it. There's no problem if you try to change the code. Okay. Let me see if let's change to Thinky 2019. Okay. And then we can just. So in order to update, you don't need to do the same process. You just need to. Okay. Then to build again. Okay. The same. We just need to build the image and then deploy again to the Docker Hub. And after that, we don't need to worry about the code itself.
You don't have to create a new action.
Yes, exactly. So let's just push again.
It should be pretty fast, right? Because
Yes.
all of these things exist. Well, most of them.
Yeah. Okay. Let's just try again to invoke the same thing. Hello world. Okay, in that case, we just need to update. So there's another function here. Update. Think C. Docker. And the name. It's what is the think clang. Then call again. Easy. Yeah.
Yep.
We just need to update the image on Docker Hub and then update the action itself. Okay. So hey Victor. Okay, I got that. I know how to create a new function. I know how to deploy to the Docker Hub. What about the image match? How can use image match as a function, as an action? So let me just clear it here. Go back and access the folder, the ImageMagick folder. Okay, so you can see that we have the Docker file, a README. So if you don't know, guys, how to do this, you can go back here and then check on GitHub the ImageMagick. There's a how-to, the prerequisites, and how to do the same process. Okay, so let's go here. Let me just see again. Okay, so in that case, I don't need to exactly build using Docker because it's I'm gonna use the FAS CLI. So under the FAS CLI, they usually call Docker build, Docker push. So I don't need to do this. So what we need to do is, okay. Oh, actually, let's just see one little thing here. Let's just open here the folder to see that we have an image. Okay. So it is like, let's just see the info.
90 kilobytes?
Yeah.
Of
it's
whale?
yeah.
Oh, it's a very large one.
It's a very large. It's 1600 per 900. Okay. So okay, let's just resize the image. It's too big for us. Okay, so just we're gonna use the FAS CLI. I'm gonna use the YAML. Okay, just because we have here. Let me close here. Just because we have a Docker file, so we pull the Alpine image, and then we just install the ImageMagick into the Docker, okay, into the container, and we need to create a YAML file, just in case, just to configure which provider we are using. In that case, we are using the FAS, the FAS UI that I already uploaded here. So I have a portal here, the FAS, okay. So I'm gonna just deploy a new action, a new Docker file into the OpenFAS portal, okay. I'm gonna use the Docker file as a language in that case. I'm gonna use the Docker file here as a handle, and we're gonna use this name, this container image name, okay, in that case. And right now we just need to, okay, YAML file, image.yaml. We need just to build, okay. So you can see that it runs a Docker build itself, okay. And then we just need to deploy. But I need to tell you guys that I already have uploaded here, so you can see the resizer. Let's just change the name, just to see that how it works. Let's just change here. Okay, we have the resizer. Let's change the think resizer here. Okay, and let's do the same process again. Just build. Again, the image. You can see that we changed the name, and then we just need to deploy. The same thing. You can see the think resizer. Okay, so let's just reload the page, and you can see the think resizer. You can test using the OpenFAS portal. It's quite simple how to test here, but I'm going to show you guys how to test on terminal.
Okay.
Just to see that it will generate the same thing, the same output, which is the same image, but 10% smaller.
Okay.
Okay. So let's just use cat here, which is the image, the image name, FAS CLI, and Evoke. Okay, you can see that is similar to IBM Cloud Functions. Think resizer. Okay, resizer, which is the name of your action, and okay, and the new name, smaller .j. Okay, that's it. Let's just check the new image here. Where it is smaller. Let's just open the info here to compare with the same, and it's smaller. Actually, it's 50% smaller.
It's much smaller.
Yeah. And you can upload now to the Cloud Object Storage, if it's the case, okay. And let's just see here. And oh, Victor, I need to change again. I want to become like 30% smaller. In that case, let's just change the code here, the Docker file. As you can see, there is a process here to convert to resize to 50% less. Let's just change to 30%, I guess. No, let's just 90%.
Oh, very small.
Okay, Yeah, smaller. So let's just do, you need to do the same process here
To build it and then
to
deploy.
build it, to deploy again. Yes, that is the same process. Okay, fast. Now let's just
Try again.
try again, and I'll add the 90. Just to know that it is a 90% smaller. Okay, and then let's just see here, 90% smaller. Oops, it is not so that small. I think,
Went the other way.
yeah,
90%
actually it's
bigger.
10% smaller.
Oh, okay.
Yeah, so in order to, if you want to change to become like actually the real 90% smaller, just change here
set to
to
10?
10%
Ah,
of the
okay.
image. Yeah, that's a trick.
I understand how the math is working now.
That's a trick here. And let do the same process again. Okay, you can see that it's simple. You don't need to worry about it. You just need to follow the steps. Okay, it will be the same if you want to build not just image match but another tool in your case, in your scenario, or if you want to create like a C++ action, because C is not so common to use. But if you're using like C++, is the same process with IBM Cloud Function. You will see that there's no secret. There is no secret. There's just a few steps that you need to do in order to create your function using Docker and Docker Swarm. I'm not using the Kubernetes right now because we need to change the gateway. I already configured the environment, so there are some few steps that I need to do to download, to configure your environment. If you want to do the complete steps, access the repository and check out here the process to download the FastCLI, and change the Docker Swarm this step here to Kubernetes. You can follow the same steps using Kubernetes, the kubectl. Okay, so yeah,
So
simple, right?
I was gonna say it looks very simple. It feels very simple.
Yeah, that's simple.
Yeah.
It's if you know how to use like create a new serverless application, like create a new actions. Oh, Victor, I want to create a chatbot, serverless chatbot. Oh, it's quite simple. If you know how to create a serverless application, serverless function, it's simple to create that using Docker, Kubernetes. Okay. And what is the difference between the Apache OpenWhisk and OpenFast? OpenFast is quite new. We have a community working on it. It's the same thing that we have for Apache OpenWhisk. But if you're more familiar with Kubernetes, I think OpenFast is a good choice to start studying more about it. You're not gonna stop just in OpenFast. You can use OpenFast, Apache OpenWhisk, the server itself. Okay, so yeah.
All right. Well, let people know how they can reach out to you if they have questions or if they're working on some of this stuff.
Yes, guys, if you need anything, if you have some question, you can reach out to me on Twitter, LinkedIn, email, Instagram. I already told you about the Instagram.
Yeah, like people reach out to you on Instagram. I think that's pretty funny.
Yeah.
Okay. Well, is there anything else you wanted to share?
No.
No, that's it.
Yeah, that's it.
All
It's
right.
simple. Yeah.
it's so simple.
Yeah.
Well, great. Victor, thanks so much for coming on. We are going to wrap up and be right back with our next guest. Thank you.
Thank you, guys. Bye.
Hello again. My name is Amara Graham, and I am joined by my friend Ryan Anderson.
Howdy.
We are super excited to be here. I think it's the last real commitment for both of us
Absolutely,
for Think,
yeah.
right? So it's like, okay, we got to get this done. But we're going to have a great conversation today. I'm going to let Ryan introduce himself and his topic.
Sure. Hi, everyone. My name is Ryan Anderson. I am based in San Francisco with IBM. I'm the architect in residence at Watson West, and I work with our Edge and Cloud team as well. And yeah, the topic today is just sort of a informal conversation. There's been an idea that we've been noodling on called character cartridges, and sort of the mental concept here is, if you imagine, I grew up in the 1980s. We used to have the Atari console systems, and we used to have these little cartridges that we plug in to play our games. And the concept of the character cartridges, what if we had avatars or sense-making systems or these other beings that you could walk up to and plug the cartridge into, and they would have variable identity. So in a VR or an AR environment, you might have an avatar you could go and unplug a cartridge and plug another one into. And it raises some interesting questions about how do you start to architect for that, and what ingredients do you need to put in to make that work. And this is on the other side of the world from chatbots that are sort of dialogue driven and very mechanical. This is starting on the other organic side.
Right.
Yeah, and it gets into some philosophical areas of theory of mind. So it's been a lot of fun, still a ton to learn. And we've learned a lot from the gaming community and folks that are designing and creating non-player characters. There's been, in some areas it's a mature field, and in some areas I think there's a lot to be had in the next decade or two.
Very, very cool. And I was joking right before we came on that on Tuesday after my AR VR talk here at Think, you had mentioned character cartridges and was I interested in getting involved? And I was like, oh, I didn't know anything about them. And I'm like, oh, now we don't have to have a meeting. We can just have it live on the internet. Very, very cool.
And for anyone that's interested, I tweeted out my Twitter handle is Ryan77Anderson. And I did, I think, hashtag character cartridges or hashtag cognitive wingman. There's some links that go into a public blog, and some of the diagrams I'm looking at here are on there if anybody is interested.
All right. Did you want to share your screen? We can bring that up live for the people.
It's pretty ugly white.
No?
I mean, you tell me. Yeah, we can, sure.
Yeah, let's do that. Sounds good. So I guess, yeah, talk me through. I mean, obviously I understand the concept of a cartridge.
Yep.
And I'm laughing because every time I hear a cartridge, I just think of how do you get it to work? You take it out, you blow in it, and then you stick it back in the system. So that's kind of why I'm over here chuckling to myself. But yeah, explain to me what the concept is, and where are we at?
Sure. So another angle that sort of informed the need for this is thinking about sort of if you're Tony Stark, Iron Man, and you've got Jarvis, or if you're Michael Knight and you're Knight Rider and you've got Kit. What would it take to start to develop and architect those systems? And systems to be authentic and to have identity, need to have a degree of empathy and emotional intelligence. And there's a lot of these sort of, there's the basic stuff, there's the basic dialogue stuff, which is we have now, so they can talk and listen. But what does it take for a system like this to have identity? What does it have? What does it require for you to want to care about it? And there's this concept of a lake test, which is if somebody came into your house and grabbed your Amazon Echo and threw it into the lake, you'd be not happy, but you wouldn't feel a sense of loss.
There's a detachment there.
Yeah,
I'm like, oh, that's fine. It's a thing. I can buy another one.
Right. But if someone came into your house and grabbed your cat and did that, you would be, or your kid, you'd be very upset about that. There would be that sense of loss. So the test for me is the lake test is, can you develop an encapsulated and embodied identity where if somebody came into your house or wherever and grabbed that and threw it into the lake, that you'd feel
like,
that same sense of loss, right? That,
yes.
And what do you need for that? Well, you need a sense of history. You would need to care about it, right? And you need to have history, and you need to believe that it cared about you. And that's one of the metrics, or sort of one of the tests here. So for these systems to be situationally aware, to reason, to understand and learn, to remember things, to have history for last week, last month. As we sort of explored this, there's the Atari. there's sort of another metaphor. So this is really ambitious stuff, and there's been some really smart people that have been thinking about this for decades. And you know, I'm learning, and I'm trying to cherry pick the choicest cuts to just get started on this. How do you begin to sort of architect? Where do you start? And one of these scenarios is imagining you're in a Unity environment.
Okay.
And you've created a beautiful green field. And in that green field, there's a brook running through, a little river,
Okay.
a data river running through it. And on the side of Data River, there's 3 humanoids.
Okay.
And you're walking up behind these humanoids on the river. And these 3 humanoids are looking at what's going past in Data River.
Okay.
Data River has barges. Meaning every 30 seconds, a new data barge goes by. And one might be a YouTube video, and one might be a tweet, and one might be
Okay.
a chapter or a bit from a book containing different sorts of content. And these 3 observers, these 3 humanoids, are observing what's going by. And you walk up and you observe the observers. You flip up the backs of their heads and you look in and you see how are they reacting? And how are they reacting differently? And ties back to the character cartridge. Imagine the first character is Tony Stark, Elon Musk hybrid.
Okay.
It's got the personality traits of that hybrid. You know, a love of rocket ships.
Right.
And
Very innovative.
Innovative, type A personality,
Yes.
assertive, and a barge goes by and it's got an article about the Chinese landing on the moon or something very positive in space and whatnot. The arousal, the interest of that embodied identity in that topic is going to be very high, and there's going to be a positive. So that has happened, and that avatar might, that embodied identity might behave differently than the one beside it.
Right.
One beside it might be an Oprah Winfrey, J.K. Rowling hybrid. And there might be different topics floating by and different, so there's a different personality type. And that's what you see sort of on the image here, is the character, the identity, the personality attributes in the black box there are effectively the character cartridge. You can see the data river in green. I'm sorry for my art. The data, the activity, the information, and then that data there's signal that's extracted. You might have a time slicer in there. It's interpreted, and each character is observing that. And then there's going to be different levels of arousal or interest by each one of those avatars as the data goes by.
Right.
You're not having any dialogue with them. All you're doing is you're just watching sort of the instrument panels in the backs of their heads. You're observing the observers, and you can let this run for a day, a week, a year, or in a million scenarios. Maybe the third avatar is a less emotional, less humanoid, and maybe it is Kit from Knight Rider, or maybe it is Jarvis from Iron Man, or modeled on.
So it's doing more of that like data processing. It's like, give me this information.
Yeah, less
let me look through
emotional.
it.
Yeah. And I'm in risk averse, right?
Right.
So Tony Stark is out there, taking on dangerous missions, and Jarvis and Kit are trying to like settle things down.
Right.
So there's different wiring in terms of things that are going to risk avoidance and whatnot. So that's sort of it at the core. This is sort of the character. The emotional state in the middle in blue is sort of the basic stuff. So at any moment in time, there might be a high level of rage or anger, an emotional state, these feelings that sort of get wired in. And we've done a little bit of work on this. It's really hard to see, and I'm sorry about that, but you can see some pictures that are in there. And just this is a very beginning Hello World baseline for this. And our hope is there's a lot of more sophisticated deep learning, machine learning tools, methods that we can start to hang off of this. That this is just sort of the beginning. And maybe folks do this in Unity in a virtual environment, or maybe in other ways. But this is sort of the nub of the character cartridges that we're looking at. So yeah.
It's very, very interesting. And I guess, other than the fact that character cartridges in general are kind of inspired by this idea of the Atari games, where did this come from, or how did you start with this idea? What was the journey to get there? What were who are you looking to enable, I guess, with this?
Well, it came, I guess, from a few sources. One is there are some great chatbots that are out there, but
Right.
often I feel that there's a little bit of an emptiness there. Yeah. So I think that brands that are looking to connect, it's about creating connections, and it's about being authentic, right? And if you can start to develop something that you really start to believe there's something on the other side of that, that's special, because we're human beings, right? That's how we foster connection. So whether it's a face in a kiosk, a humanoid face, or a digital human, I think there's many applications for that. It could be in virtual worlds, right? It could be non-player characters. There was a great article that came out a couple of months ago about a Western-themed video game, and somebody just followed one of these NPC characters around for an entire day, and like some artist, creative, and coding team had put together this very sophisticated life of the gold panner that got up in the morning and went and did it.
Right.
And the observer, maybe this is the observer, just lurked around and followed them around. It was a really nice article. I'll share it in the tweet here.
And it makes for a much more immersive experience, right? It's not just
Yeah.
kind of the classic computer player that's just kind of wandering in a circle or has
Yeah.
a very set path. It's
Yeah.
now, oh, this person has not only a personality, but they have day-to-day activities. You
Yep.
can find them in different places, in different spaces, things like that.
Yeah, and I recognize the whole gaming world. I've got a lot to learn. I've got some friends that work in that space, and there's a lot more for me to learn from them and how they've crafted it. And it's going to be interesting to see is what can we take that's already been established as sort of best practices for the gaming world,
Right.
and can we add any new points of view or perspectives, any new technologies or methods to start to pull this all together. So it's an exciting time. It's a lot of fun, and it lets you put on sort of your creative hat as well.
Of course, yeah. I think what I really like about it as, someone who's playing video games and watching other people play video games is they're not getting any smaller. We have these games that are
Mhm.
very large open worlds with a ton of different characters, and making it easier on those teams who are building those characters and making them more interesting and wanting to keep them alive or wanting to
Mhm.
interact with them.
Yep.
And a lot of the times when you're playing some of these larger games too, you're doing what's called like a fetch mission. You approach a character and they say, hey, I have a mission for
Yep,
you.
yep.
I need you to go collect something, or I need you, I'm thinking of games my husband has been playing recently. It's like, oh, I need you to go and find this this animal, this super large animal, and I need you to bring back like its teeth or something
Yeah,
like that.
yeah.
And you're like, oh, well, why should I, as this other character in this game, want to do that? What
Yeah.
is the compelling story here?
Yeah.
And there's an element of story writing that you can do to make it a little bit more interesting, or to say, oh, I do want to help this person.
Yeah.
But there's other things there too. And I think that's where some of these character cartridges come into play, where it's how do we really enhance that experience?
Yeah, and it's fun, right? It's fun to create. My kids are getting into D&D, and again, going back to the 70s and 80s. I mean, old school, they still use character sheets, right?
Right.
And it's really fun to go in there and create and develop these attributes and the backstories and whatnot. So there's a human element of creating, this identity, and that's pretty neat. Outside of sort of media and entertainment, there's also some more sort of practical and pragmatic ideas. So we've got some friends inside and outside of IBM that are working in the space of autism and other human assistive.
Okay.
And if you think about the concept of an other, the Jarvis model, of a cognitive wingman or a cognitive sidekick or a cognitive buddy, imagine what you could do with a little voice in the ear for an 8-year-old child that needs a little bit of help navigating the real world,
Right.
right? So some of the cognitive tools that exist today are great signal amplifiers for social signals. A couple of examples, the use of profanity in places where it shouldn't be
Sure.
used, or nonverbal cues. If you're looking to wrap up because you're done, and
Yeah,
this is your,
and I'm like, okay, let's do this. Yeah.
But these are today we can go and prototype these, right? If somebody checks their watch and looks to the door and starts to shuffle away, these are very measurable cues. And if you get 3 of those signals in 120 seconds, that can whisper in somebody's ear. If somebody's not really good at picking up on those signals,
Right.
that's a very basic use case about for assistive.
A
And if
gentle nudge.
Exactly. And if you start to think, what might it? So to do that, you need this embodied identity that has this degree of emotional intelligence,
Mhm.
of situational awareness. And there's a bit of back and forth here. And to have something whispering in your ear, you need to start to think, what is that identity? What is
Right.
that guide, that wingman, that assistant that might help? So there's some cases we've been thinking about, and some of them are in the blog.
I think autism is a great example because it's a spectrum, right? So it's not a one size fits all. You might need to be even more aware for certain individuals who need, who do not pick up on any of those 3 cues at all.
Yeah.
You might need less of that for someone who's like, oh, well, one of those cues reminds me to do something or to correct my behavior, but maybe I'm not looking for those other things.
Yep.
So I can see that too, where it's how do we make something that's flexible enough to
Yep.
handle everyone? And going back to your example where, you know, you have the different characters watching the
You got
river.
it. Yep.
That's what you
Yep.
want.
These
You want to
diff-
be
these
able.
different- Yeah, it's personalization at scale. Absolutely. Yeah. And then there's also this, as we start to think about these concepts of how we design the AI or the avatars, on the other side of it, you start to think about how do the avatars, or how does our code start to develop a theory about the humans it's dealing with. So let's say that you've got a meeting, you know, a situationally aware meeting room that's trying to guide the meeting in a professional environment, or back to the autism use case, you know, 5 or 6 people in the room, to start to architect things to think, you know, it's like there's 3 people here. There are different people that are interacting with my, you know, my owner, my friend, and there needs to be a way to start to architect that AI is thinking about is somebody a threat? Are they helpful? You know, is that sarcasm? Is there bullying going on? So as you start to think about, well, how do you start to code that, even at the most basic level?
Right.
And that leads to some very interesting questions as well. What matters, right?
Right.
If you could only have 10 attributes of a system trying to model counterparties, human counterparties, what 10 would you pick and why? So
That's very interesting. I'm also thinking about ways of making the virtual reality experience better. So I know virtual reality in some cases is still quite new for folks. And I know that there's been a lot of pushback from communities where, you know, you get this avatar into a room with these other avatars, and it seems like a very unpersonalized experience, kind of like when people go on the internet and they're anonymous. They feel like they're empowered to do these things that maybe they wouldn't do if their name and their face was associated with it. There's been some issues with that in VR because people feel like there's this faceless, it's just another avatar.
One size fits all.
It's kind of this one size fits all, but it's recognizing that there is a human on the other side of that, and that maybe we can put systems in place to kind of guard against that and to discourage some of that behavior where it's like, well, just because I can't see your face and I just see your avatar, would this kind of help with that? Because it's still a person on the other end.
No, to really humanize and strengthen that connection, that humanity and that kindness. I like it.
And the other thing that I wanted to point out too is there's, especially in the chatbot space, making sure that we are building things that are not necessarily tricking the human to thinking that they are human, but becoming more humanoid.
Yes.
Does that make sense?
No, absolutely, yeah.
Because I know too that there's been some technology that's come out recently where it's like, this is so much like a human, and it never identifies itself as not being a human.
No, absolutely.
And that's not the path that you want to go down.
No, it's no. I want to baby steps and coming up. No, I think if you have a hyper realistic face on the other side of it, you've got about 20 seconds within that interaction for people to figure out what level of there is there or not there. Absolutely.
Because then you have to be careful too. If they think it's a human and it's not, or it's quite deceptive, then at least for folks like me, it turns on something else where instead of being empathetic and I'm like, this is something, then I'm on high alert because I'm like, this feels like a trick. I don't like this. And back to body language, it's like, no thanks. Like, get me out.
Yeah, absolutely. So that's it. We've got a lot to learn. It's there's a lot of sort of deep reading, and I understand sort of half of what I read on some of these topics. But we're having a lot of fun on it, and it's been terrific.
So you mentioned you tweeted out some links. Are you looking for people to get involved? Do you want them to connect with you? And if so, are there individuals that you're looking for specifically that you'd want to learn? You know, are there certain areas that you want to learn more about?
Yeah, I mean, folks working in the gaming area would love to learn more. I've still got a lot to learn, and then in the human assistive types of use cases, we've got some friends that are developing some really interesting stuff that coming out probably in the next 2 or 3 weeks. Blogging about, and I'll repost those. But absolutely, if you're sort of working in those spaces and have some things to share, or reading lists, or
no,
absolutely would love to connect, DM me, or hit me up in other
Awesome.
channels. Yeah.
Is there anything else that you wanted to share while you're here?
No, I think we're good.
Awesome.
Thank you for having me.
Oh, you're very welcome. It's one less meeting that we have to have, so
Right?
that's exciting. Well, all right, we'll go ahead and wrap up. Thank you so much for being here.
It's my pleasure.
And I think I'm officially done for the day. So I am Amara Graham, and I am going to sign myself off from Twitch at Think. But there's, I think, at least 2, maybe 1 other session after. So thank you so much for watching. Bye.
Hey everybody, thank you so much for tuning in back to the IBM Twitch stream. We are here at Think 2019. We're getting ready to wrap up the day and send it on home. But before we do that, we've got a couple of talks left, and I wanted to bring some folks from GitLab to come and just kind of talk about GitLab on Kubernetes. So why don't you all introduce yourselves?
Perfect. Yeah, Brandon Young. I work on partnerships and alliances, and have spent historically originally before this. Worked a bunch on the Kubernetes, launching Kubernetes back out of its infancy. So pretty excited to see kind of where it's all come.
Cool.
Aliran Masika, partnerships, also part of Brandon's team. Been with GitLab for close to 3 years now, so a veteran, if you say.
Veteran, big time. Dan Gordon, technical marketing. Been with GitLab for almost a year. Focus on making sure that we got a good presentation of all of this great stuff.
Sweet. So what we've done is IBM and GitLab have come together, we've collaborated, and we created a workshop that we actually gave this morning here at Think. And I just kind of wanted to talk about that a little bit. Brendan, would you mind giving me the spiel on GitLab a little bit?
Sure, yeah, so history of GitLab, and Elron, you can jump in because you've lived this in a way a lot more than I have. I've lived it for 9 months, but originally we stated, we're kind of known as like the GitLab people, right? Or the private GitLab people. Private Git people, thank you. But it kind of evolved it's kind of where the company started. And then we moved down and said, we should have a CI tool. Built that out. 2 separate tools, kind of following the Unix point of view of, single tools, very sharp, very good, in their little sections, and they can be pulled together.
Do one thing well.
Do one thing well, yeah. Do one thing well, right? And as it turns out, one of the new contributors, and we believe one of the core values of GitLab is everyone can contribute. So a new person came in and said, I'm not really sure that, I think they should just be put together, to which, our founder's like, no, that's a terrible idea. They should stay separate. After many debate, tried it, talked to customers like, no, it's kind of nice how these work together. And it's just kind of snowballed from there.
Yeah.
And the more we talk to customers, the more that they really just want to write code. Yep. They really want to just make sure they can great IDE, choose your IDE, choose GitLab, choose your deployment environment, and you're off and running. And so it's one of those just iterating a lot. So kind of back to another core value, just iterate and do it really fast. And so we kind of stumbled into what is GitLab today, which is really a full single tool for really the whole dev lifecycle.
Cool.
And it's been a great journey and some really happy customers. And a lot of the market dynamics have made it even more colorful. So.
Oh yeah. Do you want to speak to that at all? Or do you want to tiptoe over that?
No, I don't need to tiptoe. I'd be very blunt.
Yeah.
If you're in a space, in the space of source code management, there's 3 players in Git, and Git's the predominant one. 3 players, 2 proprietary, 1 open source. Gets bought by another large cloud. Works really well for the one that stays. That's the only open source option that everyone else. And so that certainly was helpful.
Yeah.
Definitely.
Team did a great job already, but I would say sometimes it's good to be lucky or good. It's even better if you're lucky and good.
Yeah. I must admit that was the final thing that pushed me over the cliff to actually start adopting GitLab for just myself and my personal stuff. So.
Yeah. So what was it when you just was okay? Got to try something different. I think this is always interesting to know. What was it? Just okay. Hey. Okay. Time to look or.
Yeah.
Yeah.
Yeah, I heard about the events, what was that, 6 months ago? Something like that?
I think it's almost a year now.
Yeah.
No.
What is time? Who knows?
Anyway.
Yeah. Anyways, a while ago, some time back, and had just kind of been growing dissatisfied with that product. I didn't like messing with Travis CI. It just wasn't powerful enough for really what I wanted to do.
Mm-hmm.
And I definitely didn't want to go out and set up a Jenkins and then set up some monitoring solution and so on and so forth. You have that wonderful slide. Yeah, exactly. Now I've done my time in the Jenkins mines, and I think I speak for everyone when I say I don't really ever want to do that again. But yeah, I just happened upon GitLab, and it was just like, wow, this one tool that lets you do everything, and you can do it pretty much wherever you want, which I'd really like.
Yeah.
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 And it's completely open source. That's right up my alley. No proprietary.
Have IT license.
Monkey business.
Go forth, have fun.
Cool.
I think that's the beauty, really, with GitLab and what people are coming together to realize that more and more these days is it just makes life a lot easier and simple, and you can really focus on what you want to do and develop code, and not having to facilitate your way to be then able to start writing code.
Because not everybody wants to go futz around with infrastructure.
Exactly.
You know, like I mean that's my bread and butter. I love doing that stuff, but I mean, random developers out there aren't gonna want to go and actually do all that stuff.
But even the infrastructure aside,
Yeah.
right? Like if you want a pipeline and you want monitoring in there and you want all of the pieces to come together, to have to bring all those pieces and tweak them and make sure you got the right versions talking to the right things, and then those change and now you got to maintain it. And why do you want to spend the developer's time focusing on maintaining the tool set instead of doing coding?
Yeah.
Right? So,
yeah.
And I think the other piece is then with infrastructure having come so far, and I think that, you know, what Kubernetes has opened up is as infrastructure has gotten simpler, it's become, you know, when everything had to be managed, your infrastructure was tough and your tool code or your tool chain had a whole bunch of management to it. Everyone was like, oh, well, it's just the way it is.
Yeah. I have to run these Ansible playbooks on X number of, you know, bare metals or VMs, and that's just the way my life is.
Yeah, so it's kind of process, and then I think a lot of what Kubernetes has opened up is, wow, okay, so if I can deploy that fast and run it that fast, it's actually, we've seen a lot of that then come back upstream into the tool chain and say, you know, why do I not expect the same kind of simplicity out of my tool chain that I, you know, am now seeing in my infrastructure? And so I think in some ways those two kind of tend to be actually kind of playing off each other in a lot of our conversations. So we'll see.
Yeah, definitely. Shoot, I completely forgot the question I was going to ask you, so not a whole lot of good stuff going on there.
well, so I'll mention it.
Yeah.
Just going off what you said, it's come together really nicely, right?
Okay.
In that everyone's trying to get agile, and then everyone's going, hey, in order to get agile, I need to do CI.
Yeah.
Oh, and CD, because if I don't actually deliver it, I'm not achieving agile. And everyone's trying to do that and having challenges because of the infrastructure coordination and the different sites, and that's where DevOps starts bringing it together. And that's been going on for a while, but we haven't really fully achieved like full velocity.
Yeah.
With Kubernetes, we're starting to have that ability because it's so fast. You can actually spin it up. You can have the whole environment, all of the information captured in one place, so you can test everything at once and move that together. So it's unlocked the ability that we've been after with DevOps. So.
Yeah, and it's not just about technology. I mean, DevOps is really more of a culture philosophy, I think, at least.
Absolutely.
Yeah. And have you seen that
Culture
from your
versus
users
tool
at all?
argument.
Yeah, exactly.
Yeah.
Have you seen that marriage of culture and tooling together? Have you seen that transforming some of your users?
Oh, absolutely.
Companies?
Well, I mean,
Okay.
a lot of people are fond of saying DevOps, it's culture first, right? Which is true. But your tools have to support the culture, right? And if you're trying to do cultural change and you're using tools that don't support it, you're going upstream. So if you think about, if you have separate tools, you have your different teams in separate silos. They're in different places. They can see different things. They have different permissions for I mean, you can have permissions
They'll
different
look at
areas,
something and have
but
a
they'll
totally
look at
different
one
opinion on
thing
the
and have a
same
different
thing.
view of the same
Yep.
thing. Exactly. And so how can you have that cultural shift of everyone working together and understanding and transparency and getting towards the end goal if everybody's siloed off in their tools?
Yeah.
Right? So a tool that helps collaboration and transparency with what everyone's working on really helps the culture along.
Yeah.
So it's not about the tool, but the tool supports the cultural change.
Okay.
That's needed. So.
Cool. One of the things I've seen with some of my friends is they've been going and setting up some of their own GitLab instances. So have you seen it work for people to actually run their own GitLab rather than just go to gitlab.com and push it and use it as a source code management tool just like you would GitHub? Or
Yeah, absolutely.
Yeah?
And
Yeah.
so GitLab has was it 2/3 of the
On-prem.
private on-prem market. So
Self-managed on-prem, yeah.
So if they want to do it in, that actually kind of back to that, we kind of stumbled into it because if you look back where the company started, the company's like, it will be a SaaS offering. And it started as a SaaS offering and ended up with a number of customers, can you do it? Can we run this ourselves in self-managed? And at that time, obviously mostly behind a firewall in a data center.
Yeah.
Now, self-managed in a bunch of places, of course. So we kind of stumbled into what is another like kind of superpower for us, which is both the speed that we release. So we run the same code base for our SaaS offering as we do what ship to our customers.
Okay.
And we ship a new release every single month. 22nd, if you're interested, you're welcome. We do kickoff every 22nd of the month saying, here's a new version, here's where it goes.
Cool.
The part that was really shocking is almost half of our customers are within 3 minor releases.
Okay.
That are self-managed.
Yeah.
And so not only do they love doing it, but and some of the advantages is developers love their tools, so they tend to keep their tools reasonably up to date, more so than maybe an infrastructure only
when they can, right?
When they
If the
can.
tool allows
Yeah. So
for
we
it,
we stumbled into the business model that was okay. We're going to serve self-managed,
Mhm.
and that self-managed customer, of course, has a really high demand of wanting to be able to get the newest thing as quickly as possible.
Yeah.
And so it ended up just being a really nice self-fulfilling cycle, or self-reinforcing cycle.
Yeah.
You got to be able to ship fast, get it fast, and make sure that everyone can implement it really easily. Because if you don't literally solve all those problems, you just have code. You're like, great, we're 6 versions back. No one ever is using it.
Yep.
Different spot. And so that was actually, as a matter of fact, that kind of changed our business when we delivered a self-managed offering, and it's been really helpful for even the SaaS offering now, right? Because now it's easier to run our SaaS because we've also had to solve the same problems that a customer does.
Yeah.
And a customer can
And
trust
that'll
like,
just trickle down, for lack of a better term, down to your customers.
Right. Yeah.
Yeah.
Yeah. And then we're running the biggest GitLab instance,
Exactly.
so we know what it is, and when they have a way of doing it, it's not separate code bases. Like, well, so
Yeah.
that's not how we run it. So I hope you're working well. Like we can look and say, yeah, you're gonna hit these points at which you're gonna hit a breaking point.
Yeah.
And you can chat a little bit. I think if you have any history, I know some of this we ran into this, for example, around file storage or file service. We're like, yeah. And
that's
we
it,
can
right? If we
rebase it.
figure it out so it works at our scale for GitLab.com, then it's in the code base that everybody else has, so it's going to work for them as well, right? So everything we solve for ourselves, we solve for the customers as well.
Cool.
Yeah.
So you mentioned you were around in the heyday of when Kubernetes was first getting started. Now
Oh,
I want to
yes.
hear more about
Yeah.
that.
Okay. So at the time it was at Google, and the debate was, and to be very blunt with you, like I didn't write any of the code. There were Brendan Burns, Joe Beta, amazing team. They did the work, but when we were trying to figure out, okay, how we're going to launch it, I can go remember we managed to get an OzCon at OzCon, had a small side little venue,
Okay.
to launch it, and really was not sure where it was going to land. But remember, its heyday of we just sunset at the time. Google had what was called "Let Me Containerify That For You," really well named. I didn't name it, and the team all thought it was terrible. So everyone thought it was a bad idea, but it was descriptive. So okay.
Yeah.
Docker came along and really hit the ease of use, just nailed it.
Yep.
So Google actually just sunset it, which was great, and then but then it became well great. We know what it looks like because at the time Google still runs it all in containers. That's always had been the way.
Yeah.
They're like, you're just going to run into some challenges when people start trying to run these at scale.
Yeah.
And so internal debate. I was not in the rooms for these debates, but I know about them because I heard about them right as they came out of it. Hey, we should open source all this amazing ways you manage containers, and it was a good open debate, and to everyone's credit, decided, hey, ship that thing out there, and it was at the beginning it was definitely the overuse. So it was interesting. I think the biggest learning was initially the knock on it was too complex.
Yeah.
And the learning curve was too high.
I would say can somewhat be true now. It's a lot better now, but yeah, I've run into that a lot.
Yeah,
with some
and
people.
the knock on it was reasonable, but I think the point is distributed infrastructure is hard.
Yeah, it's not easy.
And there's some point like you really actually should know how it runs, and the fact that there's some additional layers of complexity, they're there because you're going to run into it at some point.
Yeah.
So you should know it so that when you run into it, you know why it was designed the way it was. And particularly the notion, we don't even really think of it anymore, around the notion of affinity groups and pods. Everyone's like, so why is there a pod? Just a bunch of containers, they all run on the cluster. Like, well,
I got that question today during our workshop.
'cause
So
why are they different? Why do you put a pod? Became really obvious when you started running things that needed to have strong affinity.
Yeah.
But that was a known problem, and so it got baked in. But that was believe it or not, that conversation, I think for 6-8 months was a really hotly debated discussion.
Yeah, I bet.
Which isn't even, like, doesn't really come out much anymore. And there are a
Yeah.
whole bunch of other fun stuff.
Yeah, but I'm sure the people sat around and bike shed that, until the cows came home.
Oh yeah, for sure, for sure, and rightfully so, because when
Yeah.
at first, like, no one's building, no one's doing what Chick-fil-A. Chick-fil-A literally now has a Kubernetes cluster in every single place you go. Well, no one starts there, so you don't really, like, that scale's not a scale you're trying to solve to.
Yeah.
You just want to get it shipped, and
Yeah.
so.
I want to be able to expose my web apps to the outside world, and I want to have them, all running
want
in
them
Docker
now.
containers. Yeah, exactly. And I want them now, and I want Kubernetes to keep them up and running for me.
Yes.
Yeah.
Yeah.
Cool. So, when did GitLab on top of Kubernetes get started? Were you a big
I had worked
instigator for that, or?
It was before so at the time I was at Google working with GitLab.
Okay.
I think the place it started was in Crete. So context-wise, GitLab exists in 50 plus countries, about 500 people. We have 0 offices, so no one goes into office anywhere.
Really?
Yeah, and there's a lot of really good things. There's a lot of good value out of it. But every 9 months, we still all get together. So the company gets together every 9 months in a random low-cost location. In this case, was Crete. So the team had gotten together in Crete. I was not there, so this is secondhand. So you can deal with. You should tell the story because you were there.
Happy.
You just have the bag right
I
over
think
there.
that yeah, I have the bag to prove it, but I think it really started. We were one of the first ones to really sort of go all in on Kubernetes. In the first explorations started with OpenShift, relevant or not to what we're doing here, but the first exploration started there, and then it was quickly apparent that, with GKE, what we're doing there, exploring the first sort of platform that was available in a sustainable way for us to test against, that was the first one we had chosen as a target destination.
Okay.
And it's still available today.
Yeah.
On GitLab, on GitLab.com, whatever you want to go with.
Yeah.
But at that point, that was the time where we had started to say, we believe in the way you can tie how you write your code and how you develop that in a scalable, reproducible way with Kubernetes on GitLab or with GitLab. And people at first, everyone was skeptical if this is going to really be the way to do it, or people are going to just do containers in their own sort of opinionated orchestration environments that were prolific at that time.
Yeah.
And I think obviously right now we know the bet has paid off, and we're going to more and more of integrations into all the Kubernetes environments out there today. We talked about this week a lot about the integration we have with IKS and ICP, and that's only getting more and more available across all the clouds. We want to provide that to everyone, integrating everywhere you want to go.
Yeah. And for those who don't know, IKS is the IBM Kubernetes service. That's our main public managed Kubernetes offering, and ICP is IBM Cloud Private, which is our on-prem private cloud. And that's all Kubernetes as well. So just want to clear that up.
Yes.
No, yes.
Definitely. Cool. Well, what sort of pain points did you have whenever you were first getting GitLab on top of Kubernetes? That's what I want to know. Like, what did y'all run? Because it's super easy to do now for the most part.
So yeah, I think one of the first ones. So I think as a rule of thumb with everything with GitLab, we want to simplify things, and we want to remove the manual steps.
Yeah.
So getting Helm installed and Tiller and deploying your GitLab runner and all these sort of things, we want to take that out of the equation for you to have to do as another manual step.
Yeah.
So trying to figure that out and sort of tying that back into GitLab, that was one of the first things that we wanted to tackle.
Okay.
And also getting an option to, okay, so are you tying a cluster to a repo? Are you managing it? How does it look when you have multiple repos or multiple clusters? How does that tie into your pipelines? So these were all sort of the initial scoping challenges that we had and wanted to solve to, mainly,
Does GitLab, your actual infrastructure for GitLab.com, the public site itself, does that run on top of Kubernetes at all, or is that just kind of omnibus installed into a bunch of VMs?
So it's in transition to, and maybe Dan, you want to talk about that?
Bit of info, but I believe it's Omnibus installed right now.
Yeah, it's Omnibus. It's transitioning.
I don't want to get anybody in trouble here. I was just curious.
No.
Yeah.
100% transparent about that. We write all this stuff down, and you can see how we make migrations. You can see how we made migrations, how we run it. So,
Nothing private there.
yeah. So on that one, Yeah, I mean, right now in the path of moving more to run on top of Kubernetes.
Yeah.
But it's an evolution, and certainly some of what we went down the path of is just like, well, almost any enterprise customer is going to have a monolith, and functionally GitLab's a pretty good sized monolith.
Yeah.
Which, that's okay. It's not one size fits all, and it works. It's got a whole lot of pluses that it delivers. And we'll continue to iterate over it as we always do.
Yeah. It seems like it's kind of been, microservice now a little bit.
Yeah. Yes, we certainly, everything new is thought of in that process.
Yeah. The 12-factor app came along, 10 years ago and blew everyone's minds, and it's taken a while to catch up.
Yes.
Yeah.
Yes.
Definitely.
So.
Cool.
We'll keep moving that process.
Yeah. I mean, those things.
And we'll document the heck out of it, and you guys can all look at it, and it'll be out there. So if anyone that's watching that has an opinion, please open an issue and be like, you might want to think about it this way.
Yeah.
That would be awesome.
Yeah. So you were always with Kubernetes. You never messed with like Mesosphere or anything like that.
We did actually at the same time when we were doing that, and going into Kubernetes, we were also trying to see how we can get and we got an integration going with Mesosphere, DCOS, when it was announced. I think it was like 2+ years ago.
Yeah.
So that was also live, but we were just seeing the traction going and the fit going more into what we're trying to do with Kubernetes. So that was quickly sort of identified at that time frame.
Yeah.
And everyone else is kind of shift that way. So even the DCOS integration isn't as needed because now they have a Kubernetes offering, and so that ubiquity has been awesome.
Yeah. That war has been won, and we can all just use Kubernetes as
right.
a container.
Yeah. There's a lot of other great
now.
areas to differentiate, but let's make it really dumb and simple and boring. Or I think stealing that from Joe, boring.
Yeah. It's not boring to me. I think it's super interesting, but I'm sure if I talked about it to some people, they would fall asleep.
Yes.
Yeah, definitely. Well, cool. Is there anything else you want to bring up? Anything?
No, it's just been this is a blast. So
yeah, I mean, how's your think been? I mean, we can transition into that a little bit.
It's been rain aside.
Yeah,
but you can't say like you choose San Francisco.
I've never had so much rain in San Francisco, but yeah.
No, it's been fantastic, and
is this GitLab's first thing?
Yes. Well, yes. Well, we sponsored last year, but this year we're going at it again. So it's technically second year as a sponsor, but this time more substantial sort of presence at the booth. Also, more presence also in the technical sessions, the workshops that we were part of, and more showcasing how we work together with IBM products. So you could really say that this is the first time we're going into it more full power.
Yeah, cool. Well, I've seen in GitLab you have a very good integration for the Google Kubernetes engine. Is there any plans to get any other clouds in there to have that integration right there instead of having to go and manually add your cluster in?
Yeah, we want to make it as many places as possible that a customer can you deploy your Kubernetes cluster anywhere you would like.
Yeah.
A lot of that is just continuing to work through like the automation and the fun part, honestly, a lot of times it's like the account creation and the connections of stuff.
Yep.
Like it sounds like, oh, no big deal, but if you really want it to be a really seamless experience, a lot of work to make that fit.
Yeah, it's devils in the details for sure.
But that's certainly where we're headed. Certainly looking forward to the notion of where, operators are going. Helm version 3, which will just making updates more important. So clearly deploying once is nice. Updating really important.
Yep.
And so I think Helm 3 is going to up that game. There's a bunch of stuff coming through operators that came out of CoreOS now with Red Hat that have a lot of promise.
Okay.
Those certainly help make it regular, because certainly if you're going to tie it to a managed service, you want to make sure that everything else can be updated on it.
Yeah.
Right. So it's great that the cluster's there. It's great the cluster's updated, but you got to be able to do that also to the GitLab instance as well.
Yeah.
So ton of fun work there, and it's coming together really pretty quickly.
Cool.
So pretty excited, and that would be it's on our list of really interesting things.
Oh, I'm sure that list is like a million miles.
No, I think we're going to see that. We're going to see more of that in 2019 for sure.
Yes.
More of those seamless integrations into cloud vendors that are running Kubernetes services, managed services for sure.
Okay, cool. Well, hey, I mean, we would love to have that integration here at IBM. I mean, we were second to market with our managed Kubernetes, public managed Kubernetes offering. So
Yeah.
I mean, why should we not be up there? We were right behind Google, so we should be
It's
second on GitLab.
second on-
I'm okay with that.
Okay.
Yeah.
We'll work
We
on
can
it.
do that.
All right. You have my email.
I
We
do.
didn't, we didn't
Yes,
see
we
that
do.
coming at all either.
No.
Cool. Well, I mean, I don't really have a whole lot of other questions to go to, so yeah, let's go ahead and wrap it up right now. So, anyways, we're getting ready. We're gonna have one more session with Mr. Greg Haynes. He's an IBMer. We're gonna be talking about Knative. But thank you so much for coming. I
Yeah.
really appreciate it.
Actually, the Knative's good. If you like Knative, you want to write your application, deploy it into that world.
Yep.
We released Knative with serverless for GitLab.
Cool.
So NStream on that too also is another
Yeah.
interesting endpoint.
How long ago did you do that? Because Knative.
We
was
did that.
two
We did that. We released it in December.
Yeah.
So that's 2 releases. So
Okay.
yeah, very new to us still.
Definitely.
So
It's new to
same
everybody.
thing for everyone. Use it. Please give us feedback. It's obviously early, but goal is same thing.
Yeah.
Try and make it easy for you to write a serverless application and or instance and deploy it anywhere.
Cool.
Yeah. So.
All right.
More
well-
work to do. That's on our other list. We should also work on that one.
Yeah.
In more detail too.
Okay, cool.
Okay.
Sounds good. All right. Well, we're going to go ahead and go on a break, and we'll be back in just a few minutes. So stay tuned.
Hi everyone, welcome back to the IBM Developer Twitch. We are streaming live from Think 2019. I'm Spencer Crum, back again. This is our last session, so thanks for sticking with us for these 2 days. My guest is Greg Haynes.
Hey, yeah, so I'm here to talk about Knative today. And I guess we had a stream earlier who kind of did a little bit about Knative, and I'm going to hope to go a little bit deeper, talk about some of the technical details of what goes on in Knative. But just to get started, I guess we should talk a little bit about what Knative is. It's an application platform that's supposed to build on top of Kubernetes and Istio. So at the end of the day, the idea is we're going to extend Kubernetes, provide it more features, turn it into a serverless platform itself. It's a little bit different than other serverless platforms you might be used to, like Lambda,
Google Cloud Functions,
Google Cloud
OpenWhisk,
Functions, yeah. It's not really saying you should take your application, redesign it wholesale, stick it on this special serverless platform. What we're trying to say is, if you're a Kubernetes user, we're going to go ahead and extend Kubernetes, provide it more features, and provide serverless functionality built into Kubernetes itself.
So this is not a crazy new idea, right? Kubeless and a handful of other projects have sprung up in the last few years trying to add something serverless-y into your Kubernetes cluster.
Yeah, Kubeless is probably the most notable of those examples. And funny enough, the Kubeless maintainers are now Knative developers.
Yeah.
But yeah, it's sort of the natural progression as people have figured out Kubernetes better, figured out serverless better, and kind of like where you want to end up while you're doing this. Knative is kind of that next iteration, and really what it gets down to is a CRD concept.
Do you want to take us through that?
Yeah. So when you think about Kubernetes, you think about these certain types of resources. You think about pods, you think about services, these sort of core building blocks that are part of Kubernetes. When you're a user, generally what you're doing is you're creating these resources and then mutating them and watching them go through various states. So you create a pod, you create a deployment, which might create pods, and you create a service to talk to them, et cetera.
And then Kubernetes on the back end is just kind of a control loop. It's like, this is what I was asked to make. This is the reality. Do I have to make any changes? Yes, no.
Yeah, exactly. It's trying to realize those resources in whatever way it sees fit. So after a while, after Kubernetes has been around for a little bit, it was realized, well, people want to, this is a more fundamental concept than just pods and deployments and things that Kubernetes provides. You can actually go ahead and extend Kubernetes by creating your own resources. And it's a thing that application platforms sort of naturally want to do. So a great example is Istio is sort of one of the main things that everyone's been involved with and has heard about. Istio at its core is really about providing these resources on Kubernetes. It provides what's called a virtual service, which is how applications can talk with one another. In Knative, what we're doing is the same idea. We're creating a new type of, we call it a K service, revisions, routes, configurations, and these sort of tools that let people create these resources in Kubernetes and then use it as a serverless platform.
Got it.
Yeah, and so what I'm going to hope to show you today is we're going to create an example application, play with it a little bit, and kind of show you the resources that Knative creates and that you, as a user, interact with.
Yeah. So one of the things that I really want to hear your definition of, I've said it a couple times on the stream, but scale to zero.
Yeah.
Is a topic. Can you just give a rough definition of that and why it matters?
Yeah. One of the main things that serverless aimed to provide was true zero cost when you're not using your application, right? So I have my web service out there, and maybe during the night, absolutely no one's using it. Literally nobody. It'd be great if I wasn't paying for it at all and it wasn't running anywhere. And then when somebody came in to use it, I started the app. And that's sort of what the main idea with scale to zero. It's if no one's using your app, it's literally gone. It is scaled to zero. And then when we get a request to your app, you start it back up, run as much as you need to serve requests that are coming in.
Right.
Great. So let's go ahead and get started. This is just a terminal where I've installed Knative, I've installed Istio, and I have a Kubernetes client installed. So I can do things like get pods. I don't have any currently created. And what I've got here is an example Hello World application for Knative. Let's start by showing you this application. It's extremely simple. It's a Go application. If you don't really know Go, it's not that important, but essentially all it's going to do is listen on port 8080, what's defined here. Oops. And also here it's calling HTTP listen and serve. It's going to listen on port 8080, and then this handler function up here gets a request whenever one comes in, and it reads an environment variable called target, and then it will print out to the user hello whatever's in that target environment variable.
Okay.
So it's extremely rudimentary hello world application.
Pretty, and it looks like it's doing some, oh yeah, and if target isn't defined, it's just hello world. Gotcha.
Yep, exactly. And one thing to note here, listening on port 8080, this is sort of the entire Knative interface here. It's create an application, have it listen on port 8080 for requests, and then we do all the auto scaling and scale to 0 for you. So as long as you have some type of application that can serve HTTP requests in port 8080, you can run it in Knative just fine.
Got it. But that is sort of hard-coded right now?
No, it's actually configurable.
Okay.
I don't remember off the top of my head what the parameters, but it is now. Recent addition. So the way, sort of like with Kubernetes, where you have YAML definitions to define things, Knative, because we are CRDs, you have the same type of YAML definitions to define things. And this is the K-service definition, which is the most basic way you define an application in Kubernetes.
Yeah, and so don't be, for anybody who's like, wait a minute, that kind service does say that, but this is the Knative version of a service, and it is not the service you're familiar with if you're already a Kubernetes user.
Yeah, it's certainly an unfortunate choice of name that there's a Kubernetes service. But and it's namespaced up top with API version to say it's Knative, but yeah, I'll try to say K-service.
Yeah, Fallout, differentiate. Everyone disliked that.
Yep. We've talked about just calling it like Joe. So within this definition, what we have here is called run latest. And this is just part of the service spec. And what it's saying is whenever you update your application, if you're using run latest, we will send all traffic to the newest version of your application. So if I go and edit this environment variable here, target, and then I apply that when it's created, Knative is going to go, okay, well, there's a new version. I'm going to wait for it to come up and be healthy. And as soon as it is, I'm going to send all traffic over to that version of the application. The reason that it's special, and why run latest is some key thing here, is we support more advanced features like alpha, beta deployments, things like that.
A little blue-green, rollback, that kind of stuff.
Exactly.
Yeah.
But we're going to be simple for now. We're just going to always send traffic to the latest revision. Inside of here, we have this container definition. This is the same definition as when you're defining a pod in Kubernetes.
Okay.
Yeah, there's a container, and it's literally identical. So if you have a Kubernetes pod definition, you can just take the container definition out and plop it here, and it should work.
And this is like one of the things that separates, you know, just to steal your thunder a little bit, this is one of the things that separates Knative from something like, you know, my cloud platform's functions as a service, right? Is that you probably already have some amount of complexity in those container definitions, whether it's mounting some storage or pulling some secrets out of somewhere or something like that. And not only can this run, you know, part and parcel right next to the existing microservices that you have, but you can express all that functionality in an environment that has scaled to 0.
Yep, exactly. We're able to sort of try and bridge the gap, as I like to say. You know, we're trying to not just say rewrite your application to be a 12-factor node app.
But you should.
Yes. If you are living in the world where you've got Kubernetes, we're going to try and meet you in the middle a little bit, make your life easier.
Right.
So within here, we have this image definition, and same thing with Knative. Like I said, this container definition is straight from what Kubernetes wants you to define as a container. So the image and env are the really only two components of this. Image is a Docker image, just like in Knative. And env, right here, is an environment variable, which, if you remember from a minute ago, we were saying the Go application reads from an environment variable to print out. And so we have in here Go sample v1 as our target. So the application should respond with us, hello, Go sample v1.
Right.
Great. So we're going to go ahead and define it. I'm going to have to do a little magic here and just say, don't worry about the fact that I'm using this KO command.
I wasn't going to call you on it. We've talked about that enough on Twitch.
Yeah. For all intents and purposes, it's kubectl. And just all right, so this created the service.yaml definition. So if I kubectl get kservice, which is a short string for service, it shows we find this Hello World Go application. It gives us a domain, which is an important detail. And it also gives us a latest revision, et cetera. But it's defined our application here.
So this is essentially like function list or something like that.
Yeah, exactly.
Okay.
It's listing the applications you've created.
Right.
if you also call get pods, you can see Hello World Go deployment. So there's a pod that's been created as part of us applying this application.
With 3 containers in it.
Yeah, that's because we're using Istio, and then Knative adds its own container in front of it for doing load balancing and proxying. So yeah, we've got an application running right now, and we should be able to run curl. I'm going to go ahead and run this quick while it's still running, and then talk about it. So this command, I have this -h host helloworldgoexample.com. This is only because I haven't gone through the trouble of actually configuring DNS properly, so we have to act as if we did. It supports applications just like any other production service where you can define the domain name that your application will use, and it will just work fine. But for demonstrations, you'll see most of our docs say curl-h hosts to request the app directly. And you can see that our application responded, Hello World Go sample v1, just fine. So I'm going to do another...
Good job, application.
Yeah.
Good job, Knative.
Yeah, we deployed a serverless app.
Damn. That's all. Take those raises.
Time to go home.
Yep.
So something I'm going to show you here is one of the neat things that we get by building on top of Istio and Kubernetes is out of the box. This is Zipkin right here. And out of the box, because we're using Istio supports tracing and sort of advanced debugging and observability concepts. And that's kind of the whole point of this. Let's build upon existing foundational components is we get to leverage all the things that have been built to use them. So what we're looking at right here is sort of the request path from when a request comes in. When we're doing this curl to our application, we hit our Istio ingress gateway. And if you know about Kubernetes, ingress gateways are generally what you do to define the front end, the load balancer.
Yeah, it's sort of your, the word blood-brain barrier is overused, but yeah, if you just create services in Kubernetes, your microservices, you sort of, there's a natural flow where you have a lot of east-west traffic between microservices that are not externally facing, and then for your handful of actual front doors, you use something like Kubernetes ingress.
Yeah, exactly. And because we're using Istio actually defines its own ingress gateway, but same idea. It's the very front end. And so our request, the curl request we made, first thing it did is it came in and it hit this Istio ingress gateway. Then it went connected directly to our application, Hello World Go 001. That finished eventually, right here, after a couple milliseconds, and then the load balancer request finished. So you can kind of watch this request flow. It's not super interesting because our app's already running, and ideally it's not supposed to be interesting because you just want your app to serve the request.
Wants work, man.
Yeah, exactly. But then so if we go watch here, let's wait a little bit. There we go. You see our application just started terminating. And this is when we get into the scale to zero functionality. So no one's been requesting here. I made my couple curls and I stopped for a while. Knative is going, okay, well, your application's not used. Let's scale it down so it's not running anymore. One of the big questions then is if your app's not running, where does the request go? It's got to go somewhere. You can't just say, hey, internet, hold off on that. Send it to me later. I'll spin up the app in the background.
HTTP 420, enhance your column.
Yep. So great. It's terminated down. It's not running anymore. So I'm going to do this curl to our application now. It takes a little bit while longer, but it's not failing. I'm a user. I'm just saying, oh, it's taking a little bit longer. Otherwise, it's all. But then it responds. If you show the get pods, another pod's running, so we scaled one back up.
With a different ID?
Yeah, that'll be a different ID. But the really interesting thing here is then we can go in Istio and see what happened. We've got this sort of complicated span here, right? And the scale from 0 case ends up being a lot more complicated. But my goal here isn't necessarily to say, like, hey, you need to understand all of this in detail to use Knative, because you don't. What's great here is that because we're leveraging these underlying concepts, underlying frameworks like Istio and Kubernetes, if you're an operator of Knative or if you're a developer, you have this tooling that you should be familiar with from other applications.
Right. Well, the really cool part of, the 10-second shill for Istio is basically it's going to watch because of the way it does some proxies, it's going to watch every request go through a bunch of sidecars. And that means you get this kind of, you write once this sort of instrumentation around requests, and then whatever your app is instrumented for free. So the big win there is something that you just started dealing with, like a Knative. And the second thing, especially for more established companies, is your polyglot infrastructure, where you have some Node over here and some PHP and some Java. Writing metrics and instrumentation code in all three of those languages for all three of, for your multitude of apps is like more work than just kind of handing it off to a smart platform like Istio.
Yep, exactly. And so what's even nicer, in my opinion, is when you start using something like Knative, which integrates with Istio, you're then not only getting that benefit you do on your application, where you've got your applications in multiple languages, and they all still have the same tracing and observability components. You get that all the way down through the infrastructure layer.
Right.
And often, it's like nobody ever has to debug infrastructure problems. Right? Like when those problems show up, you can then see how they pass through the infrastructure layers where they happen.
Yeah. Yes. Just having dark memories of why disk's slow, Spencer. It's like, well, network attached storage is the thing, everybody.
Yeah, exactly. And so kind of I'm going to walk through this a little bit just because it's an interesting thing to understand. But if you go to this top layer here, we've got the same thing where, the request came in, it hit our Istio Ingress Gateway, but then it went off to this activator service. It didn't go to our application, which is what it showed before. And we see here, before the activator stops, 6.3 seconds. So there's a lot of work happening underneath here, and that's really the application spinning up to serve the request. And then eventually the outer load balancer finishes as well. So I want to kind of walk through what activator is and how it works. So we go and hit this activator service, and what it is Knative itself runs a Go reverse proxy called activator. And whenever your application scales to 0, we tell Istio, with the virtual service, we say, hey, all requests for this application now go to the activator.
Okay.
And the activator just stands there and it takes reverse proxy, or it takes a HTTP request for anybody. So we did a curl, we came in, we hit the activator, and the request is just sitting there. The activator then goes and reaches out to the rest of Knative and says, hey, this application.
Yeah.
Make it happen. We need to serve a request.
On.
Exactly. So that goes and happens in the background. The activator holds on to the connection, and that's really what we're seeing right here, this active endpoint. This is a flag where the activator is saying, hey, this endpoint for this application, Knative, please make it available so I can go talk to it. Right about here, we're seeing Knative go, okay, well, revision, which is a CRD that Knative provides, saying make this revision available. And then within here and here, this is basically time where we're waiting for Kubernetes to start scaling up the deployment and basically say, hey, deployment, your replica count is now 1.
Mm-hmm.
One of the neat things here is when I'm saying deployment replica count of 1. In theory, if you're a big Kubernetes user, you should know what that means. And so like that I can kind of stop describing like, all right, below the scenes, that's just Kubernetes doing its magic. We're just upping the replica count for a deployment.
Right. All you're doing is modifying that not even custom resource definition, just a resource.
Yep, exactly.
Yeah.
Then within here, we get to see Istio doing its magic. And eventually when the app comes up, which is going to be here at the end, we start processing a request and send it back to the user.
So the activator just holds the request in RAM?
Yeah, it just holds on to that TCP connection and then waits to forward it. Yeah.
Okay, so is there remind me of my TCP, like did you send your data through, or is it more like we leave the TCP like in a temporary open?
It's a fully established TCP connection, yeah, and the client has sent the request at that point. And it has to, because the way, when I said before, we just take requests for anybody. If you're running multiple apps, there's one activator service only. So we have to have a way to know, like, this request came in for app Hello World Go, maybe this other request came in for app B.
So at the minimum, you have to read that host header.
Exactly.
Okay, cool.
And that's what tells us what application we need to go scale up. We're reading that host header. So to go and show, if we want to dive in a little bit into Istio stuff here.
Always.
Yeah, so virtual servers, as I mentioned before, is Istio's, it's the main thing you use to control Istio's mesh, right? When you create a service, you create a virtual service, which then lets you sort of say like, hey, these requests to this domain, here's the application to send them to. And it's sort of the config language for the mesh at the end of the day. It's a great way to think about it. And when we created our application here, Hello World Go, we created this route right here, which just has a unique ID, but this is the virtual service for application. So if we go and do a -o YAML here, you can go see the way, which is printing out the whole virtual service. You can see here, to know it's for our application, we just put a label inside of this virtual service to say it's for Hello World Go.
Mm-hmm.
And this is a bunch of Istio stuff that's not particularly interesting. The really interesting thing I wanted to point out is this destination line, right? So right now, if you see the route destination host is activator service.knative serving.
Okay, so that's going to be that destination until the activator is satisfied that the service is actually up, and then it'll go into the virtual service and change the Change the host destination?
Yep, exactly.
Awesome.
Yeah, so the whole idea is, we hit the ingress gateway first. The ingress gateway is putting us onto this STO mesh. At that point, it's going to resolve whatever the destination is supposed to be for that route. And yep.
Awesome.
When it's scaled to 0, straight to the activator. And so what we can do here, we should be able to watch this service. And then in this other screen over here, do our curl.
Okay, and we're watching that host line?
Yeah. It should show that this host line gets changed as soon as that service comes up. Woo.
Oh.
Yeah, we just saw it pop up, and host is now Hello World Go. So that means new requests that hit the ingress gateway go directly to our app.
Oh, cool.
So if we do the same
bypassing
curl,
the activator all the way. Yeah. Okay.
Responds immediately.
And if we wanted to, we go into Zipkin and prove it that it didn't hit the activator at all. It just went
exactly.
straight.
Let's go check that out right now.
So it's actually one of these cute proxies where it's not in the way and just fast. It actually physically is out of the way. I mean, physically is a bad word, but it's fun. It's not in the path.
Yeah, exactly. Actually, let's go. Oops. Sorry, what goes on is there's a lot of Istio traffic going on, so you have to do a lot of, to set the limit high so that, here we go. This is the one that just came in that isn't even touching the rest of the network.
Yeah, it's just bup. Yeah, cool.
Yeah.
Very interesting stuff.
Yeah, so any other questions or stuff you want to chat about? Because I can go into updating the app next. It's probably a neat thing to do.
Yeah, let's do that quickly. I don't know if the chat has any questions about Knative, but they're not saying anything yet. So.
Yeah, and I also have to say that if anybody does have questions or stuff and you're at Think, there'll be office hours about Knative immediately after this. If you come over to the tabletop tab house. All right, so let's go look at our application real quick. Service.yaml. So as I mentioned before, this environment variable is what actually the application reads this environment variable and prints it out in response to a user.
Okay.
So let's go ahead and update this and make a v2 of our application.
All right.
What this is going to do, before I do this, I'm going to explain a little bit about what's going to go on. In Knative, we have this concept of configuration and revisions. And configuration, you think of as being your application. And then a revision is an immutable point in time of your application. So every time you make any change, whether it's a new image, an environment variable, anything like that, it makes a new revision.
Right, because all you've done now is actually change the definition. You haven't changed the code.
Yep, exactly.
All right.
Yeah, and so that's still going to create a new revision. So you think of it sort of like git commits,
Yeah.
right? And we're tying together the configuration and the application into one git commit every single time you make a change.
Yeah, and every sufficiently complicated build system for deploying to production it has this, we need to grab the images from design, and we need to grab all the configuration variables and the code and put it all into one big deployment artifact.
Yep.
And hopefully it works.
Deployment number. Yeah, exactly. And so if we do kubectl get rev, we'll see we have hello world go, a bunch of zeros and a 1, which is the first revision.
Got it.
And so if I go ahead and apply this change I made, we should see Kubernetes make, or Knative make a new revision for us. We'll do this. You see, we have...
So now we have a 2.
Yep, and it's saying it's deploying. Well, something else you'll see. We have a new set of pods, O2 here. Our old revision has scaled to 0, so those pods are no longer here.
Naturally.
The other thing we should see, if we go back to our get virtual service, destination is now Hello World Go 002. So it's pointing to this new version of our application. So let's go ahead and do our curl here in Hello World Go sample v2.
Hey!
Yeah, exactly.
So it's that easy, and then just like with a Helm or something, you kind of have your list of revisions. I assume there's sort of a rollback and...
Yeah, if you want to get advanced, we actually have the route itself is exposed. So call get route was another CRD you expose. And within here, you can go ahead and make new routes, or you can modify existing routes. Before I said we're using this run latest component, and that manages the route for you automatically.
Okay.
But if you wanted to get more advanced, let's go ahead and do... If you want to get more advanced, you can go in here and set... where is it at? So right here it says traffic configuration name Hello World Go and %100.
Okay.
You can go ahead and you can specify revision names in different percentages or different configurations and percentages.
And that
so
just probably rolls into the weights on your virtual service on Istio.
Exactly. It's just writing that straight down to Istio and letting it do it for us.
Yeah. And so this gives you the opportunity to do what's pretty common, which is send 1% of your traffic to the new version of the website.
Yep.
And then read the logs and wait for the screams.
Yep, exactly. And we also have tooling built into that service itself. I'm not sure how much detail I can go into off the top of my head, but basically we have, it's called rollout percentages, and we have definitions in there that says, okay, well, when I do an update, maybe only roll it out 1% of the app. And then, you can watch your logs for an hour or so, see if there's any problems, and if so, then you can go ahead and manually say, okay, move all the traffic over, increase it, etc.
Awesome. Yeah, that kind of like safety and deployment is like a big part of like why everyone is moving towards cloud native application architecture. So.
Yep, and as far as I know, it's surprising. It's been sort of missing from serverless as a whole, because a lot of serverless seems to be built around, write your application, just push it, it's running.
Well, and I think that despite the hype, I think most organizations are sort of using serverless as the place for the greenfield, like the super greenfield, and arguably not the core, the business, the moneymaker of the app. It's the the preferences page or something like that, personalization settings, or some people are using it to offload, we talked about this earlier, but offloading some of that ETL at the end, the batch jobs at the end of the night, stuff like that. Yep.
Yeah, and it's stuff that you can kind of wake up in the morning and go, oh, that didn't work out. Let me try it again.
Yeah. It's also nice because you can run it in parallel with your serverless and your existing, dumb Postgres Zapier indexer, and then compare results to make sure that the new version is, nominally.
Yeah. And so this whole, and really what it comes down to me is this revisions concept. It's neat that it's forcing you into this whole, I've made a modification, I have a new immutable point in time of my application, which even if you're not using this advanced routing or advanced, A/B deployments, you can still roll back. And that is something I know would terrify me in many serverless platforms. I didn't have an easy way to say, oh, I did the thing, let me undo it.
Yeah, well, and that's the difference. There's two big buckets of serverless, right? There's a vendor and some magic, or there's I've built my entire pile of infrastructure myself, right? And they're both bad for different reasons.
Yeah, for sure.
They're certainly out on the edge of a lot of, you're standing, this is Knative on top of Istio, on top of Kubernetes. So there's a lot of digging into the layers there to understand why something is failing, or even understanding an error message that's popped up to the top.
Yeah, and so try to make it as easy as we can, right? And it isn't. All I can think about right now is our choice of service for the application. We certainly could have made it easier there, but overall, leveraging these lower layers that everyone uses, that's probably, in my experience, one of the best ways to make it less complicated for operators, is giving them something they already are familiar with, running, and they also understand the language of. So.
Yeah, absolutely. Okay, Greg, was there anything else you wanted to show us about Knative?
No, not really.
So for those who are interested in getting more of the source code, or maybe checking out the community, what kind of resources are available?
Yeah, so we have a Slack and we have a GitHub. Our GitHub is just Knative. And on there's a docs repo that has all sorts of information, as well as our code itself. I know we have a blog post that recently came out on IBM Developer about Knative and sort of what it is, why you should use it, and it kind of really goes into a good high-level overview of these different CRDs, of configuration, route, and so on.
Right.
Other than that, Slack, and there's a Google group. We're all really friendly. Feel free to reach out to us anytime.
We also have a video from our own Cy Venom, who did the fancy light board, taking you through Knative in just a couple minutes if you want to learn more. And this is very exciting. We probably should have led with this. Announced at Think, IBM has a Knative managed for you by IBM that's in the experimental phase. So if you have an IKS cluster, you can just go to your console right now and press Add Knative or Add Istio to my cluster, and then you can start playing with it. The details of that are, you have to read your own details and stuff, but the general idea is that IBM is going to manage the life cycle of that installation. So they will upgrade Knative and they will upgrade Istio for you, so you can just get on to writing applications.
Yeah, it's really slick. We did that in our tutorial today. It's one command, cluster add-on enable, and you have a Knative in your IKS.
That's really awesome. It's awesome to see that. So what we're going to do is we're going to actually sign off here, finally. Thanks so much for being with us on the Twitch process. We're having a great time. We're going to try to keep it going when we're not at events, with regular broadcasts on Fridays and maybe other days in the week. We're very much interested in your feedback around what kind of content you like to see. Is it more live coding? Is it more talking? Is it machine learning, Python, JavaScript, cloud native? What is interesting to you? We're happy to find those people. IBM has 400,000 of our best friends working there, so you can always find interesting people for the Twitch stream. And just thanks so much for being with us. We've had a great time. And yeah, I think we're going to host somebody. And thanks again.
Yeah, thank you.